Okay, students. So I hope all of you are doing well. This is a complete revision guide 0 to 100 of both syllabuses IGCSE and O levels, IGCSE 0625 and O levels 5054. If you can watch this video completely, I guarantee you a grade above B or at least a B. And while you are watching this video, I want you to keep your phones away, watch it preferably on a laptop or a PC, and grab a pen and a register to make notes. Timestamps are also marked in the description, and if you can just pay attention for the next 3 to 3.5 hours, believe me, your entire physics ka grade will change. Also, the guest paper for IGCSE and O levels physics will be posted one day before the examinations. Chalo. Let's start with our revision. First of all, first of all, if you come here, and these notes are also linked in the description. These notes are also linked in the description. First of all, in both IGCSE and O levels, you need to know how to measure length. You need to know how to measure length. If you have straight surfaces and the length is less than or equal to 1, you will be using a meter rule. However, if you have curved surfaces and the distance is greater than 1 meter, you will be using a measuring tape. Now, since this video is for both IGCSE and O levels, I have marked कि कौन से topics सिर्फ O levels में, like the topic of micrometer. The topic of micrometer is not in IGCSE, it is only in O levels. So IGCSE students can skip to the next part. I have marked the timestamps as well. Okay. Now, whenever you have to measure a small lengths, what do you use? You use a micrometer. Micrometer पे we have two sort of scales, main scale and a thimble scale. Perfect. Each division, each division on the main scale represents what? 0.5 millimeter. Each division on the main scale represents what? 0.5 millimeter. Sir, what do you mean by that? By this I basically mean Okay, so what do I mean by that? By that I mean that on this main scale, each division represents what? 0.5 millimeter. If this is 0, this will be 0.5, this will be 1, this will be 1.5, 2, 2.5, 3, this will be 3.5, this will be 4, this will be 4.5, this is 5. So each line on the main scale represents what? 0.5 millimeter. Okay, so how do you have to take the main scale reading? Easy peasy. This will be 5.5, this will be 6, this will be 6.5, this will be 7, this will be 7.5. If I can mark it here, this line will be 7.5, this will be 8, this is 8.5. So basically, on the main scale reading, you take the last line. On the main scale reading, beta, you take the last line. You always take the last line on the main scale reading. In this scenario, the last line is of 8.5 millimeter. So the main scale reading becomes what? The main scale reading becomes this. Main scale is equals to 8.5 millimeter. Now, how are you going to take the reading of the thimble scale? How are you going to take the reading of the thimble scale? Always remember, each division on the thimble scale represents what? 0.001 millimeter. Each division on the thimble scale represents 0.01 millimeter. Perfect. You will go here and look for a line on the thimble scale that coincides with the main scale. On the thimble scale, beta, you will look for a line that coincides with the main scale. Here you can see that line 20 is coinciding with the main scale. So what will the thimble scale reading be? The thimble scale reading be what? Beta, thimble scale की reading क्या हो जाएगी? You have the 20th line coinciding with the main scale. 20 multiplied by 0.01, this comes out to be 0.2 millimeter. Perfect. Now you can add this. You can say the thimble scale reading is 0.2 millimeter. What will be your total reading? Total reading is 8.5 plus 0.2, that is 8.7 millimeters. Simple as that. Let's try out on another micrometer question. Let's try out here as well. Can you see? Can you see? We have again main scale and a thimble scale. Okay. So let's say this is 5, this is 5.5, this is 6, this is 6.5. Let me write it. 5.5, 6, 6.5, 7. This will be what? 7.5. So the main scale reading is what? Main scale is equals to 7.5 millimeter. Perfect. What is the thimble scale reading? If you analyze 20, 21, 22, 23, and the 24th line is coinciding with the main scale. What will be the thimble scale reading? Thimble scale reading क्या होगी बेटा? 24 into 0.01. This comes out to be 0.24 millimeter. Can you calculate the total reading? Yep, easy peasy. Add both of them. Total is equals to 7.5 plus 0.24. This comes out to be 7.74 millimeter. Simple as that, nothing complicated. Now, the next parts are in IGCSE and O levels both. So let's start again. Now, how to measure the volume of an irregular solid? Yeah, how to measure the volume of an irregular solid using a measuring cylinder? Very, very, very easy. First of all, always remember that whenever you have a measuring cylinder, you always read the bottom meniscus. Now, what do I mean by that? If you have this sort of a reading in your measuring cylinder, you will always read this bottom meniscus here. Bottom meniscus. This reading comes out to be what? 68. This is 67. Perfect. Okay, let's see how to measure the volume of any irregularly shaped object using a measuring cylinder. This method is also known as measuring volume of a solid by displacement. Perfect. How can you measure the volume of an irregular solid using this method? First of all, you take a measuring cylinder and fill it with water up to a specific point. Let's say here the first measuring cylinder is filled with water up to 200 ml. Perfect. Then what will you do? Then you will immerse the stone inside the cylinder like this. Then you will immerse the stone inside the cylinder like this. Your volume increases to 270. The difference between the two volumes gives you the volume of the rock. The difference between the two volumes gives you the volume of the rock. So if you have to measure volume of a solid by displacement, what will you do? First of all, measure the initial volume of water in the measuring cylinder, add the stone, measure the final volume, calculate the difference in volume to calculate the volume of the rock. Perfect. Now for measuring time, we have two apparatus in IGCSE and O-level, digital and analog stopwatches. Nothing complicated here. Now this is something that I need to stress out. In both O levels and IGCSE, whenever you have to measure small dimensions, such as time period of the pendulum, thickness of a paper sheet, whenever you have to measure small dimensions, you apply this format. You measure the thickness of 100 sheets, let's say, because we have to measure the thickness of one sheet here. So what we will do? We will not measure the thickness of one sheet. Whenever you have to measure a small dimension such as thickness of one sheet or the time period of a pendulum, this method will be applied in IGCSE and O levels. Let's say we have to measure the thickness of one sheet. Okay, that's a very small dimension. We cannot directly measure the thickness of one sheet. What will we do instead? We will measure the thickness of 100 sheets together. Perfect. Like this. Let's say these are 100 sheets. So we will measure the thickness of 100 sheets together like this. Perfect. Then you will divide this thickness by 100 to get the thickness of one sheet. You will divide the thickness of 100 sheets by 100 to get the thickness of one sheet. Perfect. And the last step. You will repeat the process and take average. By this, what do I mean? By this, I mean that you will take multiple readings of the thickness of the 100 sheets. You will take multiple readings of the thickness of the 100 sheets. Let's say this is T1, T2, T3. You have taken multiple readings of the thickness of the 100 sheets. Then you will average them out. divided by 100 to get the thickness of one sheet. So this is the appropriate method to calculate small dimensions. What do? You measure the thickness of 100 sheets together. Then you measure the thickness of 100 sheets multiple times. Take the average of all those, divide it by 100 to get the thickness of one sheet. Simple. Let's further move ahead. Okay, what are scalar quantities? What are vector quantities? Scalar quantities are those quantities which only have a magnitude. What are some example of scalar quantities? Distance, speed, time, mass, energy, and temperature. What are vector quantities? Vector quantities have a magnitude and direction. What are some example of vector quantities? Apologies, I have written it incorrect here. What are the examples of some vector quantities? Force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Perfect. Now, this is a topic that is in both O levels and IGCSE as well. So please pay attention. Most of the IG students think that this is not in their syllabus, but they should check out Unit 1.1 last point. Now, let's say you have two vectors, 3 Newton and 4 Newton. They are acting at a point. They are acting at a specific point here. They are acting or meeting at a specific point here. Perfect. You have to calculate the resultant vector. You have to calculate the resultant vector or the resultant of two vectors. First of all, let's see the numerical approach. In the numerical approach, first of all, what will you do? You will connect the head of one vector to the tail of the second vector. You will connect the head of one vector to the tail of the second vector. This is more commonly known as head to tail rule. If you have to calculate the resultant vector, there are two methods. One is the numerical method, one is the graphical method. In the numerical method, the first step is to connect the head of one vector to the tail of the second vector. Now, what is the head? What is the tail of a vector? This pointed arrow is the head of a vector. This backside is the tail. This pointed arrow is the head of the vector. This backside is the tail. Can you realize currently both the tails of the vectors are connected together? Can you realize both the tails of the vectors are connected together? You will move this vector towards the right side. Move this vector towards the right side. Perfect. So your 3 Newton vector becomes like this. Your 3 Newton vector becomes like this. Perfect. Like this. Now, can you realize that the head of one vector is connected to what? The tail of the other vector. Can you realize the head of the 4 Newton vector is connected to the tail of the 3 Newton vector? Can you make a resultant vector here? Yeah. Resultant vector will always originate from the tail to the head. It will always go from the tail to the head. This is your resultant vector. This is a 90-degree angle. How are you going to calculate the resultant vector? Simple Pythagoras theorem. Resultant vector square is equals to 4 square plus 3 square. The resultant is equals to under root of 4 square plus 3 square. This comes out to be 5 Newton as your resultant vector. This is how you apply the numerical method. Perfect. Now, for the graphical method, let's say again, you have a 3 Newton and a 4 Newton vector intersecting at this point. For the graphical method, first of all, you will choose an appropriate scale. First of all, for the graphical method, you will choose an appropriate scale. Now, what do I mean by an appropriate scale? Can you see these are 3 Newton and 4 Newton vectors? You can say 1 Newton is equals to 1 centimeter and draw a 4 centimeter line for the 4 Newton vector and a 3 centimeter line for the 3 Newton vector. However, let's say we had two vectors. We had two vectors. One was 1000 Newton and the other was 800 Newton. Then this scale would have been invalid. Because now if you take this scale, 1 Newton is equals to 1 centimeter. This will become 1000 centimeter. And your page is smaller than 1000 centimeter. You cannot plot that. You cannot plot that. So what will you do? You will adjust your scale. You will say 100 Newton is equals to 1 centimeter. This will be a more appropriate scale. This will be equal to 10 centimeter. This will be equal to 8 centimeter on a piece of page. You can easily draw it. The first step in the graphical method is to realize a scale. Once you have realized a scale, then you can make the vectors on the page like this. Perfect. What is the second step? Second step is connecting the vectors according to the head to tail rule. This is head, this is tail, this is tail, this is head. Can you realize currently both the tails are connected together? This is not an optimum way. You will move this vector towards this side. Perfect. Now this length of the vector will also be what? The length of this vector will also be 3 centimeter. Perfect. Can you make the resultant vector? Yep. Easy peasy. You can make the resultant vector. Yeah, simple. But in the graphical method, you won't apply the Pythagoras theorem to calculate the value of the resultant vector. What will you instead do? You will take a ruler, you will take a ruler and measure this length. You will take a ruler and measure this length. You will take a scale, a ruler, and measure this length. Let's say this length of the resultant vector comes out to be 5 centimeter. Let's say the resultant vector comes out to be 5 centimeter. Now you will convert this 5 centimeter into newtons. How? Utilizing this scale. You know 1 Newton is equals to 1 centimeter. So 5 centimeters will be equal to how many newtons? 5 newtons. The resultant vectors is equals to 5 Newton. Easy peasy, nothing complicated. Let's move on to our next heading, that is of motion. Now what is distance? Distance is the length of path taken. It is a scalar quantity and it is measured in meters. What is displacement? Displacement is the shortest distance between 2 points. It is a vector quantity and it is also measured in meters. Similarly, we have a comparison of speed and velocity. Speed is a scalar quantity measured in meters per second. What is the definition of speed? Rate of change of distance. Okay. Now, velocity is a vector quantity. The units of velocity are meters per second. What is the definition of velocity? Rate of change of displacement. Perfect. This is the formula of velocity, displacement over time. And this is the formula of speed, that is distance over time. Perfect. Now, if your speed is changing in O level and IGCSE physics, if your speed is changing, you will apply the formula of average speed. What is the formula of average speed? Total distance over total time. Perfect. Let's move on to the next quantity that we need to study here. That is acceleration. Acceleration has an SI base units of ms minus 2. It is a vector quantity. What is the definition of acceleration? Rate of change of velocity. Perfect. Now, what is the formula for acceleration? This one. A is equals to V minus U divided by T. What is A? Acceleration. What is V? V is your final velocity. Final velocity. What is U? U is your initial velocity. Perfect. And what is T? T is your time. Acceleration is measured in the units of ms minus 2. Velocity final is measured in the units of ms minus 1. Initial velocity in the units of ms minus 1. Time in the units of seconds. Perfect. Now you will have the most important 5 minutes of your life. You need to understand the types of gradients as well. Although this is not written in the syllabus, but this is something that will make your life hell lot of an easier. You have to understand types of gradients in your O levels and IGCSE physics. If your line is horizontal, your gradient is zero. If your line is upward and sloping, if your line is upward sloping, then you have a positive and constant gradient. Okay. If your line is downward sloping, then you have a negative and constant gradient. If your gradient is increasing, you have an increasing curve like this. If your gradient is increasing, you have an increasing curve like this. If your gradient is decreasing, you have a decreasing curve like this. Perfect. Now let's come on to distance time graph and speed time graph. And we will be seeing different scenarios of speed time graphs and distance time graph. But before going to that, I want you guys to understand one thing, or I want you guys to remember one thing for that matter. Always remember that the gradient of distance time graph is equals to what? Gradient of distance time graph is equals to speed. Perfect. Gradient of distance time graph is equals to speed. And the gradient of speed time graph is acceleration. And the third key point that you need to remember is that area under speed time graph is distance. These are the three key points that you need to remember for a good grade. Now let's come on to case number one. Let's say your car is traveling at a constant speed, perfect. Your speed is remaining constant 6666 throughout the time of 0, 1, 2, 3, 4, perfect. If your speed is constant, you will draw a straight horizontal line on the velocity time graph. You will draw a straight horizontal line on the velocity time graph. Okay. Now, what do you remember? The gradient of distance time graph is equals to velocity. The gradient of this graph is equals to your velocity. Can you realize velocity is remaining positive and constant? Hence, if your gradient is positive and constant, which type of a line do you draw? Upward sloping. Can you realize how easy have the graphs become now? Let's move on to scenario number two. This is a constant acceleration or a steady acceleration or a uniform acceleration scenario. If your acceleration is steady or uniform, if your acceleration is positive and constant, what does that mean? This means that the gradient of the velocity time graph that is also equals to acceleration. The gradient of velocity time graph is also equals to acceleration and the gradient hence will be positive and constant. Why? Because the acceleration is uniform, steady or you can say positive and constant. Hence the gradient of velocity time graph भी क्या होगा? Positive and constant. Hence if your gradient is positive and constant, you have an upward sloping line like this. Here is the upward sloping line on the velocity time graph. Let me re-explain it for those who didn't got it at the first try. Can you realize that a constant or a steady acceleration means what? That your acceleration is positive and constant. If your acceleration is positive and constant, that means what? Your gradient of velocity time graph that is equals to acceleration will also be positive and constant. If the gradient is positive and constant, you always draw an upward sloping line like in scenario 2. Perfect. Let's move on to the distance time graph for the scenario. Can you realize that the velocity is increasing here? Can you realize from the values as well? As time is increasing, velocity is increasing. Okay, what have we studied? Gradient of displacement time graph or distance time graph is equals to velocity. If the velocity is increasing, that means what? The gradient will be increasing. If the gradient is increasing, which type of a graph do we draw? An increasing curve. This is an increasing curve. If the gradient is increasing, you draw an increasing curve like this in the distance time graph. Let's move on to the third scenario for increasing acceleration. Now, what do I mean by increasing acceleration? Just focus here. As you go from 0 to 1, your velocity units are increasing by 4. As you go from 1 to 2, your velocity units are increasing by 5. As you go from 2 to 3, your velocity ke units are increasing by 6. As you go from 3 to 4, your velocity ke units are increasing by 10. Can you realize that your velocity is increasing at an increasing rate? Can you realize the acceleration is not constant here? It is non-uniform acceleration. Or you can say it is an increasing acceleration case. Why? Because the velocity is constantly increasing at an increasing rate. Okay, so basically, sir, you are trying to say that the acceleration is increasing here, right? Yeah. And I know the gradient of this graph, velocity time graph, is equals to acceleration. If acceleration is increasing, that means the gradient will be increasing. If the gradient is increasing, which type of a graph do we draw? Increasing curve. Easy peasy. Let's further move ahead. Now, similarly, how will you draw the displacement time graph or the distance time graph? Do you remember that the gradient of distance time graph is equals to velocity? As velocity increases, the gradient should also increase. As the gradient is increasing, you draw an increasing curve on the distance time graph. Things have become quite easier for you guys. Now let's move on to the fourth scenario that is of a decreasing acceleration. Now please remember decreasing acceleration. I am writing it in bold words here. Decreasing acceleration is not equal to deceleration. Please. Decreasing acceleration is not equal to deceleration. Please, please, please refrain from this. Okay, so what is decreasing acceleration? As time goes from 0 to 1, your velocity goes from 0 to 4. Time goes from 1 to 2, velocity goes from 4 to 7, that is 3. Time goes from 2 to 3, velocity goes from 7 to 9, that is 2. Time goes from 3 to 4, velocity goes from 9 to 1, 9 to 10, that is 1. Can you realize that velocity is increasing but at a decreasing rate? That is known as decreasing acceleration. Okay, so sir, basically you are saying that acceleration is decreasing but it is not negative. Yeah, that means the gradient of this graph that is equals to acceleration is decreasing. The gradient will decrease. You will have a decreasing curve here. You will have a decreasing curve here. Okay, what will be the distance time graph? Can you realize although the velocity is a decreasing curve, but the values of velocity are increasing? Can you realize although velocity time graph is a decreasing curve, but the values of velocity are increasing? Can you realize that the gradient of distance time graph is equals to what? Velocity, or you can say speed. As the speed is increasing, the gradient will increase. You will again draw an increasing curve. Now let's come on to the last case, that is of negative acceleration, or you can say deceleration. What is the case for negative acceleration and deceleration? Okay. As time is going from 0 to 1, velocity decreases by 5. Perfect. Time is going from 1 to 2, velocity further decreases by 5. Time is going from 2 to 3, velocity further decreases by 5. Time is going from 3 to 4, the velocity is further decreasing by 5. Can you realize after each passing second the velocity is decreasing? This is known as deceleration or negative acceleration. Okay. If the velocity is decreasing, how will your velocity time graph look like? Downward sloping line. Velocity is decreasing. How will your distance time graph look like? Can you realize that the gradient of distance time graph is equals to speed, or you can say velocity? As the speed is decreasing, gradient decreases. As the gradient is decreasing, you draw a decreasing curve like this. Perfect. Now let's move on to something that is only in O levels. IGCSE students can skip this part. Thinking distance, braking distance, and total stopping distance. What is thinking distance? It is the distance covered during the reaction time of the driver. Let's say you are a driver, you have a reaction time of 1.5 seconds, you have a speed of 30. What will be your thinking distance? The speed into the time, that is 30 into 1.5. Your thinking distance comes out to be 45 meters. Simple as that. What are the factors that affect thinking distance? The speed of the car, whether or not the driver is fully alert or not, and the condition of the road. Perfect. Now, what is braking distance? What is braking distance? Braking distance is the distance that the car travels from the point till where the brakes were applied till when the car comes to a stop. Braking distance, beta क्या होता है? Braking distance is the distance which the car travels from the point where the brakes were applied till the car comes to a stop. This entire region is your braking distance. Your car was initially traveling at a speed of 30. You took a reaction time of 1.5 seconds. The thinking distance became 45 meters. After 45 meters, you applied the brake and your car came to rest at 3.5 seconds. What will be your braking distance? 1 upon 2 into 30 into 2. This comes out to be 30 meters as your braking distance. What are the factors that affect braking distance? Speed of the car, condition of the road, condition of tire, condition of brakes, and mass of the passengers. Perfect. Overall, a stopping distance is equals to what? Thinking distance plus braking distance. If you can see here, I have added thinking and braking distance to calculate the overall stopping distance. Perfect. Now let's come on to mass and weight. Mass is a scalar quantity. It is measured in kilograms. This is the definition of mass. It is a measure of quantity of matter in an object. Mass can also be measured in grams. And always remember, 1000 grams is equals to 1 kg. Perfect. What is weight? Weight is a vector quantity. Weight is measured in newtons. And what is the definition of weight? It is the gravitational force on an object with mass. Perfect. Now let's come on to the third term of this chapter, that is gravitational field strength. What is gravitational field strength? Force per unit mass acting on an object in a gravitational field. In the examinations, if you are not provided with the value of G, you will take 9.8 as the value of G. However, if you are provided with the Value of G as 10, you will take G as 10. In the examination, listen again. If you are not provided with the value of G, you will take 9.8. However, if the examiner has instructed that you have to take G as 10, you will take G as 10. Simple. Okay, now you have to remember one thing, that the gravitational field strength varies from planet to planet and depends on the mass and radius of the planet. Okay. Gravitational field strength, or the small g, varies from planet to planet and depends on the mass and radius of the planet. Perfect. You also have to remember that since weight is equals to mg, can you realize weight is dependent on gravitational field strength? Hence, weight also varies from planet to planet. However, mass remains same across all the planets. Let's come on to density. What is density ka formula and what is the density ki definition? Density is mass per unit volume. Always remember this is the formula of density. Density is equals to mass per volume. Okay. Now, density can be calculated in 2 units. Density can be calculated in 2 units in your syllabuses. If the mass is in kg, volume is in meter cube, the units of density will become kg per meter cube. However, beta, if your mass is in grams, volume is in cm cube, your density ke units will be gram per cm cube. Perfect. Now, how to calculate the density of a solid? Experiment on how to calculate the density of a solid. Very, very, very easy. To calculate the density, if you are a good student, to calculate the density, you will realize that you need the mass and volume of the object. Perfect. How will you calculate the mass of the object? Using a beam balance or electronic balance. How can you calculate the volume of an irregularly shaped object? Did I told you a method? Volume by displacement. You will calculate the volume by the method volume by displacement. I have applied this method here. V2 minus V1 final volume minus initial volume is your volume of the object. You have the mass of the object, you have the volume of the object. Divide both of them to calculate the density. Simple as that. This is an experiment to calculate the density of a solid. Now let's come on to the chapter of forces. In the chapter of forces, first of all, you need to know Newton's first law. What does Newton's first law state? Newton's first law states that if an object is at rest, it remains at rest. If an object is at constant speed, it remains at constant speed until and unless acted upon by an external force. This is written here. An object at rest remains at rest. A moving object continues to move at constant speed until acted upon by external forces. Newton's first law. Newton's first law is also known as law of inertia. Perfect. Let's come on to Newton's second law. Newton's second law deals with unbalanced forces. Newton's second law basically states that a resultant force will lead to acceleration. What is the formula for Newton's second law? F is equals to ma is the formula for Newton's second law. Perfect. F is the resultant force, m is the mass, a is the acceleration. Perfect. Let's do this example question. Now, here you have to calculate the acceleration. You have to calculate the acceleration. How are you going to do that? Easy peasy. First of all, can you calculate the resultant force here? Yep. 20 minus 12 will be your resultant force. Sir, why 20 minus 12? Why did I minus 12? Can you realize that 20 and 12 are acting in opposite direction? Hence, I had to put a negative sign in between. Resultant force is equals to mass into acceleration. And for those who still find it difficult, can you realize 20 is acting towards the right, 12 is acting towards the left? Perfect. Hence why a negative sign between them. Force is equals to 8. Mass is 4. Acceleration we have to calculate. Acceleration comes out to be 2 ms minus 2. Perfect. Now let's move on to the definition of friction. What is friction? Friction is the force which impedes motion and produces heating effect. Simple. What is the force of tension? Always remember tension force is in the string and it acts away from the object. Always remember the force of tension acts away from the object. This will always be the direction of tension. Now, let's move on to the concept of terminal velocity. This is only for the O level students. IGCSE students can skip forward. Perfect. Now, what is terminal velocity? Let's say you are falling or you have a ball that is falling through air. You have a ball that is falling through air. Let's say this is your ball that is falling through air. Perfect. Initially, only the weight of the ball will be acting. Hence, your acceleration will be 10 or you can say 9.8. Perfect. But as you move forward, as you move to point B, your speed starts increasing. As your speed starts increasing, your air resistance or the backward force starts increasing. Perfect. There will come a point when air resistance equals to the weight. There will come a point when air resistance is equals to weight. At this point, the resultant force becomes zero and you reach a terminal velocity. And you reach a terminal velocity, simple as that. This is known as a terminal velocity. You can see here, initially speed is zero, air resistance will be zero. Everything is written here. You can read the note side by side as well if you find anything difficult. Perfect. Now let's move on to Newton's third law. This is also only for O levels. Okay, Newton's third law deals with action and reaction forces. Okay, what is the action force if a car is standing on a road? If a car is standing on a road, what is the action force? Weight. Weight force that is acting down. What is the action force? What are the reaction forces? The two reaction forces are these. These reaction forces occur due to the contact of tire with the road. This is only for O levels. Newton's third law, action forces will be equal to the reaction forces, weight will be equal to the sum of reaction forces. Simple as that, nothing complicated. Let's move on to the next topic. This is for both levels. This is for IGCSE as well, and this is for O levels as well. What is center of gravity? Center of gravity is basically a point where the entire mass or weight of an object seems to be acting. Center of gravity is basically a point where the entire mass or weight of an object seems to be acting. Perfect. Now, how to locate center of gravities? Usually for regular geometric objects, center of gravity lies at the center of the object. Simple. For irregular objects, how to calculate the center of gravity of irregular objects? To calculate the center of gravity of irregular objects, you perform the plumb line experiment. Now, what is the plumb line experiment? Let's say you have a irregularly shaped lamina. Perfect. Let's say this is your irregular object. You will make three holes inside this. One, two, three. You will hang the plumb line from each of these holes. And where the plumb line drops, you will make a dotted line. Sir, what do you mean by that? Chalo, let me go into deep. Let's say this is your irregularly shaped object. You have to calculate the center of gravity of this. You make three holes through it. You attach a plumb line through it. And the line and the point or the line at which the plumb line drops and the point or the line where the plumb line drops, you mark that position with dotted lines like this. बेटा जहां पे आपकी plumb line drop हो रही है, you draw a dotted line there. Perfect. Although my drawing is pretty bad. But what I'm actually doing is I am taking an irregularly shaped object that is known as a lamina. I have three holes inside that. I have placed a plumb line across that. And where the plumb line drops, I am drawing a dotted line simple. I will do the same thing with both of these holes as well and draw a line where the plumb line drops. The point of intersection of all these points gives me the center of gravity. Simple as that. This is written here. Suspend the shape from a location near the edge. Drop a plumb line and mark on the object. Perfect. Suspend the object from another location and drop a plumb line and mark the position. Perfect. Repeat step 2 again. The intersection of all three lines is your center of gravity. Simple. Now, always remember objects that have a lower center of gravity. Objects that have a lower center of gravity. All the objects that have a lower center of gravity are more stable. All the objects that have a lower center of gravity are more stable. There is a reason why F1 cars are made close to the ground. Also, one more factor that affects the stability of the object is the base area. The wider the base area, the more stable the object is. So, wider base area and lower center of gravity are the keys to a stable object. Perfect. Let's move on to the next thing, that is elastic deformation. In elastic deformation, you need to know about Hooke's law. What is Hooke's law? Hooke's law basically states that the extension of a spring is directly proportional to the applied force, as I have written here. Force is directly proportional to the extension, that is x, Given that limit of proportionality has not been breached or has not been reached, we will discuss about limit of proportionality in just 1 minute. First of all, let's see Hooke's law in detail. Hooke's law is that force applied is directly proportional to the extension per effect. Force is directly proportional to the extension. As you can see here, if you remove the direct proportionality sign, you get a constant that is K. This constant is known as the spring constant. And what are the definition of a spring constant? Force per unit extension. Now, what are the units of a spring constant? If the force is in Newton, extension is in meters, you will get a unit of Newton per meter. If the force is in Newton, extension is in centimeter, you will get a unit of Newton per centimeter. If the force is in Newton, extension is in millimeter, you will get a unit of Newton per millimeter. Simple as that. Okay. Now, what is limit of proportionality? Now, if you see this equation, f is equals to ke. If you plot f on the y-axis, e on the x-axis, the gradient of this graph, first of all, will be equal to what? Spring constant k. Perfect. This is what I have written here. Limit of proportionality is the point till where the force versus extension graph remains a straight line. Limit of proportionality is that point up till where the force versus extension graph remains a straight line. Perfect. If you flip the axis of extension versus force, what will your gradient now become? 1 over k, that is the spring constant. Now let's move on to the centripetal force. Centripetal forces are those forces which allow your object to move in a circle. And always remember, if in examination you are asked to define circular motion, how will you do that? Define circular motion, how will you do that? You will say force is perpendicular to velocity. Whenever force applied or the resultant force is perpendicular to velocity, we move in a circular motion. Perfect. What are some examples? Also, the centripetal force always acts towards the center, or you can say inward. What are some examples of centripetal motion? The earth rotating around the sun. This is an example of centripetal motion. The satellite orbiting around the earth is also an example of centripetal motion. The tension in the string when you rotate a rope is also an example of centripetal motion. Now, this is something that is most ignored. This is something that is most ignored by all the students, either it be O levels, either it be IGCSE. This is ignored by most of the students. What is this? First of all, realize that the formula of centripetal force is equals to what? mv square over r. The formula of centripetal force is equals to mv square over r. M is equals to your mass. V is equals to your velocity. And r is equals to your radius. Now let me give you a good news. You don't need to remember this formula. Then sir, why it is written here? This formula will help you to analyze all the 3 points that are written on the bottom. This formula will help you analyze all the 3 points that are written on the bottom. Can you see as the speed increases, you can say that the centripetal force will increase? Yeah, that's correct. Can you see that as the mass increases, centripetal force will increase because mass and centripetal force are directly proportional. Perfect. Can you see as radius increases? Can you see or can you realize as the radius increases, centripetal force will decrease? Why? Because they are inversely proportional. So this formula should be on the back of your mind so that you can analyze the relationships. But you don't need to remember this formula. You don't need to apply this formula in the paper. This is categorically written in the syllabus that this is not required. But you can remember this formula to analyze the relationships of centripetal force. Now let's come on to the moments. What are moments? Moment is basically defined as the product of force and the perpendicular distance between the force and the pivot. Moment is basically defined as the product of force and the perpendicular distance between the force and the pivot. Let's say this is a force of W2. Let's say this is a pivot. The force is being applied at a distance of D2 from the pivot. What will the moment come out to be? The moment here will come out to be D2 into W2. Force multiplied by the perpendicular distance gives you the moment. Here I have written the formula of moment as well. And always remember the perpendicular distance that you are taking here is what? It is the distance between the force and the pivot. Perfect. Moments are measured in the units of Newton meter or Newton centimeter depending on what your distance is in. If your force is in Newton, distance is in meters, your units will be in Newton meters. However, if your force is in Newton, distance is in centimeters, your unit will be in Newton centimeter. Okay. Now, what is principle of moments? Principle of moments basically states that for an object to be in equilibrium, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Perfect. Okay. So, what do we mean by anti-clockwise moment and clockwise moment? If a force turns your pivot in the clockwise direction, then this gives rise to a clockwise moment weight 2 into d2. If a force turns your pivot in the clockwise direction or turns the rod in the clockwise direction, that gives rise to clockwise moment. Can you realize here that the weight of W2 or the force of W2 acting at a distance of D2 is turning the rod in the clockwise direction? Hence, this moment will be equal to what? W2 into D2. Simple. Can you realize that this other weight, W1, is turning the rod in which direction? In the anti-clockwise direction, opposite to the clock. Hence, the moment caused by this force will be anti-clockwise moment. W1 into D1. Simple, nothing complicated here. Now, let's raise this as well. Let's raise this as well. Okay. Now, in O levels and IGCSE, you also need to know an experiment to verify the principle of moments. What is the principle of moments? Principle of moments states that for an object to be in equilibrium, the clockwise moment must be equal to the anti-clockwise moment. How to verify this principle of moments? Very easy. You take a uniform meter rule and you balance it at the midpoint. You take a uniform meter rule and balance it at its midpoint. Perfect. You attach a weight W1 at a distance of D1. This will generate what? This will generate an anti-clockwise moment. This will generate an anti-clockwise moment. To balance the rod, you attach another weight W2 and adjust the distance of this weight. You add another weight W2 and adjust the distance of this weight until the clockwise movements equal to the anti-clockwise movement and the rod balances out. If W1 into D1 is equals to W2 into D2, that is the anti-clockwise movement is equals to clockwise movement, then your principle of movements is satisfied. Simple, nothing complicated. Let me repeat it for those who zoned out. So basically, what do? You take a meter rule, you apply a weight W1 at a distance of D1. This is generating an anti-clockwise moment. To balance out this anti-clockwise moment, we place another weight W2 at a distance of D2. Perfect. What will this do? This will generate a clockwise moment. This will generate a clockwise moment. Perfect. And if this generates a clockwise moment, the point where the clockwise moment equal to the anti-clockwise moment, the rod will balance out. Let's say this point is D2 at a distance of D2 from the pivot. You calculate the clockwise moment, anti-clockwise moment. If both of them are equal, then principle of moments is satisfied. Let's move on to the next thing, that is momentum. Now, what is the basic definition of momentum? Mass into velocity or product of mass and velocity. The units of momentum are kg ms minus 1, kg multiplied by ms minus 1. And other units of momentum are Newton second. And I will tell you in a while why. Okay. Momentum is a vector quantity. On the right side it will be positive, on the left side it will be negative. As you can see here, if your velocity is towards the right, momentum is positive. If your velocity is towards the left, your momentum is negative. Simple. Now let's move on to the conservation of momentum. Now, what is conservation of momentum, or what is law of conservation of momentum? Law of conservation of momentum basically states that the total momentum before an event is equal to the total momentum after an event. So the total momentum before collision is equal to total momentum after collision. Perfect. This is valid for a closed system. In a closed system, the total momentum before collision is equal to the total momentum after collision. Now, what does a closed system means? A closed system means that the energy within the system is constant. Perfect. Now let's do an example of this. Let's say you have two balls that are colliding like this. Okay. So you know one thing. You know one simple rule that the total momentum before collision is equals to what? Total momentum before collision is equals to the total momentum after collision. Total momentum after collision. Perfect. Now, what will be total momentum before collision? Mass, that is 1 kg, into the speed, that is 2. Perfect. Now, what will be the mass of this block? 2 kg. How will you write the momentum of this red volleyball? Mass of 2 kg multiplied by the velocity of negative 3. Why? Why have I multiplied it with the velocity of negative 3 and not positive 3? Because can you realize this velocity is acting towards the left? Hence, this has become negative. This will be equal to what? Total momentum after collision. So you have a 1 kg mass that has a velocity towards the left after collision, negative v. Perfect. And you have the 2 kg mass having a velocity towards the right. 1. Perfect. So what will we do further? This is 2 ones are 2 plus negative 6. This will become negative 6. Perfect. Is equals to negative v plus 2. Simple. So let's take this to the other side. Let's take this v, or you can say 2, to the other side. Let's take this 2 instead to the other side. That will make things easier. Let's take this 2 to the other side. This will make what? 2 minus 6 minus 2 is equals to minus v. 2 2 cancel out. Minus 6 is equals to minus v. Minus minus cancel out. V comes out to be 6 ms minus 1. This is how you have to apply the principle of conservation of momentum, or law of conservation of momentum. Total momentum before any collision is equals to the total momentum after any collision. Perfect. So now next thing that you need to know about is impulse. What is impulse? Impulse is force multiplied by the time for which the force acts. Perfect. Impulse can also be written as what? Change in momentum. So impulse has two formulas. If I were you, I would remember two formulas of impulse. Firstly, impulse is what? Force into change in time. Secondly, impulse is what? Change in momentum. Perfect. Impulse is change in momentum and impulse is force into time. Perfect. How do you calculate change in momentum? Change in velocity multiplied by mass. How do you calculate change in momentum? Mass into change in velocity. This is written a slightly wrong way. Mass into change in velocity is your change in momentum. Mass remains same. You have the final velocity minus initial velocity as your change in velocity multiplied by mass will give you your change in momentum. Simple. Now, can you realize that impulse has two formulas? Impulse has a formula of change in momentum and impulse has a formula of force into time. Let's equate both the formulas. You will get a formula of force. Force is equals to rate of change of momentum. Force is also defined as the rate of change of momentum. How did we derive this formula? By equating the two formulas of impulses. Nothing rocket science here. Let's move on to work energy power. Okay. Now, in work energy power, you first of all have to realize what is work done. Work done is defined as the product of force and the distance moved in the direction of force. The units of work done are in joules. Perfect. Let's say you have a force of 50 Newton. You are traveling a distance of 100 meter in that direction. Your work done will be 15 to 100. That is 5,000 joules. Perfect. Now, can you define joule? Yeah. Joule is what? When a force of 1 Newton causes a distance of 1 meter to be moved, the work done is said to be 1 joule. Perfect. Here are some energy types that are must known in O levels in IGCSE. Kinetic energy is the energy possessed by a moving object. It is represented as 1 upon 2 mv square, where m is the mass in kgs and v is the velocity in ms minus 1. Then we have gravitational potential energy, where m is the mass in kgs, g is 9.8, h is your height in meters. Perfect. What is elastic potential energy? Energy is stored in a compressed or a stretched spring. What is chemical energy? Energy is stored in a battery or a cell. You also need to know about law of conservation of energy. This basically states that the total energy in a system remains constant. Energy can neither be created nor destroyed. Simple. Now let's try out this example question as well. Let's say a toy car of 4 kg is released from point A. Okay. Assuming no friction, calculate its speed when it reaches B. Perfect. So can you realize at point A you are at rest? That means the kinetic energy at point A will be 0. Perfect. All the energy at point A will be equal to gravitation potential energy at A. All the energy at B will be what? Only kinetic energy, because the height at B is 0. The gravitational potential energy at B will be 0. All the energy at B will be kinetic energy. So can you say something like this, that the gravitation potential energy at A is equals to the kinetic energy at B? Yep, easy peasy. What is the formula of gravitational potential energy? mgh. What is the formula of kinetic energy? 1 upon 2 mv square. Mass and mass cancel out. Can you see, you don't even need this mass? You don't even need this mass to calculate the velocity. 2gh under root is your velocity. What is the value of g? 9.8. What is the value of height? 20. Take an under root and calculate the answer for velocity. Let's move on to power. Power is the rate of transfer of energy or the rate of work done. Power is equals to work done over time or energy over time. The units of power are in watts. Perfect. These are the two formulas for efficiency that you need to remember. Efficiency is useful power output divided by the total power input multiplied by 100. Efficiency can also be written as total useful energy output divided by the total energy input multiplied by 100. Simple as that. Now let's come on to the pressure ka chapter. Pressure ke chapter mein you have two main things. First of all, pressure in a solid and pressure in a liquid. Perfect. What is the formula for pressure in solids? Force over area. Force per unit area or force over area is your formula for pressure in solids. What are the units of pressure? If the force is in Newton, area is in meter square, your answer for pressure will be in the units of Newton per meter square. Newton per meter square is also given a name of pascals. Newton per meter square is also abbreviated as pascals. However, if your force is in Newton and area is in centimeter square, your units become what? Newton per centimeter square. Perfect. Now, let's analyze the relationship between pressure and area. This is only for solids. Please remember that this relationship is only for solids. Can you realize that in a solid, if the area increases, the pressure decreases? They are inversely proportional. Pressure and area are inversely proportional. If the area increases, pressure decreases, and if the area decreases, pressure will increase. Pressure and area are inversely proportional for a solid. This is a graph for inverse proportionality. Let's try out a question like that. Okay, so here can you realize that the area of pin in contact with the finger is what? 5 into 10 is the power of minus 3. The student applies the force of 26 Newton. What will be the pressure? Pressure will be equal to force over area. What is the force? 26 divided by area, that is 5 into 10 is the power of minus 5. Let's calculate this answer. Let's calculate this answer. If I have a calculator here, 26 divided by 5 into 10 raised to the power of minus 5. This comes out to be 5200 pascals. 52000 pascals. Simple. Let's further move ahead. Now, you have to calculate the pressure in fluids, either in liquids or gases. You will utilize this formula. Pressure is equals to rho gh, where rho is the density. The units of density are in kg m minus 3 or in grams per cm minus 3. Or you can write it like this. The units of density are in this. Okay. The acceleration of free fall is g, that is 9.8. Okay. The height h or the depth of the fluid is h. It is measured in meters. Perfect. Let's try out a question like this here. Okay. Let's see this. In figure 3.1, the length of the mercury column is 0.3 meters. Okay. So the length of the mercury column is 0.3 meters. Perfect. What do you have to calculate? The density of the mercury is this, atmospheric pressure is this. You have to calculate the pressure of the gas in the tube. You have to calculate the pressure of the gas here. How will you do that? Pressure of the gas is equals to the atmospheric pressure plus the pressure due to the mercury. Perfect. What is the atmospheric pressure? 1 into 10 is the power of 5. What is the pressure due to mercury? What is the density of mercury? 14,000 multiplied by 9.8 multiplied by the height, that is 0.3. Let's calculate this. 14,000 into 9.8 into 0.3 plus 10 raised to the power of 5. This gives you an answer of 141160 pascals. This gives you an answer of 141160 pascals. Simple as that. Nothing complicated here. This is a 6. Apologies for my writing. Let's move ahead. To unit 2, kinetic model of matter. You have to understand that solid has a fixed shape, fixed volume due to strong intermolecular forces. However, liquids are arranged in a form of clusters. They have a fixed volume, but they have no fixed shape. Perfect. And liquids के molecule perform translatory motion. Perfect. However, gas has not a fixed shape and not a fixed volume. Gas is compressible and the molecules move in a random motion. Now, the most important key point of Unit 2, that is this one. You wouldn't realize it, but it is very, very important. You must remember that the temperature of a gas is directly proportional to the kinetic energy of the molecules. You should write here. Temperature of a gas is directly proportional to the kinetic energy of the molecules. As temperature increases, kinetic energy of the molecules will increase. Simple, remember that. Now, you also need to know about the conversions from Kelvins into degrees. This is the conversion that you need to remember. If you have any degree centigrade ki value, you can add 273 to it to get the Kelvin value. Now, there are some gas laws as well that you need to know. For, okay, so one second. Let's do it here. Okay. So there are three gas laws that we will be studying. IGCSE only has Boyle's law. IGCSE students only have Boyle's law in their syllabus. However, O-level students need to know all three laws. So IGCSE students can only listen the Boyle's law and can move forward. Okay, what is Boyle's law? According to Boyle's law, basically the pressure of a gas is inversely proportional to its volume. Pressure of a gas is inversely proportional to its volume given that temperature remains constant. This is plotted in a relationship here. Pressure is inversely proportional to volume given that temperature is constant. Now, how will you plot it on a graph? Somewhat like this. Pressure is inversely proportional to volume. However, if you want to plot a graph of pressure on the y-axis, 1 over v on the x-axis, you will plot a straight line through the origin like this. Simple. Now, a repeated question in the examination. You have to tell, using ideas about particle, how steam or gas particle exert pressure on the piston. You will say particle hit with the wall of the container and exert a force. This force per unit area gives rise to pressure. Perfect. Whenever you are asked how does pressure develops or how do the gas molecule apply pressure, you will always mention that the gas molecules hit with the walls of container. This results in a force per unit area gives rise to pressure. Perfect. An alternative form to write Boyle's law is this: P1 V1 is equals to P2 V2. P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. Perfect. Now let's apply this formula P1 V1 into P2 V2 in an actual examination scenario. Okay, let's see this. Okay, let's zoom in a bit here. So you have a plunger, you have a syringe, you have trapped air here, you have wood, you have sealed in. Perfect. A 10 Newton weight is placed on the top of the plunger. Perfect. So a 10 Newton weight is placed on the top of the plunger like this. Perfect. Okay. The plunger moves down slowly so that the temperature of the air does not change. Whenever this is written, temperature of the air does not change, this means we have to apply Boyle's law. Whenever temperature is remaining constant, you will apply Boyle's law. Perfect. The pressure of the air inside the syringe is this. The volume of the air is this. The cross-sectional area of the plunger is this. Calculate the pressure of the air in the syringe after the plunger stops moving. Okay. So you have to calculate the pressure of the air inside the syringe once you have placed a 10 Newton ka weight here. Okay. What was the initial pressure? 1 into 10 raised to the power of 5 pascals. Okay. As soon as you place the weight, what is the added extra pressure that the weight will act? Force over area. Force is 10 Newton. What is your area here? 1.2 into 10 raised to the power of minus 4. Can you calculate the added extra pressure? Can you calculate the added or extra pressure? 10 divided by 1.2 into 10 raised to the power of minus 4. This comes out to be 83000 pascals. Perfect. You will add this extra pressure to the initial pressure to calculate the final pressure. You will say 1 into 10 raised to the power of 5 plus 83000. This comes out to be what? This comes out to be what? This comes out to be 183,000 pascals. Perfect. This is your final pressure. Okay. Now you have to calculate the volume of the air inside this range after the plunger stops moving. This will apply which formula? P1 V1 is equals to P2 V2. What was your initial pressure, beta? Initial pressure was 1 into 10 raised to the power of 5. What was your initial volume? 50 cm cube. Perfect. What was your final pressure? 183 triple zeros. 183 triple zeros. What was your final volume? You have to calculate that. So 1 into 10 raised to the power of 5. Perfect. Divided by 18300 and multiplied by 50. What does your volume comes out to be? Volume comes out to be 27.3 cm cube. Now this is how you apply P1 V1 is equals to P2 V2. This is for IGCSE and O levels as well, but the next two laws, Charles law and the pressure law, are only for O level students. IGCSE students don't need to remember this. What does Charles law state? Charles law basically states that the volume of a gas is directly proportional to the temperature given that pressure remains constant. This is Charles law. Volume is directly proportional to temperature given that pressure remains constant. Now, what is pressure law? According to pressure law, the pressure of the gas is directly proportional to the temperature given that volume remains constant. The pressure of a gas is directly proportional to temperature given that volume remains constant. Perfect. Now, a frequently repeated question. You have to answer why the pressure increases as the temperature is increased. So you will say, as the temperature is increased, the gas molecule gain kinetic energy and move forward, move faster. As the speed increases, they collide more frequently with the walls of container. As the collision frequency increases, a larger force is exerted on the wall, and since a larger force is exerted, the force per unit area or pressure also increases. Perfect. Now let's move on to thermal properties and temperature. You need to remember that for the same heat provided, gases expand the most, solid expand the least, and liquid expands by an intermediate amount. If the same heat is provided to solid, liquid, and gas, solid will expand the least, gases will expand the most. Perfect. Now let's move on to the concept of a specific heat capacity. It is represented with a small c. The units of a specific heat capacity are joule per kg degree centigrade. What is a specific heat capacity defined as? A specific heat capacity is defined as the amount of energy required by a mass of 1 kg to change its temperature by 1 degree centigrade. What is the formula of a specific heat capacity? C is equals to Q over M into delta T or delta theta. That is the formula of a specific heat capacity. Delta T is what? Change in temperature, final temperature minus initial temperature. M is your mass measured in kg. And the units of a specific heat capacity, you already know that are joules per kg degree centigrade. Simple. Let's try out a question. Calculate the amount of energy required by a mass of 5 kg to raise its temperature from 20 degree to 80 degree centigrade. The specific heat capacity of water is 4200. Okay, so basically you have to calculate what? You have to calculate the amount of energy, that is Q. Q is equals to mc delta T. What is the mass here? 5. What is C here? 4200. What is the change in temperature? 80 degree, that is the final temperature, minus the initial temperature, that is 20 degree. 60 into 5 into 4200. Your answer comes out to be, one second, let's convert it. Your answer comes out to be 1.26 into 10 raised to the power of 6 joule. So this is how you will utilize this formula. Let's move ahead. Now let's move on to the concept of evaporation. What is evaporation? Basically, evaporation is the process in which molecules with greater kinetic energy break away the intermolecular forces and escape from the surface. Okay, what is evaporation? Evaporation is the process in which molecules with greater kinetic energy break their intermolecular forces and escape from the surface. As more energetic molecules leave, the average kinetic energy of the liquid falls. As the average kinetic energy of the liquid falls, the temperature decreases. Why? Because I have told you one important thing: temperature is directly proportional to kinetic energy. As more energetic particles leave, the average kinetic energy decreases. As average kinetic energy decreases, the temperature decreases. This entire process is written here. Perfect. What are some factors that affect evaporation? What are some factors that affect evaporation? Surface area. If you increase the surface area, rate of evaporation will increase. Increase the surface area, rate of evaporation will increase. Temperature also affects the rate of evaporation. As the temperature is increased, rate of evaporation increases. As the humidity is increased, the rate of evaporation will be slower. Remember, this has an inverse relationship. ह्यूमिडिटी हाई करोगे रेट ऑफ एवेपोरेशन स्लोअर हो जाएगा. What about wind speed? As the wind speed is increased, what will happen? The rate of evaporation will also increase. As the wind speed increases, rate of evaporation increases. Perfect. Now let's move on to some basic conversions beta. अगर आप solid से liquid जा रहे हो, basically you are melting. If you are going from liquid to solid, basically you are freezing. If you are going from liquid to gas, you are boiling. If you are going from gas to liquid, you are undergoing condensation. So you must remember the name of these processes. Now, what is the difference between boiling and evaporation? Boiling occurs at a fixed temperature known as the boiling point. Evaporation occurs at all temperature. Evaporation causes a cooling effect. During boiling, the temperature remains constant. Boiling occurs throughout the liquid, evaporation only occurs on the surface. What are some similarities? Both involve a state in change, both involve breaking of intermolecular forces, both require energy. Simple. Now let's move on to the transfer of thermal energy. Okay, so there are three main processes that you need to know for the transfer of thermal energy. First one is the conduction. What happens in conduction? In conduction, the atoms of the hotter end of the solid vibrate to transfer the energy to the cooler molecules. In conduction, hotter end while molecules vibrate to transfer energy to the cooler end. Perfect. The energy transfer in conduction keeps on occurring until we reach what? Until we reach a thermal equilibrium. Perfect. Now, conduction occurs through two mechanisms. Conduction occurs through two mechanisms, atomic vibrations and free electrons. Now, can you analyze free electrons will only be present in metals? Hence why metals are good thermal conductors compared to non-metals. Now, let's look at convection. That is the second mode of heat transfer. Convection is the second mode of heat transfer and it is primarily used in liquid and gases. अच्छा कन्वेक्शन में होता क्या है बेटा व्हाट हैपेंस इन कन्वेक्शन basically let's say this is a fire source. Let's say this is a fire source. The air surrounding this fire source will get heated up. As the air heats up, the air molecules move apart, the air expands and air becomes less dense. As the air surrounding the fire becomes less dense, it will rise to the top like this. It will rise to the top. Perfect. And as the air, hot, less dense air rises to the top, what will happen? Cooler, denser air will fall to the ground. This enables the formation of convection currents. All of this theory is written. You can exactly copy paste this in the examination and you will get full marks. Let's move on to radiation. Radiation is very, very easy. Whenever you have a hot object, it emits what? Infrared radiation or radiant energy. This is known as radiation. Experiments have shown that dull and black surfaces are good absorbers and good emitters of heat. However, shiny and white surfaces are poor absorbers and poor emitters of heat, but they are good reflectors of heat energy. Now let's move on to waves. This is a third unit. Now, we have to study two types of wave, transverse waves and longitudinal waves. Both are a category of progressive wave. Transverse wave and longitudinal wave are a subcategory of progressive wave. What are progressive wave? Progressive waves are those waves which travel and transfer energy from one point to another. This is the definition of progressive wave. Okay. What is transverse wave? Transverse wave is a wave in which the direction of disturbance is perpendicular to the direction in which the wave travels. Sir, what do you mean by direction of disturbance? Let's say you have a rope like this. You will vibrate this up and down in the vertical direction. You will vibrate this up and down in the vertical direction. This will create a transverse wave in which direction? This will create a transverse wave in the horizontal direction. Or you can say that if you disturb the wave in the vertical direction, that is up and down, the wave travels in the horizontal direction. Hence, both these directions are perpendicular. This is a transverse wave. What is a transverse wave? A transverse wave is a wave in which the direction of disturbance, that is the direction of disturbance of the rope, is perpendicular to the direction in which the wave travels. Simple. Now, you also need to know some key points on the graph of waves as well. Okay. Whenever you have to mark the amplitude, what is the amplitude? Amplitude is the maximum displacement from the mean position. It doesn't matter whether it is negative or positive. Amplitude is what? Maximum displacement from the mean position. Perfect. If your displacement from the mean position is maximum positive, that is known as a crest. If your displacement from the mean position is maximum negative, that is known as a turf. Simple. Now, also you need to remember, if you have a displacement time graph and you mark the distance between one wave, you have a displacement time graph and you mark the distance between one wave, that will be known as the time period, because the x-axis is labeled in time. As you can see on the displacement time graph, if you mark the distance of one wave, that will be known as time period. What is the definition of time period? Time taken for one complete oscillation. Perfect. Now, similarly, on the displacement distance graph, if you mark the distance for one wave completion, that is this, or this, that will be known as the wavelength, because the x-axis is in meters slash distance, that will give you your wavelength. Perfect. Also remember, frequency is the number of oscillations per unit second. Frequency is the formula of 1 over time period. Time period is the time taken for the wave to get completed. The units of frequency are in hertz. Perfect. This is the wave equation that you need to remember. V is equals to f lambda, V being the speed of the wave, f being the frequency of the wave, lambda being the wavelength. Simple. Lambda can be in meters or centimeters, frequency in hertz, velocity can be in meters per second or centimeters per second. Perfect. Now let's move on to longitudinal waves. In longitudinal waves, the direction of disturbance is parallel to the direction in which wave travels. In longitudinal waves, the direction of disturbance, that is left and right, is parallel to the direction in which the wave travels. What are some longitudinal waves? Waves on a spring. Waves on a spring is an example of a longitudinal wave. The direction of disturbance, that is left and right horizontal, is parallel to the direction in which wave travels, that is also horizontal. Perfect. Similarly, sound waves are also longitudinal waves. If you see, the vibration of the loudspeaker is left and right in the horizontal direction, the wave is traveling in the left and right direction also. Now, in longitudinal waves, you have to remember that there are some points labeled as C, some points labeled as R. What are these points? C is a region of compression or maximum pressure. R is a region of rarefaction or minimum pressure. Perfect. Now, let's move on to ripple tanks. Water waves can be observed using ripple tanks. If in examination you have to draw the diagram of a ripple tank, this is what you will draw. You will draw a glass beaker, you will draw a white sheet of paper, you will draw a lamp, you will draw a signal generator along with an oscillator and a dial. The lamp and the white paper enable us to see the waves, the signal generator and oscillator cause the wave, and the dial helps us to set the frequency of the wave. Simple logic, nothing complicated. Now, there are two types of water waves that we need to study in O levels and IGCSE: plane straight water waves and circular water waves. Plane wave fronts or circular wave fronts travel in one direction only. Plane wave fronts or straight wave fronts travel in one direction only. Can you see that this orange line is traveling in one direction only? This is a plane wave. And these wave fronts are also plane wave fronts. Straight line में अगर wave fronts होंगे, that will be plane wave. The distance between the two wave fronts is known as your wavelength lambda. Perfect. However, if your wave is traveling in all directions or multiple directions, if your wave is traveling in multiple directions, they will be known as circular waves. They will be known as circular waves. Can you see here? The wave is traveling towards the right, towards the left, on the top side, on the downside. Perfect. The wave is traveling in all the directions. If your wave is traveling in all the direction, it gives rise to circular wave fronts. The distance between two circular wave fronts is also equals to lambda or wavelength. Perfect. Now, what is wave fronts? If the examiner asks you to write the definition of wave fronts, what is wave fronts? Wave front is an imaginary line joining all the crests belonging to different waves. Perfect. The distance between two wave fronts is equals to your lambda. Perfect. Nothing complicated. Now let's move on to the reflection of water waves. A reflection of water waves is pretty simple. Let's say this is your incident water wave. This comes and hits the barrier. Let's say this is your normal. This is your angle of incident. As soon as the water wave hits the barrier, it gets reflected backward. The angle between the reflected ray and the normal is your angle of reflection. Angle of incidence must be equal to angle of reflection in the case of reflection of water waves. Perfect. During reflection, what happens? Your frequency, wavelength, and speed remain same. The direction of the wave changes and the intensity of the wave reduces. Simple. Now let's move on to the refraction of water waves. That is the bending of waves. Now let's move on to the refraction of water waves. That is the bending of waves. Okay. There are two scenarios that can happen here. If your water waves are going from a deep region to a shallow region, what will happen? The wave fronts will bend towards the normal. The wave fronts will bend towards the normal. The wavelength decreases, the frequency remains unchanged, and the velocity also decreases. So please note this down. If your wave or water wave, if your water wave is traveling from a deep region to a shallow region, your speed decreases, wavelength decreases, you bend towards the normal, and your frequency remains unchanged. This is the diagram that you will draw here. This is the diagram that you will draw here. Perfect. Now, for water waves traveling from the shallow region to the deep region, what happens? For water waves traveling from the shallow region towards the deep region, what will happen? It is the opposite. Velocity increases, wavelength increases, and your wavefront bends away from the normal. Simple. Now let's move on to diffraction. What is diffraction? When waves pass through a narrow gap, they spread out. This is known as your diffraction. Whenever waves pass through a narrow gap, they spread out. This is known as diffraction. This is the narrow gap. Now, for sufficient diffraction to occur, if you want a significant amount of diffraction, the gap key width must be less, the wavelength must be higher. If you want the diffraction to increase, the gap width must be less, the wavelength should be higher. Simple as that. Let's further move ahead. Now let's see diffraction around an edge. How do waves diffract around an edge? Something like this. This is a very common example for radio waves. This is a very common example for radio waves. Let's move on to reflection of light now. Okay. In reflection of light, again, the basic principle remains same. Angle of incidence is equals to angle of reflection. Okay. Now, how do we mark angle of incidence and angle of reflection in the reflection of light? If you analyze, let's say, let's say this is the incident wave. Okay. And you will make a normal here. You will make a normal here. The angle between the incident ray and the normal is known as your angle of incidence. The angle between the normal and the reflected ray, that is the pink ray, will be your angle of reflection. In reflection of light, the angle of incidence should be equal to the angle of reflection. Similarly, here as well, if I mark a normal here, this is angle of incidence, this will be angle of reflection, both should be equal to each other. Now, remember this key point. Either it be reflection of water waves or it be the reflection of light waves, your angle of incidence remains equals to the angle of incidence. There is no complication in that. These two angles will remain same. Either it is reflection of light or reflection of water waves. Now let's move on to refraction of light. Let's move on to refraction of light, or you can say bending of light. Let's move on to bending of light. So what happens during bending of light? Again, there are two scenarios. Whenever light goes from a denser medium into a less dense medium, it bends away from the normal. Whenever light goes from a denser medium into a less dense medium, you bend away from the normal. This is your angle of incidence, that is the angle between the normal and the incident ray. And please pay attention here. Pay attention here. This R is what? Angle of refraction, because now you are having refraction. This R is your refraction, angle of refraction, because this time we are performing refraction. This R is what? Angle of refraction. Angle of refraction is what? Angle between the refracted ray and the normal. Perfect. Let's further move ahead to the next scenario. If light is going from a more dense medium in if light is going from a more dense medium to a less dense medium, you have seen that it bends away from the normal. However, if the light goes from a denser medium, or you can say from a less dense medium into a more dense medium, see, the first scenario was for from a denser medium to a less dense medium. If your light is going from a denser medium into a less dense medium, what will happen? It bends away from the normal. It runs away from the normal. However, if your light is going from a less dense medium into a more dense medium, what will happen? You will bend towards the normal. If you are going from a less dense medium to a more dense medium, you will bend towards the normal, simple as that. Now, these are some formulas to calculate refractive index. Refractive index for the first medium can be calculated using sin r over sin I, and the refractive index of the second medium can be calculated using sin I over sin I. Now, what is first medium, second medium? Let me explain that with a question. Let's say you have this sort of a question. Okay. Now, can you see that light rays are starting in air? Can you see that light rays are starting in air? Hence, air is the first medium. Can you realize light rays are ending in glass? Glass is the second medium here. Can you see that light rays are starting in air? That is your first medium. Light rays are ending in glass. That will be your second medium. The medium in which the rays start, that is known as your first medium. The medium in which the ray ends, that is known as your second medium. Okay. Now let's say, I have to calculate the refractive index of air. Let's say I have gotten a little bit crazy and I have to calculate the refractive index of air. Now, refractive index of air can be calculated using what? Using the formula of refractive index of the first medium. What is the formula for the first medium? Sin r divided by sin I. Sin r divided by sin I. Perfect. What is sin r? Sin 25. What is sin I? Sin of 40. You will get your refractive index of air. However, let's say I want to calculate the refractive index of glass. That is the second medium. Which formula will I use? Sin I over sin R. Perfect. Sin I is 40 divided by sin R. That is 25. This is how to calculate the refractive index of the first medium, of the second medium. Both are clear to you. Now, this is a formula that is only being used in IGCSE, that you can also calculate the refractive index of any material by this formula. Refractive index is equal to speed of light in air divided by speed of light in the medium. You will get the refractive index. Simple. Now, what is a critical angle? What is a critical angle? Critical angle is basically the angle of incidence at which the angle of refraction becomes 90 degrees. So when your light ray is going from a denser medium into a less dense medium, the angle of incidence at which the angle of refraction becomes 90 degrees is known as your critical angle. The angle of incidence at which the angle of refraction becomes 90 degrees is known as your critical angle. Perfect. What is your critical angle? Critical angle is the angle of incidence at which the angle of refraction becomes 90 degrees. Simple as that. This is written here. Now let's move on to the concept of total internal reflection. Whenever your angle of incidence becomes greater than the critical angle, whenever your angle of incidence becomes greater than the critical angle, what will happen? The ray will get refracted back into the medium. Beta, the refracted ray will come back into the medium if your angle of incidence is greater than the critical angle. Let's say in this scenario, your critical angle is 42 degree. Now, if your angle of incidence becomes greater than 42 degree, if your angle of incidence here, that is this blue line, becomes greater than 42 degree, your ray will return back without reflecting, without refracting. Your ray will return back as a reflected ray. This is known as total internal reflection. So just to revise, what is total internal reflection? When the angle of incidence gets greater than the critical angle, the entire ray gets reflected back into the medium. This is known as total internal reflection. Simple as that, nothing complicated. Let's further move ahead. Total internal reflection is most popularly used in which apparatus? Fiber optic cables. Total internal reflection is most commonly used in fiber optic cables. What do? You incident the light at an angle that is greater than the critical angle. This causes the light to perform total internal reflection and data is transferred in this way. Now, what are some advantages of fiber optic cables? They transfer data at a very fast speed. Data transmission is secure. A large amount of data can be transmitted, provides a good quality network, and has a very thin diameter, so it can be easily transmitted. You can also read the disadvantages, and this is something that you will have to learn by heart. Now let's come on to the types of lenses. There are two types of lenses primarily: converging lenses, diverging lenses. First of all, we will be discussing converging lenses. What are the properties of converging lenses? Okay, so let's move on to the properties of a converging lens. Basically, the first property is that any ray passing through the optical center of the converging lens will keep on passing without any deviation. So, if you have a ray that passes through the optical center of the converging lens, it will keep on passing without any deviation. Any rays parallel to the principal axis that hit the converging lens. Any rays parallel to the principal axis that hit the converging lens will pass through the focal point. Perfect. Any rays parallel to the principal axis that hit the converging lens will pass through the focal point. Simple. Perfect. Any ray parallel to the principal axis will pass through the focal point. This is the property that I told you. The inverse property is also true. If your ray is passing through the focal point before hitting the lens, then it will become parallel to the principal axis. If your ray passes through the focal point before hitting the lens, then after hitting the lens, it becomes parallel to the principal axis. It is opposite to property number 3. Now let's look at some cases. If your object is placed beyond 2f, like beyond two focal lengths on a, if your object is placed beyond two focal lengths of the lens, your image will be real, your image will be inverted, your image will be formed between f and 2f, and your image will be diminished. That is a smaller. Perfect. And whenever you are drawing a ray diagram, whenever you are drawing a lens diagram, sorry, you will make one ray that is passing through the optical center, and you will make one ray that is parallel to the principal axis. You will make one ray that is passing through the optical center, and you will make one ray that is parallel to the principal axis and passes through the focal point. At this point, you will have your image. So case number 1, whenever your object is placed beyond 2f, what will you have? You will have your image as real inverted form between f and 2f, and it will be smaller than the object. This application is used in camera lenses and human eye. If your object is placed exactly at 2f, your image will be what? Inverted, as you can see. The arrow is downward, the image will be real, as you can see. The object is on the left side, the image is on the right side, the image is real. The image will be of the same size. Perfect. Okay, case number 3. If the object is placed between f and 2f, what will happen? Your image will be real, inverted, your image will be beyond 2f, and your image will be larger than the object. So here is a simple trick to remember all these cases. As your object is moving towards the lens, as your object is moving towards the lens, what is happening? The image is going further away and it is getting bigger. The image is getting further away and it is getting bigger. Simple. Now let's move on to case number 4. Case number 4 is a unique case in which you have placed your object at the exact focal length. In this type of a scenario, no image is formed, the rays become parallel to each other. Perfect. Now, fifth scenario. When you place the object between optical center and the focal length, this is frequently asked in the examination. When you place the object between focal point and the optical center, then you will have a diverging rays. Then you will have a diverging rays. बेटा यहाँ पे आपके पास diverging rays आ रही हैं. They will never meet. They will never meet. What will you do? You will extend these rays backward to form an image here. You will extend these rays forward to form an image here. Now, this image will have different properties. First of all, this will be virtual. Why? Because object and image are on the same side. And secondly, can you see that this image has its arrow upward? This will also be upright. This image is also magnified. So these will be the properties. Image is upright, virtual, and magnified. This is the application where? This is the application of magnifying glasses. This is the application in magnifying glasses. Simple. Now, how to calculate linear magnification? You will take the height of the image divided by the height of the object, or you can say the distance of the image from the optical center divided by the distance of the image from the optical center to calculate the linear magnification. Simple. Now, if you realize here, if the object size is equal to the image size, your magnification is 1. If your image size is greater, your magnification will be greater than 1. If your image size is less than the object size, your magnification will be less than 1. Now, how to apply this formula? Let me also do a practical example so you know how to apply this formula. Let's say I have to calculate the magnification here. I will take the length of this object. Let's say this is 2 centimeter. And I will take the length of this image. Let's say this is 4 centimeter. How will I calculate the linear magnification? How will I calculate the linear magnification? Easy peasy. You will say 4. That is the image height divided by the object height. Linear magnification comes out to be too simple, nothing complicated here. So this is how you will calculate the linear magnification. Now then you have diverging lenses. What is the shape of diverging lens? Somewhat like this. What are the properties of diverging lens? Any ray passing through the optical center will continue to go straight without any deviation. For a diverging lens, any ray parallel to the principal axis that hits the diverging lens will get diverged in such a manner that if you extend it backward, it passes through the focal point. Simple. Now, what is the only case for a diverging lens? In a diverging lens, the image forms at one place only, no matter where you place the object. This is the single case for diverging lens that you need to remember. First ray passes through the optical center, second ray parallel to the principal axis diverges, but it diverges in such a way that if you extend it backwards, it passes through the focal point. The intersection of these 2 points gives rise to the image. The image is what? The image is virtual. This image is virtual and it is diminished and it is upright. The properties of image formed by a diverging lens are this: virtual, diminished, and upright. Perfect. Nothing complicated here. Now let's move on to the uses of lens. First of all, you have to understand that lenses are used to correct two types of diseases. Short sightedness is the first one. In short sightedness, you cannot see far away objects. In short sightedness, you cannot see far away objects. Okay. So if you cannot see far away objects, what's the problem happening here? The converging power of your lens has become stronger. In short sightedness, your lens has become stronger. Perfect. If your lens is stronger, what do you need? You need a diverging lens to initially diverge the rays. To initially diverge the rays. They meet at the converging lens and then they meet at the retina. This cures short sightedness. Initially, the short sighted eye was making the image before the retina because the lens had a very strong converging power. Now, once you apply the diverging lens, the converging power of the lens is sorted and the image is formed at the retina. Perfect. Long sightedness. What does long sightedness do? In long sightedness, you cannot see nearby objects, not see nearby objects clearly. Not see nearby objects clearly. In short sightedness, you cannot see nearby objects clearly. Perfect. This is a normal eye, the image is forming at the retina. In a long sighted eye, your image forms behind the retina. Why? Because this lens becomes weak. This lens becomes weak. How to cure this? You place another converging lens in front of it. You place another converging lens in front of it. A sharp, focused image is formed on the retina. Let's move on to the topic of dispersion of light. Dispersion means what? Splitting of white light into seven colors with cure. Dispersion of light refers to what? Splitting of white light into seven colors, that is Vibgyor, violet, indigo, blue, green, yellow, orange, and red. This is the splitting of light into its seven colors. Perfect. Now, why does dispersion occurs? Why does dispersion occurs? Because as light enter the glass prism, all of its seven colors travel with different speed. As all of the seven colors travel with different speed, they bend with different amount. This causes dispersion. बेटा dispersion होती क्या? What is dispersion? Dispersion is a splitting of white light into its seven colors: violet, indigo, blue, green, yellow, orange, and red. Now, why does dispersion occurs? Because when the light hits the glass prism, all the seven colors of light start to travel in different speeds. If they travel with different speeds, they bend with different amounts. They cause splitting. Now, red is the fastest. Red has the fastest speed. What will happen? Red has the fastest speed in glass. Hence, it bends least. Hence, it bends least. However, violet has what? Violet has the slowest speed in glass. Hence, it bends the most. Violet has the slowest speed. Hence, it bends the most. Perfect. You can also relate it to the wavelength. Since red has the largest wavelength, it bends the least. Since violet has the shortest wavelength, it bends the most. Simple. Let's further move ahead. Let's move on to electromagnetic waves. You need to know 5 to 6 properties of electromagnetic waves. They are all transverse wave. Electromagnetic waves travel with the speed of light. Perfect. They can all travel in a vacuum. They undergo reflection. They undergo refraction. This is the electromagnetic spectrum that you need to memorize by heart. Also, you need to memorize that as you go from left to right, the frequency decreases. As you go from left to right, the frequency decreases and your wavelength increases. Simple. As you go from left to right, frequency decreases, wavelength increases. Simple. You also need to memorize what are the uses of the electromagnetic spectrum. Radio waves are used in what? Television, transmission, astronomy, etc. And you have all the uses. You have to remember this. I'm not reading this out. This is just memorization. Okay. Let's move on to sound waves. Sound waves are longitudinal waves. Perfect. What are the audible frequencies of sound waves? From 20 hertz to 20,000 hertz. Perfect. Sound below the frequency of 20 hertz is known as infrasonic frequency. This is used in submarine communication. Sound above 20,000 hertz is known as ultrasonic frequency. It is used in ultrasounds. Now, how do ultrasounds occur? In ultrasounds, basically, we do what? We place an ultrasound transmitter on the body of the patient. Let's say this is a damaged liver. Let's say this is a damaged liver. The ultrasound transmitter will emit ultrasounds and hit the liver. This will gain information about the liver, and the ultrasounds will get reflected and they will be received by an ultrasound receiver. This is an ultrasound receiver. This is an ultrasound transmitter. This is how ultrasounds work. Ultrasound transmitter is placed on the body. It sends ultrasound in the body, as I have told you. These ultrasound get reflected, and the scanner receives these reflected ultrasound waves. This is the receiver. This is the transmitter. Simple as that. Let's further move ahead. Let's further move ahead. What is the speed of sound in different objects or different states of matter? Sound travels the fastest in solid with a speed of 5,000 to 6,000 ms minus 1. Sound travels with an intermediate speed in liquids that is from 1500 to 1600 ms minus 1. Sound travels the slowest in gases that is from 300 to 400 speed per second. And sound has a speed of 0 in a vacuum. Why? Because in a vacuum there are no molecules and sound requires molecules or a vacuum to travel. Perfect. What are some other uses of ultrasound? Ultrasound is also used for jewelry cleaning, and ultrasound is also used for quality control. Ultrasound is also used to detect crack or flaws in metals. Perfect. Now let's look at some properties of a sound. First of all, loudness. Loudness is directly related to the amplitude of the sound. If the amplitude increases, the sound will get louder. If the amplitude increases, the sound will get louder. You can see B has a greater amplitude, hence B ka sound will be much greater compared to A. Let's move on to the pitch. Pitch is directly related to the frequency of the sound. Pitch is directly related to the frequency of the sound. The higher the value of pitch, the greater the frequency, or you can inverse it as well. You can say the higher the frequency, the greater will be the pitch. Can you realize cycle B, or you can say the black wave, has a higher frequency, hence it will have a higher pitch as written here. The third property about sound is the quality of sound. The quality of sound depends on the wave that is formed. A pure sound will have a one complete wave. However, an impure sound will have a less smooth wave. It will have many waves within the single wave like this. This is a less smooth sound or a impure sound. Okay, now let's look at this experiment. This experiment is only for O levels to basically experiment to show that sound requires a medium, whereas light does not require a medium. You will perform the bell jar experiment. What do we have in a bell jar experiment? We have a bell connected with strings on the top. We have a vacuum pump on the outside. What do we do? Initially, air is present, and initially, if you ring the bell, you can hear the bell as well, and you can see the bell as well. Perfect. Once you start the vacuum pump, the air inside the bell jar starts to evacuate. The air inside the bell jar starts to evacuate. As the air starts to evacuate, what will happen? There is no medium left. Hence, the sound will not travel, and you will not be able to hear the bell jar की अंदर की जो bell है. When air is removed using vacuum pump, we can still see the bell, but the sound continues to fade until no sound is heard. Simple. This shows that bell or the sound requires a medium to travel. Simple. This is for O levels only. Now let's move on to a topic that is in both O levels and IGCSE, that is simple magnetism. Materials can be divided into two categories: paramagnetic materials and ferromagnetic materials. Materials can be divided into two categories: paramagnetic materials and ferromagnetic materials. Paramagnetic materials are those materials whose dipoles are fixed. Dipoles are fixed. Now, sir, what are dipoles? What are dipoles? Dipoles are basically tiny magnets within a overall material. Dipole basically a tiny magnet and they are denoted by this arrow paper. Now, in a paramagnetic material, the dipoles are fixed. In a paramagnetic material, the dipoles are fixed. There is no changing of the position of the dipoles. In a paramagnetic material, the dipoles are fixed. Perfect. Now, what happens in ferromagnetic? In ferromagnetic, the dipoles can change their positions. Now, I need you to pay close attention. In a paramagnetic material, the dipoles are fixed. Hence, they cannot be aligned. Hence, paramagnetic materials are non-magnetic materials. Paramagnetic materials have a fixed position of dipoles. They cannot be aligned. Hence, they are known as non-magnetic materials. All metals, zinc, copper, silver, gold are paramagnetic materials. Now, when you analyze ferromagnetic materials, there are two types of materials that you need to analyze, or two states that you need to analyze. In a ferromagnetic material, although the dipoles are free to move. Dipoles are free to move. The dipoles in a ferromagnetic material are free to move, but they can be aligned. They can be aligned like this. Hence, ferromagnetic materials are known as magnetic materials. What are example of such materials? Cobalt, nickel, iron, steel. These are ferromagnetic materials. Perfect. And let's move on to the properties of magnets now. Each magnet has two poles, north and south. The strength of the magnet is greater at the poles than is greater near the poles than compared to around the. Second property is that the strength of the magnet is greater at the poles. The strength of the magnet is greater at these poles, and as you move far away from the magnet, the strength decreases. As you move far away from the magnet, the strength of the poles decreases. Perfect. Now, magnetic field lines go from north to south. Always remember this: magnetic field lines go from north to south, like this: north to south, north to south. And the closer the magnetic field lines are together, the stronger is the field. The wider or the more space there is between the magnetic field lines, the weaker is the field. I have written this here as well. Like poles repel and unlike poles attract. North will repel, north south will attract. Simple as that. Now, how to magnetize iron? Very easy. Iron is a temporary magnet, and to magnetize a temporary magnet, you will bring a permanent magnet close to it. As soon as you bring a permanent magnet, a north pole close to the iron will have a south pole here. The iron will have a south pole here. Perfect. However, if you bring a permanent magnet ka south pole here, iron will have a north pole induced here. Always remember, iron induces a pole based on what pole is brought in front of the iron. That's why iron is known as a temporary magnet, and it works on the principle of induced magnetism. It works on the principle of induced magnetism, and iron is a temporary magnet. Perfect. And one more thing about iron: iron always attracts. Iron always attracts magnet. Attracts magnet. Please remember that. Iron never repels a magnet. Iron always attracts magnets. Perfect. How to demagnetize iron? Just remove the temporary magnet, permanent magnet away from the iron. The iron will get demagnetized. Remove the magnet, and iron, being a temporary magnet, instantly demagnetizes. Perfect. How to magnetize steel? How to magnetize steel? To magnetize steel, you can put the steel bar inside a solenoid and switch on the DC supply. You can put the steel bar inside the solenoid and switch on the DC power supply. This will cause the dipoles of the steel bar to get aligned. The steel bar will get magnetized. Now, once the steel bar is magnetized, how to find the current key direction, or you can say Now, once the steel bar is magnetized, you can say once the steel bar is magnetized, how to find the north and south pole of the steel bar? For that, we use right hand grip rule. For that, we use right hand grip rule. What does right hand grip rule states? If your fingers curl in the direction of the current, your thumb points towards the north. Okay. Where are your fingers curling here? If I make my ugly fingers here, they are curling in this direction. The thumb will point here. So your north pole is this. Okay. And the opposite pole will be the south pole. So you have learned two things here. First of all, if you have to magnetize a steel bar, you will put the steel bar inside a solenoid and switch on the DC supply. How to identify the poles of the steel bar? You will apply right hand grip rule and identify the poles of the steel bar using the right hand grip rule. Simple. Now, how to demagnetize a steel bar? Very, very easy. Place the steel bar in the solenoid, but this time connect an AC supply or an alternating current. This time connect an AC supply or an alternating current with the solenoid. What is alternating current? The current direction changes every many times 1 second. What is alternating current? Alternating current is basically a current in which the direction of current changes multiple times in 1 second. So, if you have to demagnetize the steel bar, you will connect it with an AC supply. If you have to magnetize the steel bar, you will have to connect it with the DC supply. Simple as that. All of it is written here. You can read that. What are uses of permanent magnet? Permanent magnets are used in toys, fridge magnet, compasses, school lab experiments. What are the uses of electromagnets? MRI scanners, speakers and earphones, recycling, maglev trains. Simple. Now, how to plot magnetic field lines using iron fillings and using a compass? Let's see both of them. First of all, let's see the iron filling method. How to plot magnetic field lines using an iron filling method. You will take the magnet, place it on the piece of paper, and gently sprinkle the iron fillings around the bar magnet. You will take a magnet, place it on a piece of paper, and gently sprinkle the iron fillings around it. You can see the field lines forming here. These are your magnetic field lines. Faithful. How to plot magnetic field lines using a compass? How to plot magnetic field lines using a compass? Now, please pay attention here. You will take a magnet and place a plotting compass near the magnet. You will take a magnet and place a plotting compass near the magnet like this. Perfect. Near a magnet like this. Perfect. The arrow needle, the arrow needle of the compass points in the direction of the magnetic field. If you have to plot magnetic field lines using a compass, what will you do? You will take the compass and place it near a magnet like this. Perfect. The needle of the compass points in the direction of the magnetic field. You will place a dot. You will place a dot where the needle points. Perfect. What will be the second step? You will move the compass to this point such that the needle aligns with the dot. And then you will see where the needle points now. Again, you will mark a dot here. Again, move the compass. Keep on doing this until you have a multiple set of points and then connect the points to make the field line. This is what I have written here. Place the plotting compass near the magnet on a piece of paper. Mark the direction in which the needle points. Move the plotting compass to many different positions in the magnetic field, marking the needle position each time. Join the points to show the magnetic field lines. Easy peasy, nothing complicated here. Let's move on to electrical quantities now. What is a conductor? What is an insulator? An insulator does not contain free electrons, hence its conductivity, or you can say it is a bad conductor. However, a conductor has free electrons which help in electricity conduction, hence, conductors are good conductors of electricity. You can say that. How can we charge an insulator? By a process known as charging by friction. What do we do in a process of charging by friction? Let's say you have a glass and you have wool. Let's say you have a glass rod and you have a woolen cloth. How will you charge these two insulators? By charging by friction method. You will take these two insulators and rub them together. When you rub them, friction is created. This friction generates what? This friction generates heat, and this heat causes what? This heat causes the electrons to get excited. Electrons get excited due to the heat. ठीक है क्या हो रहा है बेटा? You have two insulators, you are rubbing them together. As you rub them together, the heat causes the electrons to get excited. The electron move from one material to another. In this scenario, I am assuming the electrons are moving from the wall to the glass. So the material which loses electron become positively charged. The material which gains electron become negatively charged. Glass becomes negatively charged, wool becomes positively charged. The vice versa could have also been done here. You could have also said that glass loses electrons, glass becomes positively charged, and wool becomes negatively charged. It is completely your choice which material you think loses electron, which material you think gains electron. Perfect. Now, what is an electric field? Electric field is defined as a region around a charged particle where other charged particles experience an attractive or a repulsive force. How to represent electric field lines? Always remember, electric field lines originate out of a positive charge and they are radial in direction. Beta, electric field lines always emerge out of a positive a charge and they are radial in direction, like this. Simple. Secondly, electric field lines always go into a negative charge. They always go into a negative charge like this. They always go into a negative charge. If you have a positive and a negative charge, what will happen? Electric field lines will go from a positive to negative, positive to negative, positive to negative like this. Some field lines will just be entering the negative, some field lines will just be omitting out of the positive charge. Always remember one thing. Electric field lines go from a positive to a negative charge, and electric field lines emit out of a positive charge and they go inside a negative charge. Perfect. If you have two like charges, what will happen? The field lines will repel away from each other like this in a positive positive ka case, yeah, in a negative negative ka case. This is small point x. This is small point x is the point where there is no electric field lines. बेटा इस स्मॉल पॉइंट एक्स पे इलेक्ट्रिक फील्ड लाइंस नहीं है या इलेक्ट्रिक फील्ड स्ट्रेंथ जीरो है दिस इज नोन एज नल पॉइंट दिस इज नोन एज नल पॉइंट परफेक्ट नाउ इफ you have to draw the electric field lines between two metal plates, how will you draw them? If you have to draw the electric field lines between two metal plates, how will you draw them? From positive to negative, positive to negative, positive to negative, positive to negative, positive to negative. Simple. Let's move on to the electrical quantities. First of all, we need to study about current. Current has a symbol of I. It is measured in amperes. Current की definition क्या है? Current is the flow of charges. This is the formula that we will be using for current. Q is the charge measured in coulombs. Time T is the time measured in seconds. Perfect. What is the voltage difference? Voltage or potential difference? Voltage or potential difference has a symbol of V. It is measured in the units of volts V. What is voltage defined as? Voltage is defined as the amount of work done by a battery to move a 1 coulomb of charge through the electrical circuit. Perfect. Voltage is equals to work done over charge. This is the formula that we usually utilize when voltage and work done are related. Now, an important distinction. What is EMF? EMF is the amount of work done per unit charge in moving the charge across an entire circuit. Electromotive force or EMF is the work done per unit charge in moving the charge across the entire circuit. However, potential difference is what? Work done per unit charge in moving a charge through the electrical component. Please correct this definition. Potential difference is basically the work done in moving a unit charge across a single component. However, electromotive force is what? Potential work done per unit charge in moving the charge across the complete circuit. What is the formula of electromotive force? Work done over charge. Perfect. Now, what is resistance? Resistance is measured in ohms. This is the formula of resistance. Voltage over current. V is equals to IR will be your formula for resistance. Now, this V is equals to IR relationship is also known as Ohm's law, and the materials following this Ohm's law are said to be ohmic conductors. Perfect. Now, what does Ohm's law state? Ohm's law basically state that the potential difference applied across any material is directly proportional to the current across that material. The length, area, and the temperature should remain constant of that material. Perfect. For Ohm's law to be applicable, always remember for Ohm's law to be applicable, the temperature should remain constant. For Ohm's law to be applicable, temperature should remain constant. Perfect. Now, if you plot, now again a plotting graph, voltage is equals to IR. If you plot voltage on the y-axis, voltage on the y-axis, and let me do it correctly. Voltage on the y-axis, current on the x-axis. What will you get as your gradient? Your gradient will be equal to the resistance. Simple here. Voltage on the y-axis, current on the x-axis, the gradient is equals to your resistance. Perfect. Okay. Now, all the materials that follow Ohm's law are known as ohmic conductors. All the materials that follow Ohm's law are known as ohmic conductors. An example of such material is a resistor. Perfect. Example of such a material is a resistor. Perfect. What are ohmic conductors which obey Ohm's law? Perfect. Graph will be a straight line passing through the origin and the resistance remains constant. Perfect. What are non-ohmic conductors which do not obey Ohm's law? Whose resistance is not constant and their graph will be a curve. Now let's see two types of non-ohmic conductors. Let's see two types of non-ohmic conductors. The first type of non-ohmic conductors are those in which the resistance increases. If your resistance is increasing, you know that the gradient of voltage over current graph is equal to resistance. If your resistance is increasing, that means the gradient of this graph will increase. You will draw an increasing curve. Always remember, if your voltage versus current graph is an increasing curve, the current versus voltage graph. If the current is on the y-axis, voltage on the x-axis will be a decreasing curve, because current versus voltage graphs are always inverse of voltage versus current. बेटा करंट वर्सेस वोल्टेज ग्राफ जो होते हैं आपके दे आर इनवर्स और you can say opposite of the voltage versus current graph. If you are getting a increasing curve on the voltage versus current graph, the current versus voltage graph will be a decreasing curve. What are examples of such sort of materials? Lamp, metals, bulb, and filament lamp. Second type of non-ohmic conductors in which resistance decreases. If your resistance is decreasing, that means the gradient of voltage over current will decrease. Gradient of voltage over current graph should decrease. Why? Because resistance is decreasing. And resistance is the gradient of voltage over current. So the gradient of voltage over current graph should decrease. Hence, you will draw a decreasing curve here. The voltage versus current graph is a decreasing curve. And as I have told you, if the voltage versus current graph is a decreasing curve, the current versus voltage graph will be an increasing curve. What is an example of such a material? A thermistor. What is an example of such a material? A thermistor. Perfect. Now let's see some factors affecting resistance. First of all, temperature. Temperature affects resistance greatly. As the temperature increases, molecular vibration increases, it becomes difficult for the charge to flow. Perfect. Resistance increases. Secondly, resistance is also directly proportional to length. As the length increases, the resistance increases. Resistance is inversely proportional to area. As area increases, the resistance decreases. Simple. Next up, we have some formulas of power that you guys need to remember. Power is equals to current into voltage. Power is also equals to I square R. Power is also equals to V square over R. This is the power, not resistance. This is power. Perfect. I is current, V is voltage, R is resistance, V is power. Perfect. And if you want to calculate the formulas of energy, you just multiply time with the formulas of power. IV multiplied by T will give you the formula of energy. I square R multiplied by T will give you the formula of energy. V square over R multiplied by T will give you the formula of energy again. Simple. Now let's move on to resistors in series and their properties. Perfect. Always remember, if you have resistors in series connected, the total resistance or the combined resistance will be the sum of all the resistance 6 plus 4 plus 10, that is equals to 20 ohm. Perfect. And if you have to calculate the current in series, how will you do that? You will take the total voltage, that is 40, you will take the total resistance, that is 20, divide them, get the current as 2 ampere. Now, an important property to remember, in series circuit, current at every point remains same. In series circuit, the current at every point remains same. This will be 2 ampere here, 2 ampere here, 2 ampere here. Perfect. Now, in a series circuit, there is an interesting logic. In a series circuit, there is an interesting logic. That is what? Okay, so the last property in series circuits that you need to remember is that voltage is directly proportional to the resistance. So, what do you mean by that? Let me show you a numerical example here. Can you see that 2 ampere current will be flowing through the 6 ohm ka resistor? What will be the voltage across this resistor? 12 volts. The 2 ampere का current will also be flowing across this 4 ohm का resistor. The voltage across is this 8. The 2 ampere का current will also be flowing across this 10 ohm का resistor. The voltage across this is 20 volts. कैन यू रियलाइज बेटा, कैन यू रियलाइज कि जितनी आपकी रेजिस्टेंस हायर है, as you can see it, this is 10 ohm, the higher the resistance, the higher will be your voltage value. The higher the resistance, the higher will be your voltage is की value. Simple. This is the formula of series. The greater the voltage value, the greater the resistance value, the greater will be the voltage produced. Simple. 12, 8, 20. Simple. Now let's see resistors connected in parallel. Let's see resistors connected in parallel. Perfect. Now, whenever you have resistors in parallel, let's say this is a 6 ohm resistor, let's say this is a 3 ohm resistor, what will you do? How will you calculate the combined resistance? The combined resistance in parallel is calculated using this formula: 1 over RT is equals to 1 over R1 plus 1 over R2. 1 over RT is equals to 1 over 6 plus 1 over 3. The total resistance comes out to be 2 ohms. बेटा पैरेलल में जब भी आपने रेजिस्टेंस निकालनी है, you will utilize this formula. Parallel circuits में whenever you have to calculate the resistance, you will utilize this formula. The second formula of the second property, I would say, of parallel circuits. In parallel circuits, the voltage remains same. In parallel circuits, the voltage remains same. That means this 3 ohm resistor will also be receiving 6 volts, and this 6 ohm resistor will also be receiving 6 volts. Perfect. Now, how do you calculate the total current in a parallel circuit? How do you calculate the total current supplied by the battery in a parallel circuit? Again, V is equals to IR. In place of resistance, you will put what? In place of resistance, you will put the total resistance beta, that was 2 ohms. In place of voltage, you will put 6 volts. This is if you have to calculate the total current in a parallel circuit, 3 amperes comes to be your answer. Now, in a parallel circuit, always remember that current splits out. In a parallel circuit, always remember that current splits out. Now, how do I calculate these current in the branches? See, initially the current was 3 ampere. As you have calculated, the total current was 3 ampere. But as the current arrives at this point, it gets split out. How to calculate the current in each branch? If you have to calculate the current in each branch, it's simple. This branch is receiving a voltage of 6, the resistance is 3. Divide two of them, V is equals to IR, voltage is 6. I don't know, resistance is 3. Resistance is basically 3. What will your answer of current come out to be? The current answer comes out to be 2 ampere. Similar V is equals to IR here. Your voltage is 6. Your voltage is 6. Perfect. Your voltage is 6. What is your resistance? Your resistance is 6 as well. Current क्या आ जाएगा बेटा? Current will come out to be 1 ampere. Simple. This is the working that I have done here as well. If you want to calculate the current in individual branches, you can do it like this. Now let's move on to a thermistor. What is a thermistor? A thermistor is basically an electrical component whose resistance decreases as the temperature increases. As the temperature increases, the resistance decreases. This is the graph of thermistor. This is the symbol of thermistor. Perfect. Let's move ahead. What is a light dependent resistor or an LDR? The symbol of the LDR is this, and it works in a similar fashion. As the light intensity on the LDR increases, the resistance of LDR decreases. This is your graph. Perfect. Now, where are LDRs used? LDRs are used in street lights, etc. Now, let's further move on to cells in series. Let's further move on to cells in series. Always remember, when you have cells in series, how will they be connected? The negative terminal will be connected to the positive terminal of the battery, negative to the positive. Simple. Whenever you have cells in series, the negative terminal will be connected to the positive terminal. Simple. This is written here as well. The negative terminal is connected to the positive terminal of the other cell. If you have cells in series, how will you calculate the total voltage? If you have cells in series, how will you calculate the total voltage? 2 plus 2 plus 2, the total voltage comes out to be 6 volts. Perfect. If you have cells in series, you will add all of the voltages to calculate the total voltage. Perfect. And in series, if one cell defaults or if one cell drains out, the entire circuit stops. Perfect. Now let's see cells in parallel. Let's see cells in parallel. Now remember, oh, what has happened here? What has happened? One second. I think my diagram has messed up a bit. Okay, so what you can do here is. Mhm. Okay, this is the positive terminal, this is the negative terminal. Perfect. So in cells in parallel, what do we have? In cells in parallel, we have the positive terminal connected to the positive terminal of the battery. As you can see here, the positive terminal is connected to the positive terminal of the battery. The negative terminal is connected to the negative terminal of the battery. Negative terminal is connected to the negative terminal of the battery. Simple. In parallel, the total EMF is equals to the EMF of one battery. In parallel circuits, the total EMF will be equal to the EMF of one battery. What is the EMF of one battery? 2 volts. The total EMF will also be equal to 2 volts. Perfect. And in parallel, if one cell drains out, the entire circuit keeps on working. This is a pretty advantageous point for parallel circuits. In parallel circuits, if one cell drains out, the circuit keeps on working. Now let's come on to the topic of electrical safety. There are two types of plugs that we need to study in our syllabus: 2-pin plug, 3-pin plug. What is a 2-pin plug? In a 2-pin plug, we have a live wire. A live wire is the wire that brings current into the circuit. We have a live wire that brings current into the appliance. Then we have a neutral wire that takes away current from the appliance to the main supply. Perfect. Also, if you analyze, we have some very keen features here. You know the live wire, you know the neutral wire now. But can you realize there is an interesting component here named as fuse? What is fuse? Whenever the current in the circuit gets greater than the actual value, whenever then the current in the circuit gets greater than the required value, the fuse blows off and closes the circuit. Let's say this appliance requires 4 ampere ka current. Let's say this appliance requires 4 amperes ka current. If the current in the circuit becomes 10 ampere, the fuse will blow off and will stop the circuit. The fuse will blow off and it will stop the circuit. This is why a fuse is used to protect the appliance from any damage. And you have a traditional switch here. The switch is used to open and close the circuit. Perfect. Now, okay, switch वाली बात तो ठीक है ये थोड़ी सी क्या हो गया है? Why are they? Yeah, I guess this would be. So, fuse acts as a circuit breaker. When the current gets higher, it breaks itself, dismantles the circuit. Perfect. Now, how to determine the reading of the fuse? How to determine the reading of the fuse? What is a suitable reading for a fuse? What is the suitable reading for the fuse? Let's say your appliance is working at 4 ampere. The working temperature or the working current of your appliance is 4 ampere. Perfect. Then your fuse can be of 5 ampere. Then your fuse can be of 5 ampere or 6 ampere. Why? Because if the current gets greater than 5 or 6 ampere, the fuse will blow off. Your appliance will be prevented from any damage. Make sure that the fuse key rating is not below the current of the appliance. Make sure that you don't choose a fuse of, let's say, 3 ampere. Let's say you don't choose a fuse of 3 ampere, because if you choose a fuse of 3 ampere, then the fuse will blow off even when the appliance is working normally. You want the fuse to blow off when the current gets a bit higher than the normal working temperature, maybe 6 ampere, 5 ampere if the appliance requires 4 ampere current. This is what I've written here. If the appliance requires 4 amperes current, the fuse rating can be 5 ampere, 6 ampere, maybe max to max 8 ampere. No more than that. Okay. Now, 2-pin plugs become dangerous when they come in contact with a metal casing. 2-pin plugs are dangerous when you have a metal key outer casing. Why? Because it is possible that the live wire gets connected with the metal casing. In this type of a scenario, the metal body will get electrically charged. The metal body will gain electrons or will gain charges. You can mark it negative to make it more appropriate. If the live wire starts touching the metal body will become negatively charged. Now, if you touch the metal body now, you will get an electric shock. This is why 2-pin plugs are dangerous when you have a metallic outer casing. Why? Because when you have a metallic outer casing and the live wire starts touching the metallic outer casing, what will happen? Charges will develop on the metallic outer casing, and if you touch the metallic outer casing, you will get an electric shock. To prevent you from getting an electric shock, we have developed three pin plugs or three leads. We add an extra wire of earth wire. What does this earth wire do? Earth wire takes all the electrons into the ground and makes the metal casing neutral again. Makes the metal casing neutral again. Perfect. Makes the metal casing neutral again when we place a earth wire connected to the metal casing. Perfect. Now let's move on to the diode. Let's move on to the diode. Diode is a very interesting electrical component. Diode has two terminals, anode and cathode. You can say positive and negative. Whenever the positive terminal of the diode is connected with the positive terminal of the battery, the diode is in a forward bias condition. That means low resistance and a large amount of current flows through the circuit. However, if the positive terminal of the diode, that is the triangle or you can say the anode, is connected to the negative terminal of the battery, you will be in a reverse bias condition, very high resistance, and no current flows through the circuit. Simple as that. This is the conclusion, that is, when you are a forward bias diode, current flows. When the diode is in a reverse bias condition, the current does not flow. Perfect. Now, there is a addition to diodes, that is light emitting diodes, LEDs. LEDs also work in the same manner. If they are forward biased, the LED glows up. If they are reverse biased, LED does not glow up. Simple. Now, let's move on to the topic of potential divider as well. Potential divider is also known as potentiometer. Let's say you have a circuit like this. You want to change the voltage across the lamp. You want to change the voltage across the lamp. Okay, how are you going to do that? By again and again removing this lead of the lamp, by again and again removing this connecting lead of the lamp and then connected it somewhere across the resistance. If you want to change the voltage across the lamp, the only possible solution that you currently have is to remove these lead and connect it somewhere else. If you have connected at the exact end, you will get 20 volts. If you have connected in the middle, if you have connected at, let's say, 75% of the resistor way, you will get 15 volts. If you have connected in the middle, you will get 10 volts. If you have connected at the 25% of the resistor, you will get 5 volts. Now, can you realize you are doing a very hectic task? If you want to vary the voltage across the lamp, you are again and again removing this lead and connecting it at another point. Again and again removing it and connecting at another point. This is a hectic task. Hence why potentiometers were invented. Potentiometers have a sliding contact, and you can place this sliding contact at whatever voltage you want. If you want 20 volts, place it at point A. If you want 15 volts, place it at point B. Similarly, if you want 10 volts, place it at point C. Potentiometer enable us to change the voltage without again and again removing the connecting lead and placing it at another point. And if you realize, this was the purpose of potentiometer, to divide the voltage. Simple. Let's move on to electromagnetic effects. I think, yeah, I have explained all of this. This is written in theory here. Perfect. Now, let's move on to electromagnetic effects. What is electromagnetic effects? Ki first chase. You need to remember, whenever magnetic field lines, the first thing that you need to remember in electromagnetic effects is that whenever magnetic field lines cut with a solenoid, this change in cutting effect produces what? EMF. Whenever magnetic field lines cut with a solenoid, the change in cutting effect or change in magnetic flux produces EMF. Here we have a scenario. When we push the magnet into the solenoid, when we are pushing the magnet into the solenoid, what will happen? Magnetic field lines cut with the solenoid. As they cut with the solenoid, EMF is produced. The voltmeter deflects to one side on the voltmeter. When the magnet is pulled out, again there is a change in cutting effect. Due to the change in cutting effect, a voltage is again produced, but this time in the opposite direction. Perfect. But this time in the opposite direction. Perfect. Now, if you keep on repeating this process of moving the magnet towards the right, then towards the left, then towards the right, then towards the left, you will generate an alternating voltage here. You will generate an alternating voltage, or you can say an alternating potential difference here. How to draw the graph of this alternating potential difference? Somewhat like this. This is known as induced EMF. This is the conclusion here. The magnetic field lines will cut the coil of the solenoid. When there is a change in cutting effect, EMF or voltage is produced. Now, some students also like to write a change in magnetic flux. That is also perfectly fine. You can also write change in magnetic flux. That will also be correct. No complications here. You can write change in magnetic flux as well. Perfect. You get an induced EMF versus time ka graph like this. Take it. Now let's further move ahead. If you use stronger or powerful magnets, if you use stronger or powerful magnets, what will you have? You will have a greater induced EMF graph like this. If you use more number of turns on the solenoid, your induced EMF again will increase. If your speed of magnet is increased, the towards the speed with which you are moving the magnet, if you increase that, your induced EMF also increases and your frequency also doubles. Perfect. Lastly, if the magnet ki speed is half, the EMF also reduces, the frequency also halves. Perfect. Now let's come on to Lenz's law. Lenz's law states that induced current always flows in a manner to oppose the motion of the magnet. Perfect. Now, can you realize one thing? There was a problem. Although EMF or voltage was being generated here, you don't know the direction of the voltage or EMF. If I remove this voltmeter key directions, you don't know the direction in which the voltage or the current was flowing. To know or to identify the direction of current and voltage, Lenz's law was invented. Lenz's law basically instructs that the direction of induced current always opposes the motion of the magnet. Okay. So let's say the magnet is being pushed in towards the right. Let's say the magnet is being pushed in towards the right. What will be the opposite motion to this? A force towards the left. A force towards the left. How can the magnet apply a force towards the left? If this is your north pole, both will repel, a force towards the left will be applied. See, always remember induced current flows in such a direction so as to oppose the magnet ka motion. Magnet was moving towards the right. How to oppose this? By causing a force towards the left. How can you cause a force towards the left? By taking this as your north pole, north and north repel. Perfect. If this is north pole, this will be your south pole. Now, still you don't have the direction of current. You will apply right hand grip rule. You will apply right hand grip rule. You will apply right hand. Oh, right hand grip rule. What was right hand grip rule? What was right hand grip rule? If your thumb points in the direction of north, your fingers will curl in the direction of the current. Okay. So my north is towards the left hand side. Direction of current is this. My fingers are curling like this. You have the direction of current. Simple. So Lenz's law is used to find the direction of induced EMF or induced current. And whenever the magnetic field lines cut with the solenoid, the change in cutting effect produces EMF. These are two major things that you need to remember from here. Perfect. Now let's move on to transformers. What happens in transformers? In transformers, we have two coils. We have primary coil and secondary coil. The voltage in the primary coil is known as Vp. The current in the primary coil is known as Ip. The number of turns in the primary coil is known as Np. The voltage in the secondary coil is known as Vs. The current in the secondary coil is known as Is. The number of turns in the secondary coil is known as Ns. Now, transformer also works on the same principle. When current passes through the primary coil, when current passes through the primary coil, what will happen? The primary coil will get magnetized and magnetic field lines will be produced. The primary coil will get magnetized and magnetic field lines will be produced. I think I have a diagram of this. One second, one second. I think I have a diagram of this. Yeah. The working of a transformer. How a transformer works basically. Whenever AC current flows through the primary coil, it magnetizes the primary coil. The primary coil starts emitting magnetic field lines labeled by these orange lines. These orange magnetic field lines cut with the secondary coil, inducing EMF, inducing EMF, as magnetic field lines cut with the solenoid, the change in cutting effect produces EMF or voltage, you can say. There are two types of transformers, a step up and a step down transformers. There are two types of transformers, a step up and a step down transformers. Step up transformers are used to increase the voltage. Step up transformers are used to increase the voltage. The secondary voltage in the step up transformer is greater than the primary voltage. Perfect. And the number of turns in the secondary coil is greater than number of turns in the primary coil. For a step down transformer, the primary voltage is greater than the secondary voltage. And also, the number of turns on the primary coil is greater than the number of turns on the secondary coil. Perfect. Number of turns on the primary coil is greater than the number of turns on the secondary coil, and the voltage on the primary coil is greater than the voltage on the secondary coil. This is a step up transformer. This is a step down transformer. Now, there are two formulas that are used in transformers that you need to remember. The first formula is this: number of turns of the primary coil divided by number of turns of the secondary coil is equals to the voltage of primary divided by the voltage of secondary coil. What is the second formula that you need to remember? The voltage of primary coil divided by the voltage of secondary is equals to current of secondary divided by the current of primary. These are the two formulas that you need to remember for transformers if you want an A star grade. Perfect. Now let's move on to the uses of transformer. Transformers are used to transmit electricity. Transformers are used to transmit electricity from generation sites to where the electricity is consumed, that is homes. This is a diagram that I have drawn here. You have this generation side, then you have a step up transformers that increase the voltage, decrease the current. Then you have a step down transformers near the home that decrease the voltage again to the 240 volts की value. Okay. Now, why do we use step up transformers during the initial transmission? To decrease the current. Why? Because as the current decreases, the power losses will decrease. Simple as that. Because power loss is equal to I square R. As the current decreases, the power losses will decrease. Now let's move on to AC generators. Let's move on to AC generators. Now in AC generators, remember two things. In AC generators, you are providing input of what? I think I have written this as well. Yeah. In AC generator, you provide two inputs. What are those two inputs? Magnetic field is provided by you, and a force is provided by you. And a force is provided by you. Can you see in this what you will say AC generator? You have a magnetic field provided that is from north to south, and you are also providing the rotation. You are also providing the rotation. These are your inputs. What is your output? Your output is the induced current. Your output is the induced current. In an AC generator, you have two inputs that are magnetic field and force. Your output is the induced current or induced EMF, whatever you want to call it. Now, always remember whenever you have an AC generator, now this is something that most students forget, so please pay attention here. Whenever you have an AC generator or whenever you have to calculate the direction of current, whenever you have an AC generator or whenever you have to calculate the direction of current, whenever you have an AC generator or whenever you have to calculate the direction of current, whenever you have to calculate the direction of current or whenever you have a AC generator, what formula or what law will you apply? Whenever you have an AC generator, you will apply Fleming's right hand rule. You will apply Fleming's right hand rule. What does Fleming's right hand rule states? Fleming's right hand rule states that if your magnetic field points, or if your first finger points in the direction of the magnetic field, the second finger points in the direction of the force, the middle finger will point in the direction of the current or induced EMF. Simple as that. Now, basically, what does Fleming's right hand rule state? If your magnetic field points in the if your first finger points in the direction of the magnetic field, the thumb points in the direction of force, the second finger will point in the direction of current. Simple as that. You can utilize this to calculate the current key direction in the AC generator. Simple as that. Whenever you have to calculate the direction of current or whenever you have to calculate the current in AC generator, you will apply Fleming left hand rule, Fleming's right hand rule. My bad, sorry. Listen it again. Whenever you have an AC generator or whenever you have to calculate the direction of current, you will apply Fleming's right hand rule. What does Fleming's right hand rule state? If your magnetic field की direction is in the first finger, current force is in the direction of the thumb, your second finger points in the direction of current. Simple. How does the AC generator work? A coil is placed between the magnets. The coil is rotated. You are providing a force, as I have told you. You are also providing a magnetic field. Your output will be what? Your output will be induced EMF or current. Perfect. Where is the induced EMF maximum? The induced EMF is maximum when the coil is in the horizontal position. Why? Because if the coil is in the horizontal position, the force is perpendicular to the magnetic field. Perfect. Where is the induced EMF 0? Induced EMF is 0 when the coil is in the vertical position. Why? Because in the vertical position, force is parallel to the magnetic field. EMF will be 0. Perfect. Now, in a AC generator, you might have noticed something very strange. You might have noticed these rings, slip rings, and you might have noticed these carbon brushes. What are these for? What are these for? Slip rings basically is a device that transfers electrical power from internal circuit to external circuit. And carbon brushes are used for lubrications. Perfect. Now, one more important topic that is both in IGCSE and O levels is the magnetic field pattern around a current carrying wire. If your wire is carrying current out of the page, you will have an anti-clockwise field line. If your wire is carrying current out of the page, you will have an anti-clockwise field line, and the distance between the field lines keeps on increasing, as you can see. However, if your wire is carrying current into the page, you will have a clockwise field line, and again the distance between the field lines keeps on increasing. Simple. You only have to draw the simplified diagram in the examination if the examiner ever asks you. Perfect. Now let's move on to DC motor. What is a DC motor? In a DC motor, your inputs change. Your inputs change in a DC motor. Okay, so I have not written the inputs here. You can write here. In the DC motor, what are your inputs? In the DC motor, what are your inputs? In the DC motor, your inputs include what? In the DC motor, you are providing with what? You are providing with a magnetic field and current. In a DC motor, you are providing with a magnetic field and you are providing with the current. What is your output? What is your output in a DC motor? Your output in a DC motor is force. Please remember, your output in a DC motor is force. Okay, sir, where are we providing current in a DC motor? Can you see this DC battery? This provides the current. You have already the magnets that are providing the magnetic field. This generates a force in the DC motor. Always remember, if you have a DC motor or if you have to calculate the direction of force, you will apply Fleming's left hand rule. If you have a DC motor or if you have to calculate the direction of force, you will always apply Fleming's left hand rule. Make this a key point in your notes. Okay. Now. In a DC motor, there is one more thing to notice. In a DC motor, you don't have slip rings. Instead, you have split ring commutators. In a DC motor, one ring is split into two, that is known as split ring commutators. I have written it here as well, split ring commutators. What is the purpose of a split ring? It changes the direction of current when the coil is in the vertical position at 90 degree and 270 degree. What is the purpose of carbon brushes? They are only used for lubrication or reducing the friction. Now the next topic, that is of CRO, is only for O levels. IT students can rest for 5 minutes. Okay. Now a CRO can be used to calculate the time period, the frequency and the voltage of the waves displayed on the CRO screen. Okay. How can the CRO be used to calculate the voltage, the frequency, and the time period? Let's analyze. Let's analyze this. Let's analyze this. Perfect. Now, you have to understand two things. You have to understand two things. The CRO will get clear to you like daylight. There are two knobs in a CRO. There are two knobs in a CRO. One is the time-based setting. One is the Y gain setting. The time-based setting basically tells you what one box on the x-axis represents. The time-based setting basically tells you what one box on the x-axis represents. Here you can see the time-based setting is at 2 milliseconds. That means one box on the x-axis represents 2 milliseconds. If you have to calculate the time period, that is the time taken to complete one wave. That is these two boxes. If one box on the x-axis represents 2 milliseconds, two boxes will represent 4 milliseconds. Your time period comes out to be 4 milliseconds. Once you have the time period, you can easily calculate the frequency. 1 over time period is your frequency. Now let's come on to how to calculate the voltage. For that, we will be using the Y gain knob. You have to remember that the Y gain knob tells us what one box on the Y axis represents. You have to tell us, the Y gain knob basically tells us that what one box on the Y axis represents. One box on the Y axis is representing 5 volts. Okay. So can you see there are two boxes on the Y axis that represent the maximum voltage? If one division is equals to 5 volts, two division will be equal to 10 volts. Hence, the maximum voltage is equals to 10 volts. Simple as that. This marks the end of unit 4. Let's start with unit 5.
तो सबसे पहले इसमें हम पढ़ेंगे रेडियो एक्टिविटी क्या होता है. रेडियो एक्टिविटी इज़ ऑल्सो नोन एज रेडियो एक्टिव डिके, और इसका मतलब बेसिकली ये होता है इमिशन ऑफ रेडिएशंस. दिस इज़ द इम्पॉर्टेंट कीवर्ड. अगर एग्जाम में कभी आपको आता है कि रेडियो एक्टिविटी की डेफिनेशन बताओ, तो दिस वुड बी एन इम्पॉर्टेंट कीवर्ड फॉर 1 मार्क. emission of radiation from the nucleus of an unstable element. This is your second mark. ठीक है. रेडियो एक्टिविटी क्या होती है बच्चों? emission of radiations from a nucleus of an unstable element. ठीक है. अब ये रेडियो एक्टिविटी या डिके कब तक चलता रहेगा? जब तक ये अनस्टेबल एलिमेंट एक स्टेबल फॉर्म में नहीं आ जाता. ये अनस्टेबल एलिमेंट जब तक एक स्टेबल एलिमेंट नहीं बन जाता ना, तब तक हमारा रेडियो एक्टिव डिके का प्रोसेस चलता रहेगा, कंटिन्यू होता रहेगा. ठीक है, सही है. तो दिस इज़ द बेसिक थ्योरी ऑफ रेडियो एक्टिविटी. अब कितनी टाइप की रेडिएशंस होती हैं बच्चों, ये याद रख लो, ये आपको याद रखना पड़ेगा. अल्फ़ा रेडिएशंस होती हैं, बीटा होती हैं, गामा होती हैं, और तीनों को मिला के टोटल कितने टाइप की रेडिएशंस होती हैं? 3 टाइप्स. एग्जाम में अगर एग्जामिनर आपसे पूछ लेगा हाउ मेनी टाइप ऑफ रेडिएशंस देयर आर, तो आप कहोगे 3, और उनकी टाइप्स क्या क्या है नाम पूछ लेगा अगर, तो क्या बोलोगे? अल्फ़ा, बीटा, गामा. तो फर्स्ट ऑफ ऑल लेट्स स्टडी अल्फ़ा पार्टिकल्स इन डिटेल. अब अल्फ़ा पार्टिकल्स जो हैं वो एक हीलियम का न्यूक्लियस रिप्रेजेंट करते हैं. हीलियम किस तरह रिप्रेजेंट होता है? He42. हीलियम का न्यूक्लियस अगर अल्फ़ा पार्टिकल्स रिप्रेजेंट करते हैं तो इसका मतलब क्या है? इसमें प्रोटॉन्स कितने हुए? प्रोटॉन्स आप लोगों ने केमिस्ट्री पढ़ी है ना, ये नीचे वाले नंबर होते हैं, दैट इज़ 2. न्यूट्रॉन्स कितने होंगे? न्यूट्रॉन्स होंगे दिस मास नंबर, दैट इज़ 4 माइनस द नंबर ऑफ प्रोटॉन्स, 2. अच्छा, जिसने केमिस्ट्री पढ़ी है उसके लिए ये आसान होगा, लेकिन जिसने नहीं पढ़ी उसके लिए मैं शुरू से समझा देता हूँ कि हाउ डिड आई कैलकुलेट द प्रोटॉन एंड न्यूट्रॉन नंबर. ठीक है, हमें एक बात ये याद रखनी है कि अल्फ़ा पार्टिकल्स रिप्रेजेंट द न्यूक्लियस ऑफ अ हीलियम एटम. तो हीलियम एटम किस तरह रिप्रेजेंट होता है? 4 और 2 से. अब केमिस्ट्री में बच्चों आपने ये पढ़ा होगा, अगर नहीं पढ़ा तो रिमेंबर दिस कि ये जो नीचे वाला नंबर होता है, दिस इज़ योर प्रोटॉन नंबर, एंड दिस रिप्रेजेंट्स द नंबर ऑफ प्रोटॉन इन एनी एलिमेंट. तो इसका मतलब प्रोटॉन्स कितने हो गए अल्फ़ा पार्टिकल्स में? 2. और ये जो ऊपर वाला नंबर होता है, दिस इज़ द मास नंबर. और मास नंबर क्या रिप्रेजेंट करता है? कि केमिस्ट्री किसने पढ़ी है? मास नंबर रिप्रेजेंट्स द सम ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स. तो अगर ये 4 है और प्रोटॉन्स और न्यूट्रॉन्स का सम 4 है, और हमें पता है कि प्रोटॉन्स 2 है, 4 - 2 करके न्यूट्रॉन्स आ जाएंगे, 2 न्यूट्रॉन्स हो जाएंगे, सिंपल. ठीक है, तो दिस इज़ द कैलकुलेशन दैट वी डू टू कैलकुलेट द नंबर ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स इन एन अल्फ़ा पार्टिकल. और अल्फ़ा पार्टिकल को हमने हीलियम से क्यों रिप्रेजेंट किया? क्योंकि बेसिकली ये थ्योरी है कि अल्फ़ा पार्टिकल इज़ रिप्रेजेंटेड बाय अ हीलियम न्यूक्लियस, सिंपल. और क्या होता है भाई? 2 प्रोटॉन्स 2 न्यूट्रॉन, सिंपल. अच्छा, अब एक और बात याद रखो केमिस्ट्री से कि प्रोटॉन में चार्ज कौन सा होता है? +1. तो अगर 2 प्रोटॉन्स होते हैं पर अल्फ़ा पार्टिकल, तो अल्फ़ा पार्टिकल का चार्ज क्या हो जाएगा, +2। सिंपल लॉजिक की बात है, ठीक है। अल्फ़ा पार्टिकल कैन बी रिप्रेजेंटेड बाय हीलियम 42He और अल्फ़ा 42, ठीक है, ये भी याद रख लो। फिफ्थ बात क्या है, फिफ्थ बात ये है कि अल्फ़ा पार्टिकल्स व्हेन इमिटेड फ्रॉम द रेडियस फ्रॉम एन अनस्टेबल एलिमेंट, इनकी स्पीड क्या होती है एयर में, दैट इज़ 10% ऑफ द स्पीड ऑफ लाइट। दिस इज ऑल्सो एन इम्पॉर्टेंट पॉइंट। अच्छा बच्चों, ये जो सारे पॉइंट्स मैंने लिखे हुए ना, ट्राई टू मेमोराइज इट, या एटलीस्ट अपने दिमाग में रख लो, सो दैट इन पेपर अगर आपके पास कोई भी प्रॉपर्टी आती है अल्फ़ा पार्टिकल की लिखने के लिए, या एमसीक्यू में आता है कि ये प्रॉपर्टी है अल्फ़ा पार्टिकल की नहीं, तो यू वुड बी ईजियर टू डू इट, ठीक है। अब आ जाओ सिक्स पार्ट पे, सिक्स प्रॉपर्टी पे, सॉरी। अल्फ़ा पार्टिकल्स हैव लीस्ट पेनिट्रेशन पावर, ठीक है। हमने अभी तक क्या पढ़ा, अल्फ़ा पार्टिकल जो है 10% ऑफ द स्पीड ऑफ लाइट से एयर में ट्रैवल करते हैं और दे हैव लीस्ट पेनिट्रेशन पावर, ठीक है। ये हमने एक और पॉइंट पढ़ लिया। और लीस्ट पेनिट्रेशन पावर है तो दे कैन बी स्टॉप्ड बाय पेपर और कार्डबोर्ड, ठीक है। अल्फ़ा बीटा गामा में से सबसे लीस्ट पेनिट्रेशन पावर किसकी होगी बच्चों, अल्फ़ा पार्टिकल्स की, हेंस दे विल बी स्टॉप बाय पेपर और कार्डबोर्ड, सिंपल, ठीक है। दे हैव अ रेंज ऑफ, अच्छा अब 7th पॉइंट क्या है, दे हैव अ रेंज ऑफ 4 to 5 सेंटीमीटर्स इन एयर, सिंपल, ठीक है, ये लिखा हुआ है, सिंपल पॉइंट है, इट इज़ अंडरस्टैंडेबल, ठीक है। अच्छा अभी तक हमने क्या पढ़ लिया, फिफ्थ प्रॉपर्टी हमने पढ़ी थी कि 10% ऑफ स्पीड ऑफ लाइट होती है इनकी एयर में। सिक्स प्रॉपर्टी क्या थी कि दे हैव द लीस्ट पेनिट्रेशन पावर। सेवन्थ क्या थी कि दे कैन ट्रैवल अ रेंज ऑफ 4 to 5 सेंटीमीटर्स। 8 क्या है, दे हैव द मैक्सिमम आयोनाइजिंग पावर। अब आयोनाइजिंग होती क्या है, जब भी अल्फ़ा पार्टिकल्स एयर मॉलिक्यूल के साथ टकराते हैं ना, तो दे रिमूव इलेक्ट्रॉन्स फ्रॉम द एयर मॉलिक्यूल्स, ठीक है। और जब इलेक्ट्रॉन्स मूव हो जाएंगे एयर मॉलिक्यूल से तो क्या हो जाएंगे, वो नेगेटिवली चार्ज पॉजिटिवली चार्ज हो जाएंगे, और पॉजिटिवली चार्ज हो जाएंगे एयर पार्टिकल्स। तो जब एयर पार्टिकल्स पॉजिटिवली चार्ज हो जाते हैं तो वी कॉल दिस आयोनाइजेशन ऑफ एयर मॉलिक्यूल्स, एंड अल्फ़ा पार्टिकल्स हैव द मैक्सिमम आयोनाइजिंग पावर, सिंपल, ठीक है। अब आ जाओ नेक्स्ट पे 9 पे, ठीक है। अब अल्फ़ा पार्टिकल की इक्वेशन देख लो बच्चों। जब भी आपके पेरेंट न्यूक्लियस से, सपोज कर लो एक्स एक एलिमेंट था और इसको हम पेरेंट न्यूक्लियस कह लेते हैं, इससे जब भी एक अल्फ़ा पार्टिकल निकलेगा ना, तो मास नंबर से, जैसे कि हमने ऊपर डिस्कस किया था कि मास नंबर ऊपर वाला होता है, इससे 4 माइनस होगा, और प्रोटॉन नंबर से क्या माइनस होगा, 2, ठीक है। तो इसका आंसर क्या आना चाहिए, Y21680, सिंपल यही आया हुआ है, ठीक है। और अल्फ़ा पार्टिकल को रिप्रेजेंट किस तरह करोगे, ऑन द प्रोडक्ट साइड बाय आइदर अल्फ़ा सिंबल, ठीक है, या फिर हीलियम का सिंबल। ये हमने पहले भी पढ़ा था, ठीक है। ये देखो, ये न्यूक्लियस का जो सिंबल रिप्रेजेंटेड है यहाँ पे, ठीक है। तो आई होप दिस इज क्लियर। नाउ लेट्स मूव ऑन टू अ नेक्स्ट टाइप ऑफ पार्टिकल्स दैट वर बीटा पार्टिकल्स, ठीक है। अब बीटा पार्टिकल्स को पढ़ते हैं, ठीक है। अब बीटा पार्टिकल्स की भी कुछ इस तरह 6-7 प्रॉपर्टीज़ हैं जो आपको याद रखनी है। बीटा पार्टिकल रिजेंबल्स एन इलेक्ट्रॉन। अब इलेक्ट्रॉन किस तरह का होता है बच्चों, इलेक्ट्रॉन में बेसिकली ज़ीरो न्यूट्रॉन्स होते हैं और एक नेगेटिव का चार्ज होता है। सो दिस इज़ द रिप्रेजेंटेशन ऑफ बीटा। और बीटा को एक और तरीके से रिप्रेजेंट करते हैं, 0-1, इस तरह से रिप्रेजेंट करते हैं, ठीक है। इट हैज़ अ नेग्लेजिबल मास एंड कैरीज अ चार्ज ऑफ -1। बिल्कुल रीजनेबल बात है, क्योंकि इलेक्ट्रॉन एक है, बेसिकली बीटा पार्टिकल रिप्रेजेंट बाय द इलेक्ट्रॉन, तो इलेक्ट्रॉन का चार्ज क्या होता है, नेगेटिव, सिंपल। और एक इलेक्ट्रॉन यूज़ हो रहा है तो नेगेटिव चार्ज आएगा सिर्फ 1 का, सिंगल का। अच्छा, बीटा पार्टिकल्स कैन ट्रैवल विद द अप्रॉक्सीमेट स्पीड ऑफ 90% ऑफ द स्पीड ऑफ लाइट। अल्फा कितने से ट्रैवल कर रहा था, 10% से, ठीक है। और अब आ जाओ बीटा की पेनिट्रेशन पावर देखते हैं। बीटा हैज़ द मीडियम पेनिट्रेशन पावर, अल्फा की क्या थी, लोअर। अब मीडियम पेनिट्रेशन पावर है तो ये कार्डबोर्ड या पेपर से स्टॉप नहीं होगा, देखो इट कैन पेनिट्रेट थ्रू पेपर और कार्डबोर्ड, तो इसके लिए हम एक एल्युमिनियम शीट यूज़ करते हैं, ठीक है। बीटा पार्टिकल्स कैन ट्रैवल अ फ्यू मीटर्स इन एयर। अल्फा पार्टिकल्स कितना ट्रैवल कर रहे थे, फ्यू सेंटीमीटर्स, ठीक है। एंड बीटा पार्टिकल्स आर स्मॉलर इन साइज, हेंस इसकी आयोनाइजेशन पावर क्या होगी बच्चों, मीडियम। अल्फा पार्टिकल की क्या थी, मैक्सिमम। अब जब भी बीटा पार्टिकल इमिट होता है किसी पार्टिकल से, तो देख लेते हैं क्या इक्वेशन बनेगी। जब भी बीटा पार्टिकल किसी मॉलिक्यूल या न्यूक्लियस से इमिट होता है, तो ये जो प्रोटॉन नंबर है इसमें हम +1 कर देते हैं। तो यहाँ पे एंड रिजल्ट क्या आना चाहिए, 21, और प्रोटॉन मास नंबर जो है उसी तरह रहता है, 20 से 21 हम चले गए, ठीक है। दैट इज़ हमने +1 कर दिया इन प्रोटॉन नंबर, और न्यूट्रॉन नंबर को या मास नंबर को वैसे ही रहने दिया, और प्रोडक्ट साइड में हमने एक बीटा पार्टिकल भी दिखा दिया सिंपली, ठीक है। तो नाउ लेट्स मूव ऑन टू आवर नेक्स्ट टाइप ऑफ पार्टिकल, जो कि कौन से, अच्छा चलो ये सवाल भी कर लेते हैं। लेट्स डू दिस सवाल, ठीक है। हमारे पास क्या था, X23084 नाम का एक पेरेंट न्यूक्लियस था। इससे एक अल्फा पार्टिकल इमिट हुआ, फिर बीटा, फिर बीटा, फिर अल्फा, फिर अल्फा, फिर बीटा। सो लेट्स सी द फाइनल प्रोडक्ट किस तरह की होगी। इनिशियली जब पहले अल्फा इमिट होगा तो 230 में से हम क्या माइनस करेंगे, ऊपर वाली वैल्यूज से मास नंबर से क्या माइनस होता था 4, नीचे से क्या माइनस होता था 2, तो क्या हो जाएगा 22682 x बन जाएगा, ठीक है। ये हमने एक अल्फा पार्टिकल कवर कर दिया। अब एक जब बीटा माइनस होगा तो क्या होगा, जब एक बीटा माइनस होगा तो क्या होगा, सिर्फ इसमें 1 ऐड हो जाएगा, 22683x, ठीक है। अब वापस बीटा पार्टिकल माइनस हो रहा है, ठीक है, तो क्या हो जाएगा, वापस +1 हो जाएगा, 22684x, ठीक है। अब क्या हो रहा है, अब एक अल्फा पार्टिकल इमिट हो रहा है। अल्फा पार्टिकल इमिट होता था तो क्या होता था, वी -4 फ्रॉम 2 to 6, 2 to 6 से हम -4 कर देते हैं यार, -4 कर दिया यहाँ पे, और इससे -2 कर देते हैं, तो क्या हो गया 22282x, ठीक है। अब वापस अल्फा पार्टिकल इमिट होगा तो क्या होगा, वापस अल्फा पार्टिकल इमिट होगा तो -4 एंड -2, तो क्या हो जाएगा 21880x, ठीक है। अब क्या इमिट होगा, अब बीटा इमिट होगा, बीटा इमिट होगा तो यहाँ पे +1 हो जाएगा, तो क्या हो जाएगा 21881x, और देखो ये हमारा आंसर सिमिलर आ रहा है टू द इनिशियल सोल्यूशन दैट वाज डन बाय मी, सिमिलर, ठीक है। नाउ लेट्स मूव ऑन टू अ नेक्स्ट टाइप ऑफ पार्टिकल्स दैट आर गामा पार्टिकल्स। गामा पार्टिकल्स या गामा रेडिएशंस, तो गामा रेडिएशंस आर बेसिकली इलेक्ट्रोमैग्नेटिक वेव्स, ठीक है, ये एक इंपॉर्टेंट पॉइंट याद रखो, ठीक है। उसके बाद क्या है, दे नाइदर हैव अ मास नॉर चार्ज। अभी तक अल्फा बीटा में हमने देखा कि उनका चार्ज था और कुछ मास भी था, और ये रिप्रेजेंट किससे होते हैं, 0 0 या इस सिंबल से, ठीक है। अब आ जाओ नेक्स्ट पॉइंट पे, दैट इज पॉइंट 4, दे ट्रैवल विद द सेम स्पीड एज द स्पीड ऑफ लाइट। बीटा किससे ट्रैवल कर रहा था, 90% ऑफ द स्पीड ऑफ लाइट। अल्फा किससे ट्रैवल कर रहा था, 10% ऑफ द स्पीड ऑफ लाइट, और दे हैव द मैक्सिमम रेंज इन एयर, ठीक है। और इनकी आयोनाइजेशन पावर क्या है, दे हैव ज़ीरो, निग्लेजिबल और ज़ीरो आयोनाइजेशन पावर। लेकिन इनकी एक इम्पॉर्टेंट बात ये है कि दे हैव मैक्सिमम पेनिट्रेशन पावर। अल्फा की क्या थी, लीस्ट पेनिट्रेशन पावर, दे कुड बी स्टॉप बाय कार्डबोर्ड और पेपर। बीटा की क्या थी, बीटा की थी मीडियम पेनिट्रेशन पावर, तो उसको किससे स्टॉप करते थे, एल्युमिनियम शीट से। गामा की जो है मैक्सिमम पेनिट्रेशन पावर है, तो इसको ना आप कार्डबोर्ड से स्टॉप कर सकते हो, ना पेपर से, ना एल्युमिनियम शीट से। इसके लिए एक थिक लेड शीट चाहिए, ठीक है। अब आ जाओ इसकी नेक्स्ट पे, ठीक है, नेक्स्ट टॉपिक पे। अच्छा, दिस इज़ पॉजिटिवली चार्ज मेटल प्लेट एंड नेगेटिवली चार्ज मेटल प्लेट, और हमने तीनों टाइप्स ऑफ पार्टिकल्स को इसके थ्रू करने की कोशिश की है और देखा है कि किस तरह दे आर डिफ्लेक्टेड। गामा वुडंट बी डिफ्लेक्टेड, वाई, क्योंकि इसके ऊपर नाइदर चार्ज है नॉर एनी मास है, ठीक है। एंड बीटा विल बी डिफ्लेक्टेड टुवर्ड द पॉजिटिव प्लेट, क्यों, क्योंकि ये नेगेटिव है। अल्फा विल बी डिफ्लेक्टेड टुवर्ड्स द नेगेटिव प्लेट, क्यों, क्योंकि पॉजिटिव है। अब एक और बात जो इंपॉर्टेंट है यहाँ पे नोट करने वाली, वो ये है कि बीटा जो है वो देख रहे हो ज़्यादा जल्दी डिफ्लेक्ट होकर मेटल प्लेट को हिट कर रहा है कंपेयर टू अल्फा, क्यों, क्योंकि बीटा इज़ लाइटर, हैंस वो ज़्यादा जल्दी डिफ्लेक्ट करके पॉजिटिव प्लेट्स को रीच कर जाएगा, सिंपल, ठीक है। नाउ लेट्स मूव ऑन टू अ नेक्स्ट टॉपिक, दैट इज सेफ्टी कंसिडरेशंस व्हाइल हैंडलिंग रेडियो एक्टिव सब्सटेंसेज। ये कुछ सेफ्टी के रूल्स हैं दैट वी फॉलो व्हाइल हैंडलिंग रेडियो एक्टिव सब्सटेंसेज। फर्स्ट ऑफ ऑल क्या है कि व्हेन अ रेडियो एक्टिव सब्सटेंस इज नॉट इन यूज, आप उसको किस में रखोगे, एक लेड बॉक्स में रखोगे। अब लेड क्यों यूज होता है भाई, लेड जो है वो सारी रेडिएशन को स्टॉप कर देगा, गामा को तो स्टॉप करेगा ही करेगा जिसकी मैक्सिमम पेनिट्रेशन पावर है, अल्फा और बीटा को भी स्टॉप कर लेगा, सिंपल। सेकंड प्रिकॉशन क्या है बच्चों, सेकंड प्रिकॉशन हमारा ये है कि लेट्स मूव दिस डाउन अ बिट, ठीक है। सेकंड प्रिकॉशन हमारा ये है कि द यूज़र और जो पर्सन जो यूज़ कर रहा है ना रेडियो एक्टिव सोर्स को, वो हमेशा सोर्स के बिहाइंड स्टैंड करे, ठीक है, सोर्स के आगे स्टैंड ना करे, हमेशा सोर्स के बिहाइंड स्टैंड करे, ठीक है। यूज़र मस्ट ऑल्सो फॉलो सोर्स हैंडलिंग टूल्स, ठीक है, सोर्स हैंडलिंग टूल्स होनी चाहिए उसके पास। और रेडियो एक्टिव मटीरियल शुड नॉट बी प्लेस क्लोज टू द फूड आइटम्स, ये हमारा फोर्थ प्रिकॉशन है। बेसिकली दीज प्रिकॉशंस यू विल हैव टू रिमेंबर, ठीक है, या जहन में बिठा लो या रिफ्रेश करके कुछ मतलब कर लो, लेकिन यू विल हैव टू रिमेंबर दिस, ठीक है। रेडियो एक्टिव सोर्स मस्ट नॉट बी पॉइंटेड टूवर्ड्स एनीवन्स आई, सिंपल, ठीक है। व्हेन अ रेडियो एक्टिव सोर्स इज़ टू बी डिस्पोज, जब भी रेडियो एक्टिव सोर्स का काम खत्म हो जाता है और इसको डिस्पोज किया जाता है, इसको एक लेड कंटेनर में डिस्पोज किया जाता है, सिंपल, ठीक है। और बरीड अंडरग्राउंड करते हैं इसको डिस्पोज करने के लिए, सिंपल। अब हमने सेफ्टी प्रिकॉशंस भी पढ़ लिए रेडियो एक्टिव सोर्सेज के, अब पढ़ते हैं इसके यूजेस। रेडियो एक्टिव सोर्सेज के हमारे सिलेबस में बेसिकली 3 यूजेस हैं। फर्स्ट ऑफ ऑल मेडिकल यूजेज, इट इज़ यूज फॉर स्टेरिलाइजेशन पर्पजेज, ठीक है, एज, और यहाँ पे मैंने बता भी दिया है कि किस तरह यूज़ होंगे, कि रेडियो एक्टिव सब्सटेंसेज जो हैं वो कोबाल्ट, जैसे कि कोबाल्ट जो है वो गामा रेज इमिट करता है, दैट इज़ यूज टू किल कैंसरस सेल एंड स्टेरिलाइज ऑब्जेक्ट्स, ठीक है। अब आ जाओ सेकंड पॉइंट पे, दैट इज सेकंड यूज़ क्या है रेडियो एक्टिव सब्सटेंसेज का, इंडस्ट्रियल यूज़ है। दे आर यूज टू चेक लीकेजेस इन पाइप, ठीक है, यहाँ से आप पिंक वाले डॉट्स जो है वो रेडियो एक्टिव सोर्सेज डालोगे, और अगर ऑरेंज वाले डॉट्स जो हैं, अगर पाइप के दूसरे साइड पे आपको रेडियो एक्टिव सब्सटेंसेज मिल जाते हैं थ्रू डिटेक्टर, दिस मीन्स देयर इज़ अ लीकेज इनसाइड। इसमें लीकेज इनसाइड आप बेसिकली इस तरह देखते हो, अगर मैं सिंपल लफ्ज़ों में आपको बताऊँ तो पाइप के अंदर आप रेडियो एक्टिव सोर्सेज छोड़ते हो थोड़ी सी, एंड इफ़ ऑन द अदर साइड यू फाइंड द रेडियो एक्टिव सोर्सेज सच एज द ऑरेंज बॉल्स व्यू द वे द डिटेक्टर, मतलब आप अगली साइड पे जो है पाइप के एक डिटेक्टर लगाते हो और रेडियो एक्टिव सोर्सेज फाइंड करते हो, तो दिस मीन्स देयर आर लीकेजेस इन पाइप। थर्ड टाइप ऑफ यूज़ क्या है रेडियो एक्टिव सब्सटेंसेज का, थर्ड टाइप ऑफ यूज़ रेडियो एक्टिव सब्सटेंसेज का ये है कि दे आर यूज टू डिटेक्ट द थिकनेस ऑफ मेटल। अब अगर हमारी मेटल की शीट दैट इज़ दिस वन अगर बहुत थिक होगी, मतलब इसकी थिकनेस वुड बी ग्रेटर, ठीक है, तो यहाँ पे डिटेक्टर पे जो रीडिंग आएगी ना दैट वुड बी लोअर, रीडिंग लोअर। हाउ एवर अगर थिकनेस कम होगी बच्चों तो क्या होगा, रीडिंग हायर होगी, थिकनेस कम होगी तो रीडिंग हायर होगी। तो इस तरह हम डिज़ाइन कर सकते हैं एन एक्सपेरिमेंट टू कैलकुलेट द थिकनेस ऑफ द मेटल शीट्स, और ये एक यूज़ भी है रेडियो एक्टिव सब्सटेंसेस का, ठीक है। अब कौन कौन से टाइप्स ऑफ डिटेक्टर जो हैं, वो ये वाला जो डिटेक्टर है दैट इज़ दिस वाला, ये कौन कौन से डिटेक्टर्स हम यूज़ करते हैं इन रेडियो एक्टिविटी। 2 तरह के डिटेक्टर्स होते हैं बच्चों, क्लाउड चेम्बर डिटेक्टर्स एंड जीएम ट्यूब डिटेक्टर्स। जीएम ट्यूब का फुल फॉर्म होता है गाइगर मुलर ट्यूब्स। तो फर्स्ट ऑफ ऑल हम जो है गाइगर मुलर ट्यूब्स की कंस्ट्रक्शन देख लेते हैं, ठीक है। गाइगर मुलर ट्यूब्स बनती किस तरह है, सपोज करो ये आपका सोर्स है इन अ लेड बॉक्स, दिस इज अ सोर्स इन अ लेड बॉक्स, ये एक गाइगर मुलर ट्यूब है और दिस कलेक्ट्स रेडिएशन एंड डायरेक्ट्स देम टू अ काउंटर, ठीक है, और काउंटर पे ये एक स्क्रीन लगी हुई है जिसके थ्रू आप देख सकते हो कि कितनी रेडियो एक्टिव सब्सटेंसेज आ रही हैं, और एक टाइमर लगा हुआ है विच सेट्स द सेटिंग के, लेट सपोज आपकी रेडियो एक्टिव रेडिएशंस आ रही हैं, लेट सपोज 1200 आ रही हैं, ठीक है। अब टाइमर क्या करेगा कि टाइमर विल अलाउ यू टू गिव के ये 1200 जो रेडिएशंस आ रही हैं वो पर मिनट आ रही हैं, पर 5 मिनट आ रही हैं, ठीक है, पर 30 मिनट आ रही हैं, टाइमर आपको ये बताएगा, ठीक है। सो इफ़ यू सेट दिस टाइमर एट 1 मिनट और आपकी रीडिंग यहाँ पर 1200 आ रही है, तो इसका मतलब क्या है, इसका मतलब ये है कि 1 मिनट में 1200 रीडिंग्स आ रही हैं, सिंपल, ठीक है। तो दिस इज़ द यूज़ ऑफ द टाइमर। लेट्स रिपीट इट। टाइमर का यूज़ क्या है, टाइमर का यूज़ ये है बेसिकली कि टाइमर पे जो आप टाइम सेट करोगे उस टाइम में कितनी रेडिएशन आएंगी वो आपको इस स्क्रीन पे दिखेंगी। सपोज करो मैंने टाइम जो है 1 मिनट पे सेट किया हुआ है तो 1200 आ रहा है, तो इसका मतलब ये है कि 1 मिनट में 1200 रेडिएशन जो है वो गाइगर मुलर ट्यूब कलेक्ट कर रही है, सिंपल, ठीक है। ये देखो यहाँ पे मैंने एक्सप्लेन भी की हुई है यही बात। Looking at the counter, we can conclude that the radioactive source in front of the GM tube produces 1200 radiations per minute. अब पर मिनट वाली बात कहाँ से आई, पर मिनट वाली बात टाइमर से आई। अगर यहाँ पे टाइमर जो है लेट मी मार्क इट इन पिंक, ये 5 मिनट्स पे होता और रीडिंग यहाँ पे 6000 होती, तो क्या कहते हैं हम 6000 रेडिएशंस पर 5 मिनट्स, और फिर इसको 1 मिनट के लिए निकाल लेते, दैट वुड बी इक्वल टू 1200 रेडिएशंस पर मिनट, सिंपल। टाइमर का इसमें सिर्फ ये काम होता है कि इट गिव्स यू अ टाइम जिन अराउंड विच कितनी रेडिएशंस आई हैं, ठीक है। मिनट पे रखा है तो वो बताएगा कितने मिनट में रेडिएशंस आई हैं इतनी, और 5 मिनट पे रखा है तो वो बताएगा कितने 5 मिनट में कितनी रेडिएशन आई हैं। नाउ लेट्स मूव ऑन टू अवर नेक्स्ट टॉपिक, एंड नेक्स्ट टॉपिक इज ऑफ काउंट रेट। अब काउंट रेट क्या होता है? काउंट रेट इज बेसिकली द नंबर ऑफ रेडिएशन प्रोड्यूस बाय अ रेडियो एक्टिव सोर्स इन अ सर्टेन इंटरवल ऑफ टाइम। सिंपल, ठीक है। When a GM tube is connected to a counter, it is used to measure the count rate inside a radioactive substance. Simple, ठीक है। ये जो हमने यहाँ पे 1200 की रीडिंग निकाली थी ना बच्चों, दिस इज़ द काउंट रेट। सिंपल, ठीक है। ओके, अब आ जाओ GM ट्यूब प्लस काउंटर पे एक्सपेरिमेंट करते हैं, ठीक है। दिस डिवाइस GM ट्यूब इज ऑल्सो यूजफुल इन इन्फॉर्मिंग विच टाइप ऑफ रेडिएशन इज इमिटेड बाय द सोर्स, ठीक है। अब हम GM ट्यूब और काउंटर को यूज़ करके देखेंगे कि कौन सी टाइप ऑफ रेडिएशन जो है वो सोर्स इमिट कर रहा है। कितने टाइप की रेडिएशन होती हैं? 3। तो अब ये अरेंजमेंट यूज़ करके हम देखेंगे कि कौन सी इन तीनों में से, जो कि कौन कौन सी होती थी, अल्फ़ा, गामा, बीटा एंड गामा, में से कौन सी रेडिएशन जो है वो सोर्स इमिट कर रहा है बाय यूजिंग गाइगर मुलर ट्यूब एंड द काउंटर, ठीक है। अब लेट सपोज ये आपका सोर्स है, दिस पिंक वन इज योर सोर्स, ठीक है। दिस इज योर सोर्स। अब सोर्स कुछ इमिट कर रहा होगा रेडियो एक्टिव रेडिएशन, और इनिशियली लेट सपोज वी डोंट हैव दिस पेपर इन बिटवीन, ठीक है। तो क्या होगा, जब सोर्स डायरेक्टली इमिट कर रहा होगा टुवर्ड द गाइगर मुलर ट्यूब तो एक रीडिंग आ रही होगी 1200 की, ठीक है। बट देन व्हेन यू प्लेस द पेपर इन बिटवीन द गाइगर मुलर ट्यूब एंड द सोर्स, तो क्या आपने देखा, आपने ये ऑब्जर्व किया कि रीडिंग जो है वो 1200 से गिर के क्या हो गई है, 0। तो आपके पेपर ने सारी रेडियो एक्टिव सोर्सेज को स्टॉप कर दिया है। तो कौन सी ऐसी रेडिएशन थी जो पेपर से स्टॉप हो जाती थी? अल्फा पार्टिकल। तो द सोर्स ओनली कंटेन्स अल्फा पार्टिकल्स। देखो यहाँ पे कंक्लूजन पे भी मैंने लिखा हुआ है, अल्फा पार्टिकल्स कैन बी स्टॉप बाय वेपर, हेंस द सोर्स कंटेन्स ओनली अल्फा पार्टिकल्स। अब एक और एग्जांपल देखते हैं। अब इनिशियली जब नो बैरियर था तब आपका काउंट रेट क्या था, 1200। विथ पेपर आपका काउंट रेट क्या रहा, 1200। इसका मतलब क्या हुआ कि नो अल्फा पार्टिकल्स, क्योंकि अगर अल्फा होते तो पेपर से रुक जाते, काउंट रेट में डिक्रीज आ जाता। लेकिन विद एल्यूमिनियम आपका काउंट रेट गिर गया। तो इसका मतलब क्या है कि एल्युमिनियम कौन से पार्टिकल्स रोकता है, बीटा पार्टिकल्स। और एल्युमिनियम जब आपने बीच में लगाया बिटवीन द सोर्स एंड द गाइगर मुलर ट्यूब तो आपका काउंट रेट गिर गया। इसका मतलब क्या है कि देयर आर बीटा पार्टिकल्स प्रेजेंट इन द सोर्स, ठीक है। ये देखो यहाँ पे मैंने एक्सप्लेनेशन लिखी हुई है। अब जब आपने लेड के साथ लेड प्लेस किया इन बिटवीन द सोर्स एंड द गाइगर मुलर ट्यूब तो आपका काउंट रेट 0 पे आ गया। तो व्हाट डज दिस मीन, जो आपका सोर्स है उसमें गामा पार्टिकल भी प्रेजेंट है, तो हेंस आपकी रीडिंग 0 हो जाती है। सिंपल, ठीक है। कंक्लूजन क्या है, अल्फा नॉट प्रेजेंट। क्यों नहीं प्रेजेंट है, क्योंकि जब आपने पेपर लगाया बीच में तो 1200 की 1200 ही रीडिंग रही, ठीक है। जब पेपर लगाया तो 1200 से 1200 ही रही। लेकिन जब आपने एल्युमिनियम लगाया तब रीडिंग गिरी, और लेड लगाया तब भी रीडिंग 0 पे आ गई। तो इसका मतलब क्या है कि बीटा एंड गामा वर प्रेजेंट एंड अल्फा वर अनप्रेजेंट, ठीक है। अब आ जाओ एक और एग्जाम्पल पे। अब इसमें जब हमारे पास नो बैरियर था तब हमारी रीडिंग क्या थी, 3200। जब पेपर लगाया तो रीडिंग गिर गई, इसका मतलब क्या है, अल्फा प्रेजेंट है। जब हमने एल्युमिनियम लगाया तो रीडिंग वापस गिर गई, इसका मतलब बीटा प्रेजेंट है। जब हमने लेड लगाया तब भी रीडिंग गिर गई, इसका मतलब ऑल 3 आर प्रेजेंट। गामा भी प्रेजेंट है, अल्फा भी प्रेजेंट है और बीटा भी प्रेजेंट है। सो लेट्स लुक एट द कंक्लूजन, ऑल 3 टाइप्स ऑफ रेडिएशन आर प्रेजेंट। सिंपल, ठीक है। अब आ जाओ नेक्स्ट एग्जाम्पल पे। जब नो बैरियर था तो रीडिंग 4300 थी। जब विद पेपर के साथ हमने किया तो वही रीडिंग रही, नो अल्फा। जब एल्युमिनियम के साथ किया तब भी वही रीडिंग थी, नो बीटा। जब लेड के साथ किया तो रीडिंग 0 हो गई। तो इसका मतलब गामा आर प्रेजेंट। गामा का सिंबल मैंने गलत मार्क कर दिया है और आप लोगों ने नोटिस भी नहीं किया। लेट मी रीइंस्टेट दिस अगेन एंड मार्क इट हेयर, ठीक है। दिस इज द गामा का सिंबल प्रेजेंट, ठीक है। कंक्लूजन में क्या लिखा है, ओनली गामा प्रेजेंट बिकॉज नो ड्रॉप विद पेपर एंड एल्युमिनियम विच कन्फर्म्स नो अल्फा एंड बीटा। सिंपल, ठीक है। अब आ जाओ, अच्छा इसमें बच्चे गलती क्या करते हैं कभी कभार, दे डायरेक्टली प्लेस लेड, ठीक है, नो बैरियर की रीडिंग लेते हैं उसके बाद डायरेक्टली लेड प्लेस कर देते हैं। सो दिस इज़ रॉन्ग, क्योंकि अगर डायरेक्टली आप लेड प्लेस करोगे तो ऑब्वियसली बात है सारी रेडिएशन रुक जाएंगी और ज़ीरो की रीडिंग आ जाएगी, बट इट वुडंट टेल यू कि अल्फ़ा प्रेजेंट थी, गामा प्रेजेंट थी या बीटा प्रेजेंट थी, ठीक है। सो नेवर प्लेस लेड फर्स्ट, हमेशा पेपर से शुरू करो, फिर एल्युमिनियम प्लेस करो, फिर लेड प्लेस करो, ठीक है। अब आ जाओ हमारे नेक्स्ट कॉन्सेप्ट पे, व्हाट इज़ बैकग्राउंड रेडिएशन। बैकग्राउंड रेडिएशन वो रेडिएशन होती हैं जो ऑलरेडी नेचर में प्रेजेंट होती हैं विदाउट द रेडियो एक्टिव सोर्स, ठीक है। नेचर में ऑलरेडी भी कुछ बैकग्राउंड रेडिएशन प्रेजेंट होती हैं दैट आर सेपरेट फ्रॉम द एक्चुअल सोर्स, ठीक है। और वो क्या, वो बहुत स्मॉल वॉल्यूम्स में होती हैं और उनका काउंट रेट 20 to 30 पर मिनट होता है, ठीक है। बैकग्राउंड रेडिएशंस की सोर्सेज क्या हैं, कॉस्मिक रेज फ्रॉम सन, नेचुरली अकरिंग रेडियो एक्टिव मटीरियल्स, ग्रेनाइट, न्यूक्लियर फेलियर्स, अनस्टेबल आइसोटोप्स, लिविंग थिंग्स कैन ऑल्सो बी अ सोर्स, ठीक है। बेसिकली ये सारे आपके सोर्सेज हैं फॉर बैकग्राउंड रेडिएशन, ये आपको थोड़े बहुत याद होने चाहिए, 2-3 कभी कभार एग्जाम में आ सकते हैं। अच्छा, बैकग्राउंड रेडिएशन को आप एडजस्ट किस तरह करोगे अपने आंसर में, बिफोर कैलकुलेटिंग द रीडिंग ऑफ योर सोर्स विद द जीएम ट्यूब, सबसे पहले आप क्या करोगे, बैकग्राउंड रेडिएशन कैलकुलेट करोगे। वो किस तरह होती है कि फर्स्ट ऑफ ऑल आप जो अपनी सोर्स होती है दैट इज एनी रेडियो एक्टिव पार्टिकल, आप इसको हटा देते हो फ्रॉम द जीएम ट्यूब की फ्रंट वाली साइड से एंड जस्ट कैलकुलेट द रीडिंग्स ऑफ द बैकग्राउंड रेडिएशन, ठीक है। लेट सपोज आपकी 20 आई, फिर आपने क्या किया, फिर आपने जाके गाइगर मुलर ट्यूब के आगे ये सोर्स प्लेस कर दी, सिंपल, और उसके बाद एक रीडिंग ले ली दैट इज इक्वल टू 770। अब ये जो रीडिंग आई है दिस इंक्लूड्स बैकग्राउंड रेडिएशन प्लस दिस सोर्स की रीडिंग विच इज़ नॉट एक्यूरेट, क्योंकि हमें तो सिर्फ सोर्स की चाहिए। तो आप सिर्फ सोर्स की कैसे निकालोगे, आपने फर्स्ट स्टेप में क्या निकाली थी, बैकग्राउंड रेडिएशन, सेकंड में क्या निकाली है, बैकग्राउंड प्लस सोर्स। तो फर्स्ट स्टेप में जो बैकग्राउंड निकाली थी अगर वो यहाँ पे आके माइनस कर दोगे तो आपके पास सिर्फ सोर्स की रीडिंग आ जाएगी, सिंपल। लेट्स सी व्हाट वी आर डूइंग इन द थर्ड स्टेप, subtract the background radiation from the final reading to obtain the actual count rate from the radioactive source, simple। बैकग्राउंड रीडिंग क्या थी 20, टोटल क्या थी आपकी 770, टोटल में से बैकग्राउंड माइनस कर दी तो एक्चुअल रीडिंग ऑफ द रेडियो एक्टिव सोर्स आ गई। और इस एक्सपेरिमेंट को आप वापस रिपीट करोगे एंड विल एवरेज आउट द रीडिंग्स टू गेट अ मोर एक्यूरेट वैल्यू, ठीक है। नाउ लेट्स मूव ऑन टू अवर नेक्स्ट टॉपिक दैट इज व्हाई इज रेडियो एक्टिविटी अ रैंडम प्रोसेस। कभी कभार जो है एग्जामिनर आपको कह देगा कि यार रेडियो एक्टिविटी रैंडम प्रोसेस क्यों है, ठीक है। तो आप उसको सिर्फ जवाब में ये 2-3 लाइनें लिख दोगे, सिंस रेडियो एक्टिविटी इज अ नेचुरली अकरिंग प्रोसेस, hence it is difficult to predict exactly how many radiations will be emitted at a particular time, ठीक है, and in which direction। तो आपने बेसिकली एग्जामिनर को ये बताना है कि भाई रेडियो एक्टिविटी इसलिए रैंडम प्रोसेस है बिकॉज इट इज़ नेचुरली अकरिंग एंड हेंस इसी वजह से आप हर पॉइंट पे और एट हर मिनट आप रेडियो एक्टिविटी की ना डायरेक्शन बता सकते हो नॉर द particular amount of radiations that will be emitted at a certain time, ठीक है, सिंपल सी बात है। Now how can you verify that the radioactivity process is random? सिंपल है, फर्स्ट ऑफ ऑल क्या करोगे, एक गाइगर मुलर ट्यूब लोगे और बैकग्राउंड रेडिएशन मेजर कर लोगे, बैकग्राउंड रेडिएशन क्या आ गए 30 मिनट्स पर सेकेंड। फिर एक रेडियो एक्टिविटी का सोर्स लोगे, गाइगर मुलर ट्यूब के आगे रखोगे एंड यू विल रिकॉर्ड सेवरल रीडिंग्स लाइक दिस 6 रीडिंग्स आ गई हमारे पास। लेकिन इन सारी रीडिंग्स में एक मसला है, दीज आर द सोर्स रीडिंग प्लस बैकग्राउंड रेडिएशन रीडिंग, ठीक है। अब हमारे पास जो इनिशियली फर्स्ट स्टेप में बैकग्राउंड रेडिएशन आई थी वो क्या आई थी 30, वो अगर माइनस कर देंगे तो हमारे पास एक्चुअल सोर्स की रीडिंग आ जाएगी। तो लेट्स सबट्रैक्ट द बैकग्राउंड रेडिएशन फ्रॉम ईच ऑफ द ऑब्जर्व रीडिंग्स टू गेट द एक्चुअल रीडिंग। तो आ गई हमारे पास एक्चुअल रीडिंग्स। नाउ यू कैन सी दैट हर रीडिंग जो है वो एक दूसरे से डिफरेंट है। दिस इज डिफरेंट फ्रॉम दिस, 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 दिस इज डिफरेंट फ्रॉम दिस। So what does this tell us? This tell us that radioactivity is a random process. And why is it a random process? Because it is a naturally occurring process. Now let's come on to the concept of half life. Half life basically वो टाइम है जब आपकी रेडियो एक्टिव सोर्स की काउंट रेट, जो हम गाइगर मुलर ट्यूब से काउंट रेट मेजर करते हैं ना बच्चों, वो काउंट रेट हाफ हो जाए, उसको हम हाफ लाइफ कहते हैं, सिंपल। हाफ लाइफ क्या है? हाफ लाइफ वो टाइम है जिस टाइम में आपकी रेडियो एक्टिव सोर्स की काउंट रेट मतलब क्या है? रेडिएशंस पर मिनट या रेडिएशंस पर 5 मिनट, रेडिएशन पर सेकेंड, दैट हाफ्स, उसको हम कहते हैं हाफ लाइफ। ठीक है, लेट सपोज इनिशियल काउंट रेट आपका 1600 था, अब हमारी हाफ लाइफ 15 डेज है, तो 15 डेज के बाद क्या होगा? आपका काउंट रेट हो जाएगा 800। उसके और 15 डेज के बाद क्या होगा? आपका काउंट रेट हो जाएगा 400। उसके और 15 डेज के बाद क्या होगा? आपका काउंट रेट हो जाएगा 200। सिंपल। तो ये देखो यहाँ पे मैंने एक किया हुआ भी है एग्जाम्पल में कि 100, 200, 50, 25 सिंपल। एंड द पैटर्न कंटिन्यूज अंटिल व्हाट? अंटिल रेडिएशन या काउंट रेट बिकम जीरो। और रेडिएशन जीरो हो जाएंगी तो आपका क्या हो जाएगा? रेडियो एक्टिव सब्सटेंस स्टेबल हो जाएगा। सिंपल। अब हाफ लाइफ का कर्व भी देख लेते हैं एक दफ़ा। ये देखो यहाँ हाफ लाइफ में ये काउंट रेट्स लगे हुए हैं यहाँ पे सारे, और ये 15 डेज, 30 डेज, 60 डेज, 75 डेज। सो दिस इज अ कर्व बेसिकली। ठीक है, स्ट्रेट लाइन नहीं होती, कर्व होती है। ठीक है, दिस इज द काउंट रेट ऑन द वाई एक्सिस। लेट मी मार्क इट हियर, दिस इज द वाई एक्सिस पे काउंट रेट, यहाँ पे टाइम आया वैसा ही है। अब आ जाओ नेक्स्ट टॉपिक पे। ठीक है, व्हाट इज द नेक्स्ट टॉपिक? एक्सपेरिमेंट टू कैलकुलेट द एग्जैक्ट हाफ लाइफ। किस तरह कैलकुलेट करोगे अगर किसी सब्सटेंस की आपको हाफ लाइफ नहीं पता? ठीक है, और हमें सिर्फ ये पता है कि उसकी हाफ लाइफ जो है ना उस सब्सटेंस की क्लोज टू 1 आवर है। ठीक है, तो हम क्या कर सकते हैं इसमें? हमें बेसिकली निकालनी है एग्जैक्ट हाफ लाइफ, मतलब बिल्कुल एग्जैक्ट पॉइंट टू पॉइंट हाफ लाइफ ऑफ अ सब्सटेंस जिसका हमें पता है कि उसकी हाफ लाइफ क्लोज टू 1 आवर है, लेकिन हमें एग्जैक्ट नहीं पता। तो किस तरह निकालेंगे? फर्स्ट ऑफ ऑल हमेशा रेडियो एक्टिव के किसी भी सवाल में आप क्या करते हो? बैकग्राउंड रेडिएशन नोट कर लेते हो। वो आपने नोट कर ली, दैट इज 20 काउंट्स पर मिनट। उसके बाद क्या करोगे? उसके बाद सोर्स को गाइगर मुller ट्यूब के फ्रंट में प्लेस करोगे एंड विल रिकॉर्ड 5 to 6 रीडिंग्स विद एन इंटरवल ऑफ 50 मिनट्स। ठीक है, ये सारी रीडिंग्स आपने रिकॉर्ड कर ली, लेकिन इन रीडिंग्स के साथ फिर से कोई मसला है। ये क्या है? ये सोर्स प्लस बैकग्राउंड रेडिएशन की रीडिंग्स हैं विच आर नॉट एक्यूरेट। एक्यूरेट के लिए हमें क्या चाहिए होगा? हम इससे बैकग्राउंड रेडिएशन माइनस कर देंगे जो कि हमने ऊपर कैलकुलेट की थी, दैट इज़ 20। तो बैकग्राउंड रेडिएशन माइनस करने के बाद हमारे पास एक और टेबल आ गया, और उस टेबल से हमने एक चार्ट बना लिया सिंपली। अब उस चार्ट में जाके हम क्या करेंगे? हमें पता है कि इनिशियल रीडिंग क्या थी? 780। अब अगर हाफ होना है इस रीडिंग को, दैट इज़ हाफ होना है इस रीडिंग को, दैट इज़ 390 होना है, तो कितना टाइम लगेगा वो हम चार्ट से देख लेते हैं। 390 रीडिंग पे हमारा टाइम क्या आ रहा है? 55 मिनट्स। तो हमारी हाफ लाइफ क्या हो गई? 55 मिनट्स। तो दिस इज़ अ सिंपल वे टू कैलकुलेट द एग्जैक्ट हाफ लाइफ ऑफ अ सब्सटेंस जिसका आपको पता है कि उसकी हाफ लाइफ अराउंड 1 आवर है। ठीक है, डिज़ाइन एन एक्सपेरिमेंट टू शो दैट अ रेडियो एक्टिव सब्सटेंस ओनली इमिट्स गामा रेज। अब ये किस तरह करोगे आप? बिल्कुल फर्स्ट ऑफ ऑल आप क्या करोगे? हर रेडियो एक्टिव एक्सपेरिमेंट की तरह फर्स्ट ऑफ ऑल बैकग्राउंड रेडिएशन मेजर कर लोगे। उसके बाद क्या करोगे? सोर्स को प्लेस करोगे इन फ्रंट ऑफ काउंटर। उसके बाद क्या करोगे? उसके बाद यू विल प्लेस अ पेपर इन फ्रंट ऑफ द सोर्स एंड द जीएम ट्यूब। ठीक है, प्लेस अ पेपर। फिर आप क्या नोटिस करोगे? देयर वुड बी नो फॉल इन द काउंट रेट। सिंपल, क्योंकि गामा रेज वुडेंट बी स्टॉप बाय पेपर। सेकेंडली क्या करोगे? एल्युमिनियम प्लेस करोगे बिटवीन सोर्स एंड द जीएम ट्यूब। फिर आप क्या नोटिस करोगे? देयर विल बी नो फॉल इन द काउंट रेट। हेंस क्यों नहीं होगा? क्योंकि गामा रेस कांट बी स्टॉप बाय एल्युमिनियम, ओनली बीटा रेस कैन बी स्टॉप। फिर आप क्या प्लेस करोगे? लेड। जब आप लेड प्लेस करोगे तो ऑल द काउंट रेट विल बिकम टू 0, या बैकग्राउंड की जो वैल्यू होगी उस पर आ जाएगा। ठीक है, और वो आपको किस तरह पता चलेगा कि बैकग्राउंड की क्या वैल्यू है? फर्स्टली यू हैव कैलकुलेट द बैकग्राउंड वैल्यू इन द फर्स्ट स्टेप। सिंपल। ठीक है, अब आ जाओ नेक्स्ट सवाल पे। रेडियो एक्टिव सोर्स हैज़ अ half life of 6 hours. Calculate the time for the half life to reduce to 1/6 of its value. ठीक है, कर लेते हैं। फर्स्टली वैल्यू क्या होगी? लेट सपोज कर लेते हैं कि इनिशियल वैल्यू x है, हाफ लाइफ हुई 1/2x हुई, हाफ लाइफ फिर हुई, फिर 1/2x हो गई, फिर 1/4x हो गई, सॉरी, फिर से हाफ लाइफ हुई 1/8x हो गई, फिर से हाफ लाइफ हुई 1/16x हो गई। तो कितनी हाफ लाइफ लगी हमें? 4, और एक हाफ लाइफ के कितने आवर्स हैं? 6। तो टोटल कितने आवर्स हो गए? 24. Now you can do this second question on your own. This is your homework. Now let's move on to our next topic, which is, this is also a homework for you guys. This is pretty easy. ठीक है, Now let's move on to a next topic, that is nuclear reactions. Now there are two types of nuclear reaction, fission and fusion. First of all fission को पढ़ेंगे हम, उसके बाद फ्यूजन को पढ़ लेंगे, ठीक है. फिजन क्या होता है? फिजन बेसिकली होता है ब्रेकिंग अप ऑफ लार्ज न्यूक्लियसेस सच एज यूरेनियम इनटू स्मॉलर न्यूक्लियसेस सच एज क्रिप्टॉन एंड बेरियम, ठीक है. इसमें प्रोसेस में आपके पास काफ़ी ज़्यादा एनर्जी भी रिलीज होती है एंड दिस इज़ द बेसिक पर्पस ऑफ फिजन, ठीक है. तो लेट्स मूव ऑन टू हाउ डज अ फिजन रिएक्शन अकर, ठीक है. यहाँ पे ये फिजन होगा, दिस इज इन फ्यूजन, ठीक है. सो फिजन अकर करने के लिए हम क्या करते हैं, एक फास्ट मूविंग न्यूट्रॉन जो है फायर करते हैं एट अ यूरेनियम न्यूक्लियस. इससे होता यह है कि यूरेनियम न्यूक्लियस बिकम्स अनस्टेबल एंड ब्रेक्स डाउन टू टू स्टेबल न्यूक्लियसेस दैट आर क्रिप्टॉन एंड बेरियम. इन प्रोसेस वो 3 न्यूट्रॉन्स और रिलीज करता है और एनर्जी रिलीज करता है, ठीक है. अब फिजन रिएक्शन की इक्वेशन भी देख लेते हैं यार. न्यूट्रॉन प्लस यूरेनियम इज इक्वल टू क्रिप्टॉन प्लस बेरियम प्लस 3 न्यूट्रॉन्स प्लस एनर्जी. अब ये जो 3 न्यूट्रॉन्स है ना, दिस हैज़ अ वेरी इंपॉर्टेंट पर्पस. ये 3 न्यूट्रॉन्स जो हैं वो आगे रिएक्शन कंटिन्यू करने के लिए यूज़ होंगे. देखो यहाँ पे ये जो न्यूट्रॉन यूज़ हुआ है ना, वो ही यहाँ पे ये जो 3 न्यूट्रॉन है ना, वो ये बेसिकली इन 3 न्यूट्रॉन्स में से कोई एक न्यूट्रॉन will again combine with a uranium and continue the process, ठीक है. ये तीनों के तीनों न्यूट्रॉन्स यहाँ पे वापस न्यूट्रॉन ये एंड दिस वन एज वेल, ठीक है. ये तीनों जो हैं, तीनों न्यूट्रॉन्स विल कंबाइन विथ 3 अदर यूरेनियम एटम्स एंड विल कंटिन्यू द रिएक्शन. इसलिए हम इसे चेन रिएक्शन भी कहते हैं, ठीक है. इन एनी स्टेज जब भी आपको न्यूक्लियर फिजन रिएक्शन रोकना होता है तो आप क्या करते हो, बोरॉन रॉड्स का यूज़ करते हो. और बोरॉन रॉड्स कहाँ प्लेस करते हो, न्यूक्लियर रिएक्टर के अंदर टू स्टॉप द रिएक्शन, ठीक है. ये भी याद रखो, दिस इज एन इम्पॉर्टेंट पॉइंट एंड देयर इज अ मूवी ऑन इट एज वेल इफ यू वांट टू वॉच इट, चेरनोबिल. इट विल एक्सप्लेन टू यू द न्यूक्लियर फिजन रिएक्शंस क्वाइट अमेजिंगली, ठीक है. डू वॉच इट, इट इज़ अ मस्ट वॉच. तो न्यूक्लियर रिएक्टर्स, आप कभी भी आपको न्यूक्लियर फिजन का रिएक्शन रोकना होता है तो आप क्या करते हो, न्यूक्लियर रिएक्टर्स में बोरॉन रॉड्स पुश इन करते हो, ठीक है. अब आ जाओ नेक्स्ट पे, ठीक है. ऑल्सो वन मोर थिंग टू रिमेंबर हियर इज दैट जो बाई प्रोडक्ट्स होते हैं ना, क्रिप्टॉन और बेरियम के एलिमेंट्स दैट आर हाईली रेडियो एक्टिव, और उसको आपको डिस्पोज ऑफ करना होता है. और डिस्पोज ऑफ किस तरह करते हो रेडियो एक्टिव मटीरियल्स को, लेड बॉक्स में बंद करते हो और अंडरग्राउंड बरी कर देते हो. ये हमने ऊपर भी पढ़ा था, ठीक है. हाउ डू वी यूज़ दिस एनर्जी फॉर, व्हाट डू वी यूज़ दिस एनर्जी फॉर. बेसिकली जो न्यूक्लियर फिजन के रिएक्शन में यहाँ पे एनर्जी आई है आपके पास, ये 3 न्यूट्रॉन के साथ जो एनर्जी आई है उसको आप यूज़ किस तरह करते हो. बेसिकली ये एनर्जी यूज़ होती है पावर प्लांट्स में टू कन्वर्ट वाटर इनटू स्टीम, ठीक है. और ये जो स्टीम होती है दैट इज़ यूज टू टर्न द टर्बाइंस, और टर्बाइंस आर इंटरनली कनेक्टेड टू अ जनरेटर टू जनरेट इलेक्ट्रिसिटी. ये मैंने यहाँ पे नोट्स में भी लिखा हुआ है, यू कैन रीड इट इन योर फ्री टाइम, सिंपल, ठीक है. नाउ लेट्स डू अ क्वेश्चन रिगार्डिंग द न्यूक्लियर फिजन रिएक्शन. अब यहाँ पे आपके पास एक यूरेनियम का एटम है या न्यूक्लियस कह सकते हो, एंड आपके पास एक न्यूट्रॉन हिट कर रहा है, क्रिप्टॉन है, बेरियम है, ठीक है. नाउ वी हैव टू फाइंड द टर्म्स A and B. Let me mark them with black, ठीक है. A and B फाइंड करना है. A ये है, B ये. किस तरह फाइंड करोगे, A आप इस तरह फाइंड करोगे कि सम ऑफ ऑल द प्रोटॉन्स ऑन द लेफ्ट हैंड साइड will be equal to the sum of protons number on the right hand side. तो लेफ्ट हैंड साइड पे प्रोटॉन्स नंबर क्या है, 0 प्लस 92. राइट हैंड साइड पे प्रोटॉन्स नंबर क्या है, A प्लस 56 प्लस ये क्या है, 3 इंटू 0 वुड बी 0. तो A क्या आ जाएगा, A वुड बी 92 माइनस 56, ठीक है. क्या होगा, A का आंसर 36, ठीक है. B आप किस तरह कैलकुलेट करोगे, B भी सिमिलर प्रोसेस होगा, लेकिन B में आप क्या करोगे, B में आप सम ऑफ मास नंबर्स ऑन द लेफ्ट हैंड साइड वुड बी इक्वल टू सम ऑफ मास नंबर्स ऑन द राइट हैंड साइड. तो लेफ्ट हैंड साइड पे क्या मास नंबर्स हैं, 1 प्लस 236 इज इक्वल टू 90 प्लस B प्लस 3. तो आपका क्या आंसर आ जाएगा, 237 माइनस 93 वुड बी इक्वल टू B. तो B का क्या आंसर आएगा बच्चों, 144, सिंपल. और यही वर्किंग मैंने आपके लिए नोट्स में भी करके रखी है, सो यू कैन डाउनलोड दीज नोट्स फ्रॉम द डिस्क्रिप्शन बिलो एंड गो थ्रू इट व्हेन यू आर फ्री, ठीक है. अब आ जाओ सेकंड टाइप ऑफ न्यूक्लियर रिएक्शंस पे, दैट आर न्यूक्लियर फ्यूजन रिएक्शंस. न्यूक्लियर फ्यूजन बेसिकली होते हैं रिवर्स प्रोसेस ऑफ फिजन। फिजन में हम क्या कर रहे थे, एक बड़े मॉलिक्यूल को ब्रेक कर रहे थे इनटू स्मॉलर। यहाँ पे स्मॉलर मॉलिक्यूल्स आर कंबाइनिंग टू फॉर्म अ बिगर मॉलिक्यूल। और बेसिकली न्यूक्लियर फ्यूजन में सबसे जो इम्पॉर्टेंट या हाईली मतलब स्टडीड जो टॉपिक है या रिएक्शन है वो है टू हाइड्रोजन आइसोटोप्स की मर्जिंग का रिएक्शन। ठीक है, इसमें ये होता है कि बेसिकली आइसोटोप्स ऑफ हाइड्रोजन आर ऑफ 3 टाइप्स। कौन कौन से आइसोटोप्स होते हैं हाइड्रोजन के? H11, H21, H31। तो फ्यूजन रिएक्शन जो कि बहुत ज़्यादा पॉपुलर है उसमें हाइड्रोजन के हम 2 आइसोटोप्स लेते हैं, ड्यूट्रियम 21H एंड ट्राइट्रियम दैट इज 31H, और उनको कंबाइन करके एक हीलियम न्यूक्लियस बनाते हैं। इसकी वजह से हमारे पास 2 और चीज़ें आती हैं, न्यूट्रॉन और एनर्जी। ठीक है, एंड दिस रिएक्शन इज मोस्ट कॉमन इन सन की कोर। ठीक है, दैट्स वाई दैट इज टू हॉट, इससे बहुत ज़्यादा एनर्जी रिलीज होती है। ठीक है, ये देखो फ्यूजन इज डिफिकल्ट टू परफॉर्म। अच्छा, एंड दिस रिएक्शन इज ऑल्सो डिफिकल्ट टू परफॉर्म। वाई? क्योंकि जब आप 2 पार्टिकल्स को करीब लाओगे, लेट्स सपोज दिस इज H21 एंड दिस इज H31, इनकी कोर्स में क्या होगा, एक एक प्रोटॉन होगा, और प्रोटॉन्स क्या होते हैं? पॉजिटिवली चार्ज। जब भी आप पॉजिटिवली चार्ज पार्टिकल्स को या लाइक चार्जेस को एक दूसरे के करीब लाते हो तो दे रिपेल ईच अदर, हेंस हायर अमाउंट ऑफ एनर्जी वुड बी रिक्वायर्ड टू फ्यूज देम टुगेदर। सिंपल, यहाँ पे मैंने चीज़ें भी लिखी हुई हैं सारी। ठीक है, नाउ लेट्स, यहाँ पे मैंने आपकी एक्सप्लेनेशन भी लिखी हुई है, वाई डू वी नीड provide energy for fusion. Simple, since proton are positively charged, hence when we try to fuse the two nuclei together, like charges repel each other, and hence fusion requires more energy than more energy to recover the repulsive forces. Simple, ठीक है। differences between fission and fusion क्या होंगे? fusion requires more energy as compared to fission। ठीक है, क्यों? क्योंकि फ्यूजन में हम लाइक चार्जेस को एक दूसरे के अंदर फ्यूज़ कर रहे हैं। फ्यूजन ऑल्सो रिलीजेज मोर एनर्जी, अगर फ्यूजन एनर्जी ज़्यादा ले रहा है तो वो रिलीज़ भी ज़्यादा कर रहा है। ठीक है, और फ्यूजन ऑल्सो इन्वॉल्व्स कॉम्बिनेशन वेयर एज फिजन इन्वॉल्व्स ब्रेक डाउन। ये तो हमने पहले ही पढ़ा है कि एक दूसरे के रिवर्स रिएक्शन है। फिजन क्या होता है? चेन रिएक्शन होता है। फिजन में जो 3 न्यूट्रॉन्स रिलीज होते हैं दे कंटिन्यू द रिएक्शन फर्दर, लेकिन फ्यूजन में ऐसा नहीं होता। प्रोडक्ट्स ऑफ फिजन आर रेडियो एक्टिव वेयर एज फ्यूजन प्रोडक्ट्स आर नॉट रेडियो एक्टिव। सिंपल, ठीक है। वेयर डज फ्यूजन अकर्स, ये हमने पहले भी बात की है। वेयर डज फ्यूजन अकर्स? फ्यूजन अकर्स मोस्टली इन द सन्स कोर वेयर आइसोटोप्स ऑफ हाइड्रोजन 31 and 21 कंबाइन टू फॉर्म हीलियम एंड एनर्जी। ठीक है, हाउ आर स्टार्स फॉर्म? ठीक है, ये भी कभी कभार एग्जामिनर पूछ लेता है एग्जाम में कि हाउ आर स्टार फॉर्म्स, तो यू राइट दिस 3 स्टेप प्रोसेस। क्या है 3 स्टेप प्रोसेस यार? 3 स्टेप प्रोसेस ये है कि द आइसोटोप्स ऑफ हाइड्रोजन, डस्ट पार्टिकल्स एंड ऐश in the outer space come close together due to gravitational force of attraction. ठीक है, makes sense. When they get close together, they start colliding with each other. ठीक है, this causes an increase in the temperature. जब temperature increase होगा तो क्या होगा? Kinetic energy increase हो जाएगी, और kinetic energy would be used to overcome the repulsive forces. और जब repulsive forces overcome हो जाएंगी तो they will merge according to fusion reaction and form stars. Simple, यहाँ पे मैंने सारी चीज़ें लिखी हुई हैं, you can go through it. पॉसिबली कोशिश करोगे इसको रीफ्रेस करके लिखने की कोशिश करो इन एग्जामिनेशन, क्योंकि इतना ज़्यादा रट्टा नहीं मारा जाएगा। ठीक है, हाउ कैन वी डिस्क्राइब द स्ट्रक्चर ऑफ एटम्स? सो येस, दिस इज द लास्ट टॉपिक ऑफ रेडियो एक्टिविटी, और इसमें हम ये देखेंगे कि हाउ डिड वी डिस्कवर द स्ट्रक्चर ऑफ एटम यूजिंग द गाइगर मुलर ट्यूब। ठीक है, सो लेट्स सी एन एक्सपेरिमेंट दैट वी परफॉर्म। हमने क्या किया? हमने एक सोर्स लिया जो रेडियो एक्टिव था, और गोल्ड फॉयल के थ्रू वो रेडियो एक्टिव रेस पास करवाई, और GM ट्यूब ने जो है वो रेडियो एक्टिव रेस कलेक्ट की। सो व्हाट डिड वी ऑब्जर्व? फर्स्ट ऑब्जर्वेशन हमारी ये थी कि जब हमने गोल्ड फॉयल रखा यहाँ पे और रेडियो एक्टिव रेस को पास कराया तो काउंट रेट जो है वो बहुत कम जो है वो डिक्रीज़ किया विद एंड विदाउट गोल्ड फॉयल। सो व्हाट डिड दैट टेल अस? दिस टोल्ड अस दैट एटम हैज़ वेरी लार्ज एंड एम्प्टी स्पेसेस। ठीक है, अच्छा, और इफ़ यू वांट टू गो थ्रू द समरी ऑफ दिस एक्सपेरिमेंट, तो दिस एक्सपेरिमेंट की कंक्लूजन मैंने यहाँ पे पहले ही लिख दी है। तो ये 3 कंक्लूजन्स हम देखेंगे बारी बारी। फर्स्ट कंक्लूजन देख रहे हैं हम, एटम हैज़ वेरी लार्ज एंड एम्प्टी स्पेसेस। ये किस तरह पता चला? ठीक है, द काउंटर रिकॉर्डेड अ वेरी हाई रीडिंग इन द पोजिशन। ठीक है, काउंटर में यहाँ पे जब गोल्ड फॉयल आपने प्लेस की और हटा भी दी तब भी दोनों में रीडिंग का फ़र्क बहुत कम आया। तो इससे हमें क्या पता चल रहा है? इससे हमें ये पता चल रहा है कि atoms या alpha particles pass through the gold foil to reach the GM tube. Most of the alpha particles pass through the gold foil to reach the GM tube. इससे हमें ये पता चल रहा है, ठीक है. अब अगर मोस्ट ऑफ द अल्फा पार्टिकल्स पास थ्रू द GM ट्यूब, तो हमें ये क्या बता रहा है? ये हमें बता रहा है कि एटम्स हैव लार्ज एम्प्टी स्पेसेस, तभी तो इतने ज़्यादा अल्फा पार्टिकल्स पास थ्रू द गोल्ड फॉइल एंड रीच द GM ट्यूब. फर्स्ट कंक्लूजन हमारी निकली क्या? फर्स्ट कंक्लूजन हमारी ये निकली कि मोस्ट ऑफ द अल्फा पार्टिकल्स पास थ्रू दिस गोल्ड फॉइल का एटम. व्हाट डज दिस टेल के जो गोल्ड फॉइल का एटम है या नॉर्मल एटम्स हैव लार्ज स्पेसेस इन देम, ठीक है, हेंस दे अलाउ मोर पार्टिकल्स टू पास थ्रू देम. अब सेकंड ऑब्जर्वेशन हमारी क्या थी? कुछ अल्फा पार्टिकल्स जो हैं वो डिफ्लेक्ट हो गए गोल्ड फॉइल से, ठीक है, मतलब इस तरह पास करने के बजाय ये डिफ्लेक्ट हो गए या रिफ्लेक्ट कर गए, ठीक है. व्हाट डज दिस टेल अस? दिस टेल अस हमारी सेकंड एंड थर्ड कंक्लूजन्स. क्या सेकेंड एंड थर्ड कंक्लूजन्स क्या थी? न्यूक्लियस इज स्मॉल एंड इज पॉजिटिवली चार्ज, ठीक है. हाउ डज दिस टेल अस हमारी सेकेंड एंड थर्ड कंक्लूजन? देखो डिफ्लेक्शन कब होगी अल्फा पार्टिकल्स की? जब उनके सामने पॉजिटिवली चार्ज पार्टिकल्स आएंगे. क्यों? क्योंकि अल्फा पार्टिकल खुद पॉजिटिवली चार्ज हैं. अगर उनके सामने पॉजिटिवली चार्ज लाओगे तभी तो रिपल्जन होगी, ठीक है, या डिफ्लेक्शन होगी. तो गोल्ड फॉइल का न्यूक्लियस जो है वो पॉजिटिवली चार्ज था, हेंस इट रिपेल्ड द अल्फा पार्टिकल्स. दिस वाज आवर कंक्लूजन. और वो था क्या? बहुत ही स्मॉल साइज का था न्यूक्लियस. क्यों? ये किस तरह पता चला? क्योंकि वेरी स्मॉल पार्टिकल, वेरी फ्यू अल्फा पार्टिकल्स डिफ्लेक्टेड. क्योंकि अगर न्यूक्लियस जो है वो लार्जर साइज का होता तो ज़्यादा अल्फा पार्टिकल्स डिफ्लेक्ट करते, लेकिन क्योंकि फ्यूअर अल्फा पार्टिकल्स डिफ्लेक्टेड, इसलिए वी कैन स्टेट दैट द न्यूक्लियस वाज ऑफ अ स्मॉलर साइज. सिंपल. दिस वाज आवर एक्सपेरिमेंट की कंक्लूजन्स and the reasons why we concluded this. So cloud chambers are used to detect alpha particles. Cloud chambers are used to detect alpha particles. Okay. So what are the more important things in a cloud chamber? Let's see that. First of all, you have these rings. You have these rings in a cloud chamber. They are soaked in alcohol and they emit alcohol vapors. They are soaked in alcohol and they emit alcohol vapors. Secondly, you have a lamp and a plastic lid that enables you to see what is happening inside the chamber. In a cloud chamber, you have a lamp and a plastic lid that enables you to see what is happening inside the cloud chamber. Perfect. You also have this dry ice here. You also have this dry ice here to maintain lower temperatures in the chamber. You also have dry ice here to maintain lower temperatures in the chamber. Okay. And then lastly, you have a radioactive source here that is emitting alpha particles. A radioactive source that is emitting alpha particles. Perfect. So what happens inside a cloud chamber? Let's see that. Let's see. Okay. So basically, alcohol vapors are initially emitted by these rings. Perfect. Alcohol vapors are emitted by these rings. Due to the lower temperature in the chamber, these alcohol vapors get converted into what? These alcohol vapors get converted into alcohol droplets. These are the first and second step that I have written here. Perfect. Simultaneously, this alpha emitting source would have ionized the air around it. Simultaneously, this alpha emitting source would have ionized the air around it. What will happen next? This ionized air will attract the alcohol vapors. These ionized air will attract the alcohol vapors, forming path of condensations. This is what I have written here. Alpha particles ionize the surrounding air. The surrounding air attract these ions, forming path of condensation. Where can you see these path of condensations? On these black plates. You can see these paths of condensation on these black plates. Now, if the source contains alpha particles, you will have thick, short tracks that curl in one direction. If the source is emitting alpha particles, you will have thick, short tracks of
path of condensation. This is your cloud chamber experiment. Now let's move on to spark counters. Spark counters are also used to detect alpha particles. Let's see the diagram of a spark counter. Yeah, this is the diagram of a spark counter. Okay, so what do we have here? We have a metal gauze here, this thing, okay, and we have a metal wire here, this solid thing, and we have attached a higher voltage here, like a 5000 volts here. Okay, what happens in a spark counter? What happens in a spark counter? When you bring an alpha emitting source here, this ionizes the surrounding air. And hence sparks are generated. So spark counter is really easy. You set up a wire gauze and apply a higher voltage across it, and then bring an alpha source close to it. Alpha source will ionize the air around it. As it ionizes the air around it, sparks will generate. Now, why are sparks generated actually? If the examiners ask you why are sparks generated, sparks are generated because the charged air molecules or the ionized air molecules collide with each other. Now let's move to a last unit, that is unit number 6, and the topic is space physics. तो इसमें ज़्यादातर चीज़ें रट्टा मारने की हैं. There are basically 1 to 2 calculations जो हम देखेंगे, and most of his stuff is रट्टा. ठीक है, तो अर्थ जो है, फर्स्ट ऑफ ऑल लेट स्टार्ट विद द रिलेशनशिप बिटवीन अर्थ एंड सन. ठीक है, अर्थ जो है वो सन के अराउंड ऑर्बिट करता है, और पूरा ऑर्बिट करने के लिए उसको 1 साल लगता है टू कंप्लीट 1 साइकिल. अर्थ नॉट ओनली अराउंड सन ऑर्बिट कर रहा होता है, बट वो अपने एक्सिस के अराउंड भी रोटेट कर रहा होता है. और ये वाली एक्सिस वाली रोटेशन कितनी देर में होती है? 24 घंटे में. ठीक है, 24 आवर्स में. और ये अराउंड द सन कितने देर में होती है? 1 साल में. ठीक है, नाउ लेट्स कम ऑन टू मून. मून ऑल्सो ऑर्बिट्स अराउंड द अर्थ. ठीक है, और मून की एक ऑर्बिट अराउंड द अर्थ कितने दिन लेती है? 28 डेज. सिंपल. जैसे कि मैंने आपको कहा था, बिल्कुल ये रट्टे वाला सब्जेक्ट है, मतलब यूनिट है. ठीक है, तो इसमें ज़्यादातर चीज़ें जो हैं वो नंबर्स और फिगर्स ही हैं और डेफिनेशंस. ठीक है, मून शाइन्स विद रिफ्लेक्टेड लाइट फ्रॉम द सन, इट डज़ नॉट प्रोवाइड इट्स ओन लाइट. सिंपल. ठीक है, ऑर्बिटल स्पीड किस तरह निकालते हैं? स्पीड इज़ इक्वल टू डिस्टेंस अपॉन टाइम. डिस्टेंस क्या होता है? 2 पाई आर डिवाइडेड बाई टी. आर क्या होता है इन दिस केस? आर इज़ द डिस्टेंस बिटवीन द सन और द अर्थ का ऑर्बिट. ठीक है, या फिर आर इज़ बेसिकली द एवरेज रेडियस ऑफ द ऑर्बिट. लेट सपोज, देखो मैं बता देता हूँ आर क्या है. लेट सपोज आपका ये एक सन है. ठीक है, एंड द अर्थ इज ऑर्बिटिंग अराउंड इट. ठीक है, तो आर क्या होगा? आर वुड बी फ्रॉम द सेंटर ऑफ द सन टूवर्ड द अर्थ. ये आपका आर होगा. ठीक है, और क्या हो गया? स्पीड आपको पता चल गई. स्पीड, ऑर्बिटल स्पीड क्या होती है? किस स्पीड से अर्थ जो है वो मूव कर रहा है अराउंड द सन. ठीक है, और टाइम पीरियड क्या है? ऑर्बिटल टाइम पीरियड. ऑर्बिटल टाइम पीरियड बेसिकली ये है कि कितने टाइम में पूरा एक साइकिल कंप्लीट करेगा अर्थ अराउंड द सन, या कोई भी ऑब्जेक्ट अराउंड एन अदर ऑब्जेक्ट. सिंपल. ठीक है, लेट्स डू अ क्वेश्चन. कैलकुलेट द ऑर्बिटल स्पीड. अर्थ रेडियस ये है. हबल टेलीस्कोप जो है 560 सेंटीमीटर 560 सेंटीमीटर, ये 60 है, अबव द अर्थ है. अर्थ का रेडियस क्या है? अर्थ का रेडियस है 640. तो टोटल रेडियस क्या हो जाएगा? टोटल रेडियस अगर मैं अर्थ के सेंटर से लूँ तो ये वाली चीज़ भी प्लस होगी, दैट इज़ 6400 किलोमीटर प्लस 560 किलोमीटर. तो टोटल रेडियस क्या हो जाएगा? 6400 प्लस 560 किलोमीटर. तो ये टोटल क्या हो जाएगा? 6960 किलोमीटर. तो अगर मुझे ऑर्बिटल स्पीड निकालनी है तो मैं फॉर्मूला लगा सकता हूँ 2 पाई आर डिवाइडेड बाई टी. आर क्या है मेरे पास? आर आ गया 6960. 2 पाई 6960. ठीक है, मल्टीप्लाई होगा, और किलोमीटर है तो 10⁻³ हो जाएगा. टी क्या है हमारे पास? टी है टाइम पीरियड. टाइम पीरियड हमेशा सेकंड्स में होता है, हमें मिनट्स में गिवन है, तो वी कन्वर्ट 96 मिनट्स इंटू सेकेंड्स. 96 इंटू 60 डिवाइड करेंगे और हमारे पास स्पीड आ जाएगी. सिंपल, ये आ गई इधर. ठीक है, अब आ जाओ सोलर सिस्टम पे. सोलर सिस्टम इज़ ऑल्सो अ रट्टा वाला टॉपिक. सोलर सिस्टम कंसिस्ट ऑफ 5 मेन
things: the sun, 8 planets, natural and artificial satellites, and dwarf planets and asteroids and comets. कुछ कुछ चीज़ें मैं यहीं बता देता हूँ. 8 planets क्या होते हैं? वीनस, अर्थ, मार्स, जुपिटर, सैटर्न एंड यूरेनस एंड नेपच्यून. ये सारे आपके 7 planets हो गए. और एक और कौन सा होता है? प्लूटो. ठीक है. अच्छा, नेचुरल सैटेलाइट्स क्या होती हैं? नेचुरल सैटेलाइट्स आर बेसिकली मून्स. आर्टिफिशियल सैटेलाइट्स क्या होती हैं? जैसे हबल स्पेस टेलीस्कोप था, दैट इज़ योर नेचुरल सैटेलाइट. ठीक है. इंटरनेशनल स्पेस स्टेशन सैटेलाइट, दैट इज़ योर नेचुरल सैटेलाइट. ठीक है. डॉर्फ प्लैनेट्स क्या होते हैं? जिनकी ग्रेविटेशनल फील्ड स्ट्रेंथ वीक होती है. सिंपल. ठीक है. ये देखो यहाँ पे नेचुरल और आर्टिफिशियल सैटेलाइट का भी लिखा हुआ है. एस्टेरॉयड क्या होता है? एस्टेरॉयड इज़ बेसिकली अ स्मॉल रॉकी ऑब्जेक्ट दैट ऑर्बिट्स अराउंड द सन. सिंपल डेफिनेशन आपको याद होनी चाहिए, इसमें और कोई ख़ास बात नहीं है. ठीक है. एक और चीज़ याद रखो, वो ये है कि द एस्टेरॉयड बेल्ट लाइज बिटवीन मार्स एंड जुपिटर. सिंपल. ठीक है. अब आ जाओ नेक्स्ट टॉपिक पे, कॉमेट्स पे. ठीक है. कॉमेट्स भी बेसिकली सोलर सिस्टम में ही लाई करता है, तो इसकी भी आपको डेफिनेशन आनी चाहिए. एंड ये आपको पता होना चाहिए कि अगर कॉमेट्स जो हैं वो क्लोज टू द सन आते हैं तो उनकी आइस जो है, उन पे जो आइस होती है वो मेल्ट कर जाती है एंड इट फॉर्म्स द कॉमेट्स टेल. ठीक है. अब हम पढ़ते हैं कि एक लाइट को एक प्लैनेट रीच करने में, लेट सपोज किसी भी सॉर्ट ऑफ लाइट को कोई भी प्लैनेट पे रीच करने के लिए, लेट सपोज सन से लाइट आ रही है. ठीक है. टू रीच मार्स इसको कितना टाइम लगेगा ये निकालना है. ठीक है. द रेडियस ऑफ मर्क्यूरीज ऑब्जेक्ट अराउंड द सन इज दिस. ठीक है. डिस्टेंस आ गया हमारे पास. कैलकुलेट द टाइम टेकन फॉर द लाइट टू ट्रैवल. टाइम निकालना है. टाइम का फॉर्मूला क्या होता है? डिस्टेंस अपॉन स्पीड. तो हमारे पास डिस्टेंस तो आ गया है 5.8 इंटू 10⁹ हमेशा रेडियस यूज़ करेंगे जब भी टाइम निकालना होगा फॉर लाइट. स्पीड किस तरह आएगी लाइट की? लाइट की स्पीड इज़ अ कांस्टेंट स्पीड 3 इंटू 10⁸, तो आपके पास टाइम आ जाएगा. ठीक है. 19.3 सेकेंड्स. इसी मेथड को यूज़ करते हुए आप टाइम निकाल सकते हो फॉर लाइट फ्रॉम द सन टू रीच अर्थ, और वो आती है अराउंड 500 सेकेंड्स और 8 मिनट्स. सिंपल. ठीक है. अब आ जाओ और थोड़ी सी बेसिकली दिस इज़ अ एनालाइजेशन पार्ट. ठीक है. इसमें आपको एग्जामिनर जो है ऑर्बिटल डिस्टेंसेस, पीरियड, डेंसिटी, सरफेस टेम्परेचर और ग्रेविटेशनल फील्ड स्ट्रेंथ फॉर डिफरेंट प्लैनेट्स दे देगा और रिलेशनशिप पूछेगा अमंग देम. ठीक है. सो लेट्स एनालाइज दैट. लेट्स एनालाइज द रिलेशनशिप बिटवीन द ऑर्बिटल डिस्टेंस एंड द सरफेस टेम्परेचर. तो ऑर्बिटल डिस्टेंस का कॉलम कौन सा है? ये है. ठीक है. जैसे जैसे ऑर्बिटल डिस्टेंस बढ़ रहा है, सरफेस टेम्परेचर को क्या हो रहा है? सरफेस टेम्परेचर का कॉलम ये है. सरफेस टेम्परेचर इज़ डिक्रीजिंग. ठीक है. तो इसका क्या रिलेशन है? इन्वर्स रिलेशन है. ऐसा क्यों हो रहा है? क्योंकि जैसे जैसे ऑर्बिटल डिस्टेंस बढ़ रहा है आप सन से दूर होते जा रहे हो. सन से दूर होते जा रहे हो तो आपकी तरफ रेडिएशंस कम आ रही हैं, हैंस आपका टेम्परेचर जो है वो कम होता जा रहा है. ठीक है. See here, surface temperature and orbital distance are inversely related. Now let's move on to the relation between orbital distance and orbital period. ठीक है. orbital distance और orbital period को देख लेते हैं. orbital distance जैसे जैसे बढ़ रहा है, ठीक है, जैसे जैसे orbital distance यहाँ पे बढ़ रहा है, orbital period के साथ क्या हो रहा है? orbital period भी बढ़ रहा है. सही है. तो इसका मतलब क्या है? इसकी रीजनिंग क्या है? बेसिकली इसकी रीजनिंग ये है कि जितना ऑर्बिटल डिस्टेंस आपका कम होगा उतनी ग्रेविटेशनल फोर्स ऑफ सन आपके ऊपर ज़्यादा लग रही होगी. जितनी ग्रेविटेशनल फोर्स ज़्यादा लग रही होगी उतनी स्पीड ज़्यादा होगी, इसलिए पीरियड कम होगा. सिंपल. और जैसे जैसे दूर जाते जाओगे ग्रेविटेशनल फोर्स कम होती जाएगी, पीरियड बढ़ता जाएगा. सिंपल. नाउ लेट्स कम ऑन टू अ थर्ड रिलेशन, दैट इज़ द रिलेशन बिटवीन ऑर्बिटल डिस्टेंस एंड डेंसिटी. ठीक है. ऑर्बिटल डिस्टेंस जैसे जैसे बढ़ रहा है, डेंसिटी के साथ क्या हो रहा है? डेंसिटी के ऊपर वाली 4 वैल्यूज़ ज़्यादा हैं और नीचे वाली 4 वैल्यूज़ देख रहे हो ड्रास्टिकली कम है. तो इसका हम क्या रीज़न दे सकते हैं? इसका हम रीज़न ये दे सकते हैं कि जो फर्स्ट 4 प्लैनेट्स हैं दैट वर फॉर्म्ड फ्रॉम द हॉटर इनर रीजन्स ऑफ द सोलर सिस्टम, इसलिए उनकी डेंसिटी ज़्यादा है. However, the last 4 planet or the furthest 4 planet were formed from the cooler outer region of the solar system. ठीक है. तो उनकी डेंसिटी कम है. सिंपल. ठीक है. अब ग्रेविटेशनल फील्ड स्ट्रेंथ किस किस चीज़ों पर डिपेंड करती है? दैट इज़ जी की वैल्यू जो होती है, W इज़ इक्वल टू एम जी में जो जी की वैल्यू होती है वो किस किस चीज़ों में डिपेंड करती है? मास ऑफ द प्लैनेट पे. ठीक है. एंड डिस्टेंस फ्रॉम द प्लैनेट पे. जितना मास ऑफ द प्लैनेट ज़्यादा होगा उतनी जी की वैल्यू ज़्यादा होगी. मतलब जितना मास ऑफ द प्लैनेट ज़्यादा होगा उतनी जी की वैल्यू ज़्यादा होगी. लेट्स नॉट रिप्रेजेंट दिस विथ स्मॉल एम, इट विल गेट कन्फ्यूजिंग फॉर यू गाइज. सही है. तो जितना मास ऑफ द प्लैनेट ज़्यादा होगा उतनी जी की वैल्यू ज़्यादा होगी. ये देखो यहाँ पे वर्डिंग्स में भी लिखा हुआ है, द ग्रेटर द मास ऑफ द प्लैनेट देन द ग्रेटर इज इट्स ग्रेविटेशनल फील्ड डिस्टेंस. डिस्टेंस के साथ किस तरह का रिलेशन है? द ग्रेटर द डिस्टेंस फ्रॉम द प्लैनेट उतनी ही उसकी जी कम होगी. देखो, द स्ट्रेंथ ऑफ द फील्ड अक्रॉस द प्लैनेट डिक्रीजेज एज द डिस्टेंस फ्रॉम द प्लैनेट इंक्रीजेज. सिंपल. ठीक है. अब नेक्स्ट व्हाट वी कैन स्टडी हियर इज, अच्छा, next there is nothing more that we can study here. You can study that sun की properties. सही है. How nuclear fusion happens in sun. ठीक है. Then you can study life cycle of a star. This is basically ratta. What can I explain in this? ठीक है. This is basically ratta. You can go and download the notes from the description and ratify it all through this. This is all ratta. There is nothing to be explained here. Literally not one thing. ठीक है. तो ये सारा आप डाउनलोड करो, इसको रट्टा मार लो. दिस इज़ बेसिकली अ रट्टा वाला सब्जेक्ट. ठीक है. तो हेयर इज़ वन थिंग दैट आई वांटेड टू एक्सप्लेन टू यू गाइज. येस, रेड शिफ्ट. ठीक है. रेड शिफ्ट एक फिजिकली लॉजिकल टॉपिक है दैट आई मस्ट एक्सप्लेन टू यू गाइज. ठीक है. यूजुअली जब एक ऑब्जेक्ट स्टेशनरी होता है और वेव्स इमिट कर रहा होता है तो क्या होता है, वेव जो है वो सिमेट्रिकल होती हैं. बट अगर ऑब्जेक्ट मूव करना शुरू हो जाए आइदर टू द लेफ्ट और द राइट तो क्या होता है, वेव जो हैं एसिमेट्रिकल हो जाती हैं. कुछ वेव जो हैं वो स्क्वाश हो जाती हैं, कुछ वेव जो हैं वो स्ट्रेच आउट हो जाती हैं. और इस इफेक्ट की वजह से इस इफेक्ट को हम कहते हैं डोपलर इफेक्ट. ठीक है. यहाँ पे देखो इसकी डेफिनेशन भी लिखी हुई है. द वेवलेंथ ऑफ द वेव्स, अ मूविंग ऑब्जेक्ट विल कॉज द वेवलेंथ एंड फ्रीक्वेंसी ऑफ द वेव्स टू चेंज. ठीक है. ये यहाँ से डॉपलर इफेक्ट की डेफिनेशन शुरू हो रही है. The wavelength of the waves in front of the source will decrease and frequency increase. The wavelength behind the source increases and frequency decreases. Similar. ठीक है. ये जो ऊपर सिनेरियो हो रहा है, ठीक है, इस इफेक्ट को हम डॉपलर इफेक्ट कहते हैं. और डॉपलर इफेक्ट की वजह से देयर इज़ अ रेड शिफ्ट इफेक्ट. ठीक है. रेड शिफ्ट क्या होता है? इफ़ एन ऑब्जेक्ट मूव्स अवे फ्रॉम एन ऑब्जर्वर द वेवलेंथ ऑफ लाइट इंक्रीजेज. सिंपल. ठीक है. ऑब्जेक्ट अगर मूव कर रहा है ऑब्जर्वर से दूर तो वेवलेंथ ऑफ लाइट क्या होगी, इंक्रीज़ हो जाएगी. और वेवलेंथ ऑफ लाइट इंक्रीज़ होगी तो क्या होगा, वेवलेंथ ऑफ लाइट जब इंक्रीज़ होती है, और हमें पता है वेब गियोर में सबसे ज़्यादा वेवलेंथ किसकी है, रेड की है, तो लाइट किसकी तरफ शिफ्ट होना शुरू हो जाएगी, रेड साइड पे. दिस इज़ बेसिकली रेड शिफ्ट. ठीक है. ये यहाँ पे डेफिनेशन भी लिखी हुई है. एन इंक्रीज इन द ऑब्जर्व वेवलेंथ ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन इमिटेड फ्रॉम द रिसीडिंग स्टार्स एंड गैलेक्सीज. सिमिलर. ठीक है. अब जितना जितना डिस्टेंस बढ़ता जाएगा उतना उतना रेड शिफ्ट का इफेक्ट ज़्यादा होता जाएगा. दिस इज़ अ ग्राफ दैट यू मस्ट नो इन द एग्जाम. ठीक है. रेड शिफ्ट in light from the distant galaxy is evidence that the universe is expanding and support the Big Bang theory. Let's zoom in here. Let's move on to the theory questions now. Table 1.1 shows details about 8 planets in the solar system, their average distance from the sun, their orbital period, and their average surface temperatures. Perfect. Complete table 1.1 by adding the names of the 3 planets that are not given. Okay, you have to add the names of the planet that are not given. First of all, the closest planet to the Earth is Mercury. Then, between Mars and Saturn, what do we have? Jupiter. And between Saturn and Neptune, what do we have? Uranus. Also, you can check these answers with the marking scheme that is attached right besides the question itself. Let's move on to the question again. Calculate the orbital speed of Mars as it travels around the Sun. So now you have to calculate the orbital speed. What is the formula of orbital speed? 2 pi r divided by the time period. Okay. What is r? R is the orbital distance. R is the orbital distance. What is the orbital distance between Mars and the Sun? This 2.3 into 10 raised to the power of 8. So let's place it here. 2 pi into the distance of 2.3 into 10 raised to the power of 8. Now, here I have to focus on one thing. The distances are in kilometers. The distances are in kilometers, and if this was a normal question, I would have multiplied it by 10 raised to the power of 3 to convert kilometers into meters. But here I wouldn't do this. Why? Because I have to give my final answer in kilometers. So I will keep my distance in terms of kilometers only. I will not convert it into meters. Okay. What is your orbital period? What is your orbital period T? If you see here, yeah, this is your orbital period 5.9 into 10 raised to the power of 7 divided 5.9 into 10 raised to the power of 7. Let's calculate the orbital speed. 2 pi into 2.3 into 10 raised to the power of 8 divided by 5.9 into 10 raised to the power of 7. The answer comes out to be 24.5. The answer comes out to be 24.5 kilometers per second. Describe the relationship between the distance of a planet from the sun and its orbital speed. Let's examine that. So, as the distance from the sun is increasing, as the distance from the sun is increasing, what is happening to the orbital speed? Yeah, orbital speed or orbital period? Orbital period, yeah. As the distance from the sun is increasing, what is happening to the orbital period? The orbital period is also increasing. Simple as that. As the distance, as the distance of a planet, of a planet from the sun, from the sun increases, the orbital period increases as well. The orbital period increases as well. Perfect. Nothing complicated. Let's further move ahead. Describe the relationship between the distance from the sun and the average surface temperature of a planet. In your description, include any anomalies. Okay, so what are anomalies? Let's first of all discuss this. What are these anomalies? What is this difficult English word? Anomalies. Anomalies are data set or data value that doesn't follow the trend, that doesn't follow follow the trend. Now, if you examine, as the distance from the sun is increasing, the surface temperature is decreasing. As the distance from the sun is increasing, the surface temperature is decreasing. And can you see any anomaly here? Can you spot any anomaly here? Yes. The anomaly here is this: Venus. As you are going from Mercury to Venus, your distance increases and your temperature also increases. That is an anomaly. So we will write this as well. How will you phrase your answer? You will say, as distance from the sun increases, surface temperature decreases. Surface temperature decreases. Perfect. And as surface temperature decreases, you don't have to give an explanation, right? No, you don't have to give an explanation, but you have to tell an anomaly. So you can say planet Venus is an anomaly. The planet Venus is an anomaly as distance increases, temperature also increases, which is against the trend, which is against the trend. Let's further move ahead. Let's check the marking scheme as well. Yeah. We have Venus as an anomaly, further from the distance, cooler the planet. Simple. Let's move on to the next question. Astronomical distances are measured in light years. State what is meant by a light year. The distance, the distance traveled, traveled by light, The distance traveled by light in 1 year is known as your light year. The sun is one star in the Milky Way galaxy. State the approximate diameter of the Milky Way galaxy. The diameter of Milky Way galaxy is what? 100,000 light years. There are several stages in the life cycle of a star. Perfect. Complete figure 10.1 to show the stages that a massive star goes through after it has used up most of the hydrogen at the center of the star. Perfect. So, what will happen if you have used most of the hydrogen at the center? This becomes a red supergiant. Perfect. A red supergiant explodes into a supernova when the hydrogen finishes. This supernova gets divided into two parts. What are those two parts? Nebula and a black hole or neutron star. Simple as that, nothing complicated here. Let's further move ahead. State the region in the life cycle of a star where heavy elements are produced, supernova. Always remember heavy elements or heavy metals are produced in supernova. Current scientific understanding is that the universe began 14 billion years ago in an event known as Big Bang. Perfect. Explain one observation that supports the Big Bang theory. A redshift of light coming from galaxies moving away from Earth supports the Big Bang theory. The further away the galaxy is, the greater is the speed of recession. The further away the galaxy is, the greater is the speed of recession. Hence a greater redshift. Hence a greater redshift. And if you have a greater redshift going back in time, all stars and galaxies would have been close together. See, the redshift in light explains Big Bang or supports Big Bang. How? Because the further away the galaxies are, the greater is the redshift. Hence, going back in time, all the stars or galaxies would have been together. This explains that the universe began an event known as Big Bang, and the universe has been expanding ever since. This explains that the universe began in an event known as Big Bang and it has been expanding ever since. Let's further move ahead. The planet Venus orbits the sun at a constant speed of this and takes time TV to complete one orbit. Venus is always 1.1 into 10 raised to the power 11 meters from the sun. Calculate TV. So again we will apply the formula of orbital speed 2 pi r divided by t. What is your velocity? 3.5. What is your radius? 1.1 into 10 raised to the power of 11. Can you calculate the time period? Yes. Time is equals to 2 pi into the radius, that is 1.1 into 10 raised to the power of 11 divided by the velocity, that is 3.5 into 10 raised to the power of 4. What does your time period come out to be? Let's calculate 2, 2 pi into 1.1 into 10 raised to the power of 11 divided by 3.5 into 10 raised to the power of 4. This comes out to be 1.9. This comes out to be 1.9. 1020. Yeah, 1.9 into 10 raised to the power of 7 seconds. I hope I am correct. Let me check it in the marking scheme as well. Yeah, 1.9, that is roughly equal to 2.0. 2.0 into 10 raised to the power of 7 seconds. Yeah. Explain why speed is a scalar quantity, because it only has a magnitude. Because it only has a magnitude. Perfect. Let me write it completely because speed only has a magnitude. Speed only has a magnitude. Let's further move ahead. Velocity is a vector quantity. Explain what happens to the velocity of Venus as it orbits around the sun. As Venus orbits around the sun, around the sun, the direction changes and hence the velocity changes. And hence the velocity changes. Simple as that. There is a resultant force acting on Venus as it orbits around the Sun. The force is perpendicular to the direction of motion of Venus. State why this force is needed to keep Venus in a circular orbit. To keep Venus in a circular orbit. Simple as that. Let's further move ahead. Figure 9.1 shows the orbit of Venus around the Sun. Perfect. On figure 9.1, draw an arrow to show the resultant force on Venus. So, how will you show the resultant force on Venus? It will act towards the center like this. It will act towards the center like this. 1 second. It will act towards the center like this. Yep, like this. State what causes the force acting on the Venus. What is the origin of this force? The gravitational field strength of the Sun. This force, this force is caused by the gravitational field strength of the Sun. By the gravitational field strength of the Sun. Of the Sun. Simple as that. One planet is in the solar system is closer to the Sun than Venus, which is that planet, Mercury. Perfect. Compare the time that this planet takes to complete one orbit of the Sun with time TV. Explain this difference. Okay, what will be the orbital period of Mercury compared to the orbital period of Venus? So, how will the orbital period of Mercury compare with the orbital period of Venus? First of all, let's draw it. I think by drawing it, it will get easier. This is Sun, this is Mercury, and let's say this is Venus. Perfect. Can you realize the orbit of Mercury is smaller compared to the orbit of Venus? Can you realize this? Yeah, pretty evident. So this could be your first point. The circumference, the circumference of the orbit of the orbit of Mercury is less. What is the second thing? And Mercury has a greater orbital speed. Why? Has a greater orbital speed due to it experiencing a greater gravitational force due to the Sun. Or how can you phrase it? And Mercury has a greater orbital speed as it is closer to the Sun. As it is closer to the Sun, this results in a lesser orbital period for Mercury. So there are two factors that contribute to a lesser orbital period for Mercury. The first one is that you have a lesser circumference. Second is that Mercury has a greater orbital speed. Both of them combine and give you a lesser orbital period for Mercury compared to Venus. Let's further move ahead. In space, an interstellar cloud of dust and gas collapses to form a protostar. The cloud contains hydrogen. Perfect. Describe the energy transfer that takes place as the cloud collapses and forms a protostar. What will be the energy transfer as the cloud collapses and forms a protostar? Your gravitational potential energy, gravitational potential energy gets converted into internal energy. Gets converted into internal energy. Simple as that. As your cloud is collapsing and forming a protostar, gravitational potential energy gets converted into internal energy. Let's further move ahead. The collapse results in a nuclear reaction in the protostar that involves the isotope hydrogen 3. The isotope hydrogen 3 is radioactive. It decays by a beta particle emission. State how the nuclei of isotopes of the same element are different. How the nuclei of isotopes of the same element are different. They have different mass numbers. They have different mass numbers, or if you want to be fancy here, you can say they have different nucleon numbers. Different mass numbers or different nucleon numbers. Perfect. Explain why hydrogen 3 cannot decay by alpha particle emission. Why can hydrogen 3 not decay by alpha particle emission? Because alpha particle emission requires two protons. We have one proton only. So you can say hydrogen 3 has one proton only, and alpha particle emission requires two protons. Simple as that. Let's further move ahead. Now complete the equation for the decay of hydrogen 3 to become an isotope of helium. Okay. If hydrogen 3 is decaying by beta particle emission, what will this be? Negative 1. This will be 0. This mass number will remain same. Proton number will increase by 1 whenever you have a beta particle emission. Explain how the nuclear reaction in the protostar stops further collapse as the protostar becomes a stable star. So in this question, we have to tell how the nuclear reaction in the protostar stops further collapse as the protostar becomes a stable star. So the nuclear reaction in the protostar, the nuclear reaction in the protostar causes what? Causes the temperature to increase. This increase in temperature causes what? Causes an outward force. Causes an outward force. As this outward force balances the inward gravitational force, balances the inward gravitational force, gravitational force, the star becomes stable. The star becomes stable. Simple as that. Let's further move ahead. The cloud and dust that collapses also contains atoms of the heaviest element. By this only I know what is going to be asked about. Supernova. Always remember, heaviest elements are formed in the supernova. State which part of the life cycle of a star is responsible for the production of the heaviest elements. Supernova. Let's further move ahead. Table 8.1 shows data about three planets Mercury, Venus, and Earth. Perfect. So these are data about three planets Mercury, Venus, and Earth. Perfect. Figure 8.1 shows these planets in alignment with the Sun. They rotate around the Sun in the direction shown. Mark and label in figure 8.1 the positions of these three planets 110 days after the position shown in figure 8.1. Okay. So currently this is the position of Mercury, Venus, and Earth. We have to mark the position after 110 days. Okay. So what will we do? First of all, let's consider Mercury. Let's consider Mercury. Mercury takes 88 days to complete one orbit, or you can say Mercury takes 88 days to complete 360-degree rotation. How many degrees will Mercury rotate in 110 days? Apply ratio method. X is equals to 110 into 360 divided by 88. This comes out to be 450 degrees. So in 110 days, Mercury will rotate by 450 degrees. Okay. Where will 450 degrees be? This one entire rotation will be 360 degrees. And 360, or you can say, or you can say, oh, what have I done here? 88, this is 110. Okay. 450 minus 360 will be equal to what? 90 degrees. So, after 110 days, Mercury will be here. After 110 days, Mercury will be here. Make sure you draw with a compass or at least draw with a good drawing, at least, not like me. Secondly, you have what? Venus. Okay. Venus takes 2 to 220 days to cover an entire orbit, or you can say 360 degrees. In 110 days, how many degrees will Venus cover? X is equals to 180 degrees. So if Venus moves by 180 degrees, where will Venus end up? Somewhere here. And make sure this is bigger than the Mercury, just as the diagram initially depicts. Now let's come on to Earth. Let's come on to Earth. Let's choose a good color for Earth. Let's take pink. Yeah. Okay. So Earth takes 365 days. Let's write it here. Earth basically takes 365 days to cover how many degrees? 360 degrees. 110 days will cover how many degrees? X. Can you calculate the value of X? Yes. X is equals to 360 into 110 divided by 365. What is the value of X? Let's calculate that. Let's calculate that. 360 into 110 divided by 365. Your answer comes out to be 108. 108 degrees. So Earth will be somewhere between 90 and 180, and it will be bigger than Venus and Mercury both. This is how your diagram will look like. Let's further move ahead. Each of these three planets has a similar average density. Explain why the gravitational field strength at the surface of Mercury is much smaller than that at the surface of Venus. Why is the gravitational field strength of Mercury less than the gravitational field strength of Venus? Why? You can say because Mercury has a smaller mass. You can say because Mercury has a smaller mass. Simple as that. Let's further move ahead. An object has a weight of 37 Newton on the surface of Mercury. Perfect. What is the gravitational field strength on Mercury? 3.7. Okay. Can I calculate the mass using these? Yes. W is equals to mg. Weight is 37. M into 3.7. Your mass comes out to be what? 37 divided by 3.7. This is equals to 10 kg. 10 kg is your mass. You have to calculate the weight on the surface of the earth. Weight is equals to mg. Mass is 10. What is the gravitational field strength? What is the gravitational field strength? 9.8 on earth. Multiply it. 10 multiplied by 9.8. This gives you a value of 98 Newton. State what is meant by a moon. A natural object or a natural satellite. A natural object that orbits around a planet, orbits around a planet, or you can say around Earth. Simple. The sun will eventually run out of hydrogen. Describe what happens to the sun when hydrogen runs out. The sun expands and becomes a red giant star. Becomes a red giant star. Perfect. Later, it gets converted into planetary nebula. Planetary nebula. And after energy losses, it converts it converts into a white dwarf. Simple as that, nothing complicated. Let's see the marking scheme as well. Yeah, simple. Let's see this. Figure 8.1 is a picture of a nebula formed from a supernova. Very good. State what is meant by a supernova. Explosion. Explosion as the hydrogen in the red supergiant runs out. You can say as the, or you can say explosion as the hydrogen, as the hydrogen in red supergiant runs out. Red supergiant runs out. Simple as that. Describe how a protostar forms inside a nebula. So, what will you say? What will you say here? How a protostar forms from a nebula? You will say cloud of dust and gas comes together. Comes together due to gravitational pull or gravitational force of attraction. They collapse due to gravitational force. They collapse and cause an increase in temperature. And cause an increase in temperature. Increase in temperature. Simple as that, nothing complicated. Let's further move ahead. Our sun is in circular orbit around a black hole at the center of our galaxy. State the name of the galaxy that contains our sun. Milky Way. Milky Way. State what is meant by light year. Light year is the distance traveled by light in 1 year. Distance traveled by light in 1 year. Simple as that. Let's further move ahead. The time taken for one complete orbit of our sun around the black hole is this. Okay. Let's suppose this is a black hole, and let's say the sun is orbiting like this around the black hole. Perfect, perfect, perfect. So this is your time period. Okay. The distance from our sun to the black hole is 26,000 light years. So this distance is what? 26,000 light years. Perfect. 1 year has this many seconds and the speed of light is this. Calculate the speed of the sun as it orbits around the black hole. Show your working and give your answers in meters per second. So you have to calculate what? Orbital speed. Orbital speed is equals to 2 pi r divided by the time period. Now what will be the r here? 26,000 light years. But how will you calculate the distance in 1 light year? The distance in 1 light year is very easy to calculate. Speed of light multiplied by the amount of seconds in an year. So the speed of light is 3 into 10 raised to the power of 8 multiplied by 3.2 into 10 raised to the power of 7 divided by the time period, that is 7.3 into 10 raised to the power of 15. Let me zoom in a bit and tell you again what have I done here. So I have to calculate the orbital speed of sun. 2 pi r. What is r here? R is 26,000 light years. So I took this 26,000, multiplied it by the speed of light, and then multiplied it by the amount of seconds in 1 year to calculate the distance between the black hole and the sun. Can you calculate the orbital speed here? Yes, very, very easy. The orbital speed comes out to be 210 100,000 meters per second. Simple as that. Let's further move ahead. Okay, let's see this. The Earth has a radius of 6.4 into 10 raised to the power of 6 meters and rotate on its axis once in every 24 hours. Okay. Figure 9.1 shows that as the Earth rotates, objects on the surface of the Earth move in circular paths around the axis of rotation. Perfect. Calculate the speed of an object at the equator as it moves in a circular path around the axis of rotation. We have to calculate the speed of the object. So again orbital speed formula 2 pi r over time period t. What is r here? R is 6.4 into 10 raised to the power of 6. 6.4 into 10 raised to the power of 6. What is the time period? 24 hours. 24 into 60 minutes in each hour into 60 seconds in each minute. Can you calculate the orbital speed here? 2 pi into 6.4 into 10 raised to the power of 6 divided by what? 24 into 3600. Your answer comes out to be 465 ms minus 1. Let's further move ahead. Explain why the speed around the axis of rotation of an object on the earth decreases as the distance of the object from the equator decreases. So let's say now your distance from the equator is decreasing. Let's say you are at this point. Let's say you are at this point B. If your distance from the equator decreases, what happens? Your radius decreases. Your radius around the sun decreases. As your radius around the sun decreases, your velocity will decrease. So you can write it here as radius of orbit decreases while keeping the time period constant, while keeping what constant? This time period t constant, while keeping time period t constant. This causes the speed to decrease. This causes the speed to decrease. Simple as that, nothing complicated. The earth moves around the sun because a force acts on the earth. State what provides this force? The gravitational field strength of the sun. The gravitational field strength of sun. Simple as that. Let's further move ahead. The orbit of the earth around the sun is an ellipse. Perfect. Describe what happens to the magnitude of the force that acts on the earth as it moves in its elliptical orbit. So, how does an elliptical orbit look like? Let's say this is your sun and your earth will move in an elliptical orbit like this. Let's say this is your earth. So, the points where the earth is closer to the sun, let's say point A, the earth will experience a greater force. The points where earth is away from the sun, it will experience a lesser force. So you can write it here. State what happens to the magnitude of the force that acts on the earth as it moves in this elliptical orbit. The magnitude of force changes. Magnitude of force changes. As earth comes near to the sun, near to the sun, force increases, force increases, and as earth moves away from the sun, force decreases. Away from the sun, force decreases. Simple as that, nothing complicated. Explain why the earth travels the slowest when it is at the furthest distance from the sun. If the earth is at the furthest distance from the sun, what will happen? Gravitational potential energy will be maximum. kinetic energy will be minimum, hence velocity is minimum. So you can write it here. When the earth is furthest away from the sun, gravitational potential energy is maximum, kinetic energy is minimum, hence velocity will be minimum. Hence velocity will be minimum. Simple as that. This marks the end of space physics past papers. If you have any question, you may ask in the chat.